Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So basically in this course we are going to talk about the basics of data science. So this part of the course is really theoretical. We are going to talk about the theory behind data science and everything that you guys need to know about this subject. So let's start. Alright, so basically what is data science? So when we ask someone what is exactly data science or how it works or anything else, well, it looks very fancy and the word data science looks really fancy. But basically data science is simply the study of data. Yes, you have a lot of positions that can exist in data science. We're going to talk about them a bit later. But basically, data science is really the study of data. So data science can starts as early as the recording part. So let's say, for example, you have a project and you want to find out a solution to a certain project. So the first thing that you want to do is recording the necessary data to be able to answer to the problematic inside of your project. So basically, let's say, I don't know, you want to know how many, well, you give a survey to some people, and those people fill up the survey. So let's say there are people who fill up the survey and I don't know, 100 persons say they like the color blue. And let's say of those 100 persons that like the color blue, I don't know, 80 persons said that they like hamburgers as well. So you can link up hamburgers with the color blue and say in majority of cases, people who like the color blue like hamburgers. So you can, for example, create, well, this could help you for marketing, for a lot of purposes, but this is basically data science. Like, this is a really basic example of what data science can do. So the study of data can start as early as in the recording phase. Recording phase could be, for example, giving people questionnaires where they, for example, well, surveys that people can take. So for example, do you like the color blue or do you like the color red? And once again, those surveys are linked up with your problematic. So very important, you at first need to have a problematic that you want to solve, and for this problematic you need a certain data from certain people, and you will give them, for example, surveys. It could be surveys, it could be just ask them questions. There are plenty of ways that exist to be able to record data. The next step would be storing the data, because once you have the data, you need to store it somewhere. You don't know if you have the data physically. If, for example, it's on papers, you need to store this data, so you need really a storage room. If it's gonna be stored on the hard drive of your computer, if it's really huge amounts of data, maybe it's gonna be stored somewhere on a server, maybe it's gonna be stored on the cloud. So data science is really all those elements together. Next thing would be analyzing this data. So once again, analyzing all the analyzed parts. So you want to take the raw data and you want to transform it into data that you can use to be able to fix your problematic. So basically this part is really important, and in majority of times people know only the analyzing part, but they don't know the storing and recording part. But all this is part of data science and of the study of the data. Data transformation, so the second part right here is just another part of data science. So basically data transformation could be part of the analyzing part right here. Basically data transformation is part of data science, and in this case this could be extracting the right information. So when we're talking about data science, as I said, we work with huge amounts of data, so you can have millions, if not billions sometimes, datas of people's, depending of what type of problematic you want to fix. For example, we're talking about marketing or specialized ads. For example, when Google is able to give you like perfect ads for you, it will collect data on you, and with those patterns and with all the data that they collected, they took this raw data and they transformed it, and after that they are able to know exactly what type of advertising they will give you. So really extracting the right information to be able to, well, after that, transform it. Gaining insight and useful clues to run efficiently a project. Once again, right now I'm talking about Google, but it could be anything else. It could be, for example, in the manufacturing field. For example, I don't know, if you collect, if on a machine, for example, let's say the data is collected on real time. Let's say, for example, data is collected on real time. Let's say we spot a problematic each time that I don't know, there is there is a certain piece that is created, or there is 100 pieces that are created on this machine, and there is a problematic each 100 pieces. Well, with data science, we are able to spot this problematic and say, okay, each time that this machine creates 100 pieces of something, we need to make maintenance on this machine if we don't want it to break. Then data science can also be used to predict certain outcomes. So once again, data science can be used in plenty of fields, and predicting outcomes could be, well, for example, in the banking world, in the financial world. It could be as well in the manufacturing world, in marketing. So as I talked a bit earlier, right now, this could be part of it. So for example, giving specialized ads or ads that are perfect for you, this could work as well. So this is for what is data, where data science is used. Data science is used in many fields. Those are just some examples. So for example, for online businesses or e-commerces, which is really popular right now, we can say that data science could be used to recommend products. So product recommendation, better marketing as well. If, for example, you need let's say a certain business wants to market the right products to the right audience, well, it will help them. So as I said, if, for example, you go on Amazon right now and you start Googling a certain product, so you write down a certain product on Amazon, well, Amazon will take this data and will give you products that are recommended based on your past researches. So this is all data science. Healthcare, for example, you can use data science in healthcare in a lot of ways. So for example, virtual assistant, let's say, for example, there are assistants that are virtual, not real right now, and this could be an amazing way to to use data science. It could improve medical researches. Since we have a lot of data, we have a lot of knowledge about a certain subject. For example, if we see that this medication this medication tested on 1,000 people help them with this and this and this symptom, for example, this could be pretty much a good thing. For image analysis, so in this case picture analysis, this could be a really good thing as well in the healthcare world. In the banking industry, for example, for fraud detection, it's not an employee that is sitting in his office and looks for frauds. It's complex algorithms that are created and that works for fraud detection, and it's all about data science and machine learning, all those stuff, to create credit scores, for example, and to give the right product to the consumers. Yeah, there is a little mistake right here. So giving the right product to the right consumer, especially in the banking world, sometimes it's it's not really easy, because some customers have millions of dollars, other customers don't have money at all. So it's really it's really different, and you can't offer a type of product that you offer to the other one. For transports, for example, GPS optimization, in this case it's going to be, let's say, for example, you want to go from place A to place B, how to go the fastest way possible, and the really real-time optimization. So in this case, it's all about data science. For example, it will know that there is traffic at this place, and it will not suggest you to pass by this place or this place. Self-driving cars could also be an example of how data science can be used, because once again, this is a huge amount of data that is collected to make the car driving alone. Personalized virtual assistant, once again, it's like the healthcare part. For manufacturing, as I said before, we have problem detection that could be really an amazing way, and the problem prevention, as well as automation. So let's say, for example, you want to automate your production. It's possible with data science. So for example, with all the data that is collected, you are able to hire engineers. Data engineers will be able to create machines that will automatically work and will automatically, let's say, for example, work on huge scales. So let's just take a basic example. Let's say a huge business that is, I don't know, putting water inside of bottles. So it's all automated. There is no one person that is like putting water in each bottle. It's really a huge machine that is automated because of the use of data science once again. In finances, it's really used in algo trading, so algorithm trading, sorry. And this is all algorithms that are created based on past performances of a certain stock or ETF or whatever. And it's based on all this past data that algo traders are able to create programs that will trade by themselves and really control the risk, create all the strategies around their trading style, which is pretty much a very cool thing. So those are some uses of data science, but it can also be used in engineering. It can also be used in agriculture. It's used pretty much everywhere, and it's really part of our lives right now. All right, so next thing is about the data scientists. So basically, what are the skills that you will need to have? So for me, once again, this is based on my personal experience. You need the 3 skills, even if you don't necessarily have them now. You can work on them. So basically, logical thinking and mathematic understanding. So data science is all about mathematics. So there is a lot of numbers. There is a lot of, you work always with numbers. So if you're bad in mathematics, well, I'm sorry to say that, but it's going to be a bit hard for you. So really having a good mathematic understanding and logical thinking, because mathematical understanding is linked with logical thinking. So you need to understand basic logical concepts, and with those basic concepts, after that you can put them on higher and higher scales and create something that is pretty cool. But just understanding the basics sometimes, well, the moment you understand the basics, you will be able to go further and further. Understanding the business world around us, because data science is not just a thing that you play with. Data science is really something that you will use to solve real problem issues. An example, let's say for example, you want, the first step in data science is really to find out the problematic that you can solve. You will not just collect data to collect data, because this don't make sense at all. This would be raw data that will not be used, and doesn't make sense just collecting data for collecting data. If you collect data, is to improve something, is to reach a certain goal or a certain objective. This is why you need an understanding of the business that is around us, the business world that is around us, because in the majority of times the use of data science would be done inside of business worlds. Interest in technology and programming. Data science nowadays, mathematics is the first part, but programming and technologies are the second part. As I said, data science is not only in the analyzing part where you analyze numbers. It's it starts way from the moment that you guys give surveys, for example, and you collect data and store data. So you need to understand all the technological parts around this. What are the things that you can use, for example, to store your data, how you can collect your data, and after that, all the techniques that you can use to analyze properly your data. Yes, the more you work with the data science, and the more you analyze data, the more you will create your own techniques, and you will have your own ways to analyze data, and you will see it's not something that is that complicated. At the end of the day, it's just logical thinking. It's 100% logical thinking, honestly. Data science jobs, you can have a lot of data science jobs that are not listed here. I just listed 3 examples. For example, data analysis, database administrator, or business analysis. Those are the jobs that come to me quickly right now. But you could have, for example, data engineer, you can have data scientist, you can have business analyst, you can have statistician. So there are plenty of other jobs that are linked with the data science, which is pretty cool. So you'll see this field is pretty cool. So the basics of data. So right now we are gonna talk a bit more in depth about the basics of data and the data life cycle. And basically in this case, there is 6 steps that we need to follow for data. So just for you guys to understand how exactly it works. So it's pretty simple. The first step would be, let's say, for example, you are in a business, and the first step will be identifying the problematic that you want to solve. So let's say, for example, I don't know, let's take just a really basic example. Let's take our example of hamburgers. You want to create a new packaging for your hamburger. So let's say, for example, you're working for, I don't know, a hamburger store, and you have thousands and thousands of consumers, and you give them, I don't know, surveys. Let's say it's online surveys, and they fill up their surveys. So you have your problematic. Your first step will be identifying your problematic. So your problematic is, I want to create another packaging for my hamburgers. Then the next step would be finding a way to collect or acquire data. So you can collect yourself your data, or you can ask a business to acquire data for you. Yes, you would need to pay a certain fee, but once again, if you are a big corporation, you don't really care about paying those fees, because at the end of the day, you will make profit because of all this research around it. So the second step will be finding a way to collect this data. So the first step, well, the first thing that you need to understand here is what data you need. So basically you need to understand the data that you guys will need to collect. Because if, for example, you want to change your packaging, you will not ask your consumers, do you like it when it rains outside? It doesn't make sense. So for example, you will ask them, hey, do you prefer blue or red, for example? So they will answer the question. Next step would be thinking about where I can find this data. So once again, you can acquire it. You can buy it from, let's say, another business already did this research. You can buy it from the business. Well, you can buy it from the company that did the research for that business, or you can go and collect the data by yourself. And then the most efficient way to obtain and store this data, because once again, this is part of the first step. So you'll think about a good way to, well, an efficient way to collect this data. If you want to collect it by yourself, you'll think about an efficient way to collect this data. It could be, for example, giving surveys to your consumers when they come to your restaurant, or it could be sending them emails where you tell them, hey, you'll get a free hamburger if you, for example, fill up this survey. All right, step 3 would be data transformation. And in this case, you want to put your data into the right format. And you will clean your data. So let's say, for example, you have surveys that are not filled up to the maximum. You want to clean this data, all the missing values, you want to take them away. You want to compile all the data, so put everything together. All the corrupted data, all the duplications, you want to take them away. So let's say, for example, someone filled it up the survey like 5 times because he wanted 5 free hamburgers. Well, you will only count it as one person. And removing unnecessary data. So let's say someone just wrote, I don't know, anything inside of his survey. Well, you just take him away as well. Next step is when you have all your data ready. This at step 3, you have all your raw material. So in this case, you have all your raw data. Now it's time to understand it and transform it and create a solution to your problem. So once you have all the raw data, you want to understand this. So you will make hypotheses. So let's say, for example, you will say, hey, that's the thing that we talked about before. So hey, 100% said they love the color blue, and 80% said they like hamburgers. So basically, if it's this way, this means that everybody who eats a hamburger, or the majority of people who are eating a hamburger, likes the color blue. So basically, maybe this could be a good thing to have a blue packaging for my hamburger. So this would be making a hypothesis, and at the same time understanding the data pattern. So we get our data. So we have our data, and we understand that this brings us to this. And this is where you really need logical thinking. Once again, this is a really basic problem. Sometimes they're way more complicated. So this would be for the 4th step, really understanding the data. So hypotheses, you will make them there. And once again, understanding all the patterns around the data that you have. Step 5 will be modeling your data. So once again, you will create a model around this data. So in this basic example, it will be, for example, creating packages. So let's say you create a blue package in this case. You want to evaluate the efficiency of your model. So let's say, for example, you create those packages and you give them to your consumers, and if they're happy, well, this would be a good way. So once again, you will deploy, but once again, since our example is really simple, let's say we stay with this example, you will deploy but on a small scale. So let's say, for example, you will deploy 1 day a week. So you will have your new packaging 1 day a week, and you will give it to your new consumers. they will be able to see it, they will be able to use it, and who knows, maybe it works perfectly. So when all this works perfectly, so you are in your step 5, if you see that your consumers are happy, your sales are going up because you changed the packaging of your burgers and they're blue now and everybody is happy, it's time to go to the step 6, which is launching the solution or launching your model on a larger scale. So let's say you have few restaurants, so instead of launching your model on only one restaurant, you will launch it on more than one restaurant or inside of all your restaurants. The best way to do this is really going step by step. So when you reach the step 5, you launched your model or your solution inside of a small scale. And the next thing would be inside of a larger scale. So you always want to limit your risk. So never launch at a whole scale straight up, because what can happen is that you could have problems or anything could happen, and your solution will just break. So you launch on a small scale and you slowly grow your launching process. And if everything goes the right way, this means that you can just launch it faster. So those are the 6 steps inside of data, in the basics of data. Those are the 6 steps that we need to follow. So really from finding the problematic to launching the solution. Once again, I gave a really basic example. So this is really for the basics of data. Right now, we will jump inside of the course. We are gonna start talking about the tools that are used inside of data science. And you'll see basically this course will teach you all the basics about this subject, and you will have a lot more knowledge when this course will be done. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. In today's class, we are going to talk about one of the first tools that we are going to use in this course to be able to perform certain tasks. So this tool is pretty simple. It's called the Anaconda Navigator, and this Anaconda Navigator will give us access to Jupyter. So basically in today's class, we are going to learn how to install it and how to use it and what it's supposed to look like. So basically it's pretty simple. What I'll ask you guys to do is simply go on Google and write down Anaconda Navigator. And the next thing that you guys want to do is go into installation. When it's all done, what you want to do is simply click on installation right here. And from this moment, simply select for what device you want to install it. So it could be for Windows, for Mac, for Linux, or anything that you want. So let's say you want to install it for Windows, simply click on install it for Windows. And then pretty simple, it's going to be on the first one, download Anaconda installer. You click on it. And then simply click on download. So when it's all done, you should be able to have access to Anaconda. So you download the installer, and after that you will set up Anaconda on your computer. Very important, you need something around the 3 gigabytes of storage space to be able to download it. So be sure to have 3 gigabytes of data when you download this application. So let's see what it all looks like. So basically when you download the Anaconda Navigator, it should look something like this. So basically you have your Anaconda Navigator up there. You will have different applications. So for example, Orange, Notebook, PowerShell. I downloaded PyCharm to be able, this is my, what I program in Python. I use PyCharm. So it's gonna be right here. If you have any other text editor, you will have it somewhere right there. Of course, you work with Python. So what we are going to do, we are going to work with the Jupyter. So I'm not gonna launch it, I'm just gonna talk a little bit about it. So basically what Anaconda is pretty much a desktop GUI. So the Anaconda Navigator will come with Anaconda Individual Edition, and it will make it easy to launch different applications. So as I said, PyCharm, for example, RStudio to program in R, Orange, and anything else. GIU stands for Desktop Graphical User Interface, and basically Jupyter is the notebook that we are going to use. So before, people used notebooks to be able to work with data science, so they wrote all their notes right there. But we are going to use Jupyter. which is very well, it's gonna be very easier to work with Jupyter than to work with a physical notebook. So any app related to programming will be that you will download on your computer will be also on the Anaconda navigator. So this tool is really important if you guys want to continue in data analysis. So this is for the download and setup part. So when you have downloaded the Anaconda navigator, the next thing would be to work with Jupyter. And this is what we are going to talk about in our next class. So that's it for this course, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about data analysis with Python. So basically, until now we just talked, we had an introduction to data analysis. And now we are gonna talk about the first tool that we are gonna use in practically, and this is the Jupyter Notebook. So in today's class, we are gonna talk about all the theoretical side of this app, or well, of this tool that we are going to use. And in the next class, we are gonna practice by writing down some lines of code in Python, of course. So let's start. Basically, it's pretty simple. The first thing that you guys would need to do is open up your Anaconda navigator and then go into your Jupyter Notebook. So just click on launch, and what it's going to do, it's going to open up a folder directly on your internet browser. So very simple. The first thing you need to understand, guys, is how everything works. So basically you have 3 tabs right here. You have your files, your runnings, and your clusters. Basically your files are all the files that are imported from your computer. So right here I have all my files that are imported. Running is all the files that are right now running. So in this case, if you have any terminal, any Python terminal that is running, or any notebook that is running, you're gonna see it inside of your running, and those are your cluster. So basically, let's come back to our file folder, which will be our most important one. So basically, if you want to select files, well, it's pretty simple. You can just click here to select them. To see the type of files that you guys can have, in this case, you can have folders, which everybody should have. So all the folders that you have on your computer. So if you want to select all the folders, simply click on the folders and you will be able to select them. The second one will be the notebooks that you can maybe have. So if, for example, you created some notebooks for past Python projects or any data analysis projects, you should have them here. As you can see, I don't have them, but if you do, well, it's possible. Next thing would be your running. So all your running notebooks or running Python apps should be here. Once again, I don't have some, so you can't really see them. I have 0. And finally, all the files that are open. So in this case, I only have one, advanced IP scanner. So in this case, this is the only file that I have running. So if you guys have some other files, well, you will be able to select them this way. After that, when you select the file, you can do a lot of things with it. You can rename it, you can move the file, you can download it if you want to download it. You can view it, you can edit it as well, because it's on your computer directly. So it's pretty cool. Those are really the basics of it. After that, here you can place your files by name. So once again, it's pretty simple, by date or by file size. If you guys want to upload some new files, it's pretty simple. It's going to be here. So you simply click on upload and you will be able to upload any new file that you want. If you want to create a new folder, you can create a new folder. You will be able to create, well, a simple folder, or it could be something pretty cool, like for example, a Python 3 folder. So right here, it will be inside of a notebook. So you simply click on it and you will be able to create it. You can create a text folder. So in this case, it's going to be automatically saved. You can create a folder, so once again, a normal folder like this one right here. You can create it and it's going to be automatically named unnamed folder, or untitled folder. I personally don't remember. And finally, you can generate a terminal. So once again, if you want to work on a terminal, you can do it. Last thing right here, if you want to refresh everything, you can do it simply by clicking this button right there. And basically, until now, you guys try to understand why we use Jupyter. Well, basically, the workflow inside of a data analysis project is pretty simple. The first step will be to create a notebook for your project. So in this case, we are, well, not right now because we're just talking about the theory part. But basically, the first thing that you guys will do is simply creating a notebook for your project. So in this case, you'll write down your code and everything. After that, you will add analysis, step coding, and the outputs to your notebook. So absolutely everything would be here. And finally, you will add your business and all other analytics to your notebook, which will complete your project as a whole. For the security of Jupyter, since it becomes more and more popular on the internet, or well, it's a popular tool, the security that this tool uses, well, they have some security models that are in place. The first one would be untrusted HTML will always be sanitized. This means they will clean all untrusted HTML. So if you have any HTML code that is not clean, it will be sanitized. JavaScripts that are not trusted will not be executed. So once again, if you have some external JavaScript, it will not trust it and will execute it. All HTML and JavaScripts that are in markdown cells will not be trusted. So very important to know that HTML, JavaScript, and the JavaScript that are in markdown cells are not trusted. The output that are generated by the user are trusted. So everything that you guys will create and generate at the end, let's say at the end of the project or at the end of a certain part of the project, will be trusted, because once again, this is you who created the project. And any other HTML or JavaScript, it could be in markdown cells, output generated by others, or anything related that it's not you who created personally, will never be trusted. So let's say, for example, you import a project that someone else created on your project. Well, it's not going to be trusted because it's not like you who created it. So this is for the security model around Jupyter. So right now you guys have some basic and really low and basic knowledge of Jupyter. So you know how everything here works. So basically to import documents and how to store documents and everything. The next step will really be to work with Jupyter, and this is what we are going to talk about in our next class. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to our second class of our introduction to Jupyter. So basically in today's class, we are going to learn how to work with Jupyter, and we are going to write down some basic lines of code. Once again, before starting this class, I highly suggest you guys to have some basic knowledges of Python, because we are going to write down our first lines of code. Of course, I'm going to explain them to you, but once again, to be able to follow the course and not focus only on Python, you guys should have some basic knowledge. So let's jump right into it. The first thing that I'll ask you guys to do is open up your Anaconda navigator and launch your Jupyter notebook simply by clicking on the button right here. So when it's all done, it's gonna be launched. Next thing that we want to do is pretty simple. We want to open up a new folder. So in this case, it's gonna be a Python tree. When it's all done, we'll simply give a name to our folder. Let's call it project in this case. Here we go. So the first thing that we are going to talk about right here is pretty simple. We are going to talk about how works the Jupyter notebook and what exactly you guys can do with it. Well, how exactly you can work with it, and what is the difference between the Jupyter notebook and any other text editor. Well, text editor, for example, like PyCharm. So let's start. Basically, the first thing that you guys have inside of your Jupyter notebook, this would be your main page. You will have the buttons right here. So to be able to save your changes, pretty simple, you simply click on the button right here, and usually it's gonna be automatically saved. So as you can see, the auto save mode is activated, so it's gonna be automatically saved. Then in your PyCharm or any other text editor, you usually don't have cells. Inside of your Jupyter notebook, you have cells. So there is not only one cell, you can have more than one cell. For example, if I want to add a cell, it's going to be by clicking on the little plus sign right here. So pretty simple, I can add as many cells as I want. And it's pretty cool because it allows me to really organize my code. So let's say I want to write down a function right here. I want to store some variables right here. I want to write down another function right here. And which is pretty cool is that I can move my cells from up to down. If you guys want to duplicate your cells, well, first of all, if you want to delete your cells, it's going to be there. So simply click on the scissors. If you guys want to duplicate your cells, it's going to be here. So you can select a copy cell and you can copy your cell. So let's say, for example, we have a cell right here. We will write down something simple. So a simple function. Let's print pizza, for example. Here we go. I have my function. So I run my function. I have pizza right here. Let's say I want to copy this cell right there, and I passed my cell. And as you can see, it has been copied and passed it down there. All right, so pretty simple. If I want to move my cells, so let's say I have more than one cell, I have a lot of cells, I can take this code right here and move it from up to down. So right now I have absolutely nothing. I just have a print function with pizza inside of it that doesn't mean nothing. But let's say, for example, I have variables right here that I want to work with them down there. I can do it. I can just have my variables here. And let's say I want to put them down there. Here I have a function where I want to take a function and move it somewhere higher or anything. I can move my cells how I want, which is pretty cool in this case with Jupyter. All right, next thing to run our apps, to run our code, I mean, it's going to be just there. You simply click on the run button. If you want to stop the code that is running, it's going to be on the little interrupt button right here. So this is for the basics of, of Python, of Jupyter, sorry. So it's pretty simple. As you can see, it's pretty simple to use. Next thing that we are going to talk about would be our first Python lines of code. So how exactly can we work with it? So as you saw some seconds before, in this with the Jupyter, you don't have a terminal down here like you do in, for example, PyCharms. So basically, if you write down your code, it's gonna be printed right under the cell right there. So just for the purpose to understand how Jupyter works, and for the purpose of everybody who is in the course and maybe don't understand Python that much, we'll write down a very simple line of code, and I will explain really the basics of Python, which we'll talk about variables, numbers, and booleans. So let's try it out. The first thing that we'll do is simply create two variables that are strings. So in this case, let's say we will call it name1 and name2 and name0. And in this case, let's name our name, well, our name variable will be pizza. So for those who never really programmed and are right now writing down their first lines of code, what I'm doing right now is I'm creating my variables, which is name and name2, and I'm storing strings inside of my variables. So I created two variables. The first one is called name and the second variable is called name2. I have three types of variables, which could be strings or plain text. Strings are simply plain text. I have numbers, which can be 1 to infinite. So in this case, let's say we have quantity 1 and quantity 2. Those two quantities will be numbers. So in this case, we'll have number 2 and number 4. So as you can see here, I have my pizza, I have my pasta. Those two are strings. And those variables right here are numbers. It's possible to transform strings into numbers and numbers into strings, because when you write down a line of code, you can't use both strings and numbers at the same place. So if you try to run, for example, a sentence that contains numbers and strings, it's not gonna work. You guys need to transform your strings. If you wanna use only strings, you need to transform all your numbers into strings. So let's write down a very simple line of code. And in this case, this line of code right here. So what exactly this line of code means, it's pretty simple. First of all, what exactly do I want? So when I write down, well, let's start by print. So first of all, I have my print function. I give the order to print something. So what I give the order to print? I give the order to print I want. So this would be the first part of our function. This is just plain text. This is a string. What I want exactly, I want quantity 1. So quantity 1 in this case is the number 2. Why I wrote a str right here, this is the function that we use to transform numbers into strings. So as I said, we can't have strings and numbers inside of the same sentence. Then what exactly do I want? I want quantity 1 plus name. This means I want 2 pizzas. So we have our quantity 1, which is 2, plus name, which is pizza. Plus we have our plain text or our string end, and in this case we just put it inside of those little parentheses. Plus I want quantity number 2. In this case it means 4. Plus name 2, in this case it means pasta. So if we run our app, logically it's gonna give us I want 2 pizzas and 4 pastas. So let's try it out. As you can see right here, we have an error sign. So why exactly do we have an error? It's pretty simple. It's because it says quantity 1 is not defined. Pretty simple. Let's try something else. So usually the error comes when you guys just don't add the little space bar. And as you can see here, it works. So pretty simple. The problem was simply right here. So there were no spaces. And this is how the error came. So this is a typical error with Jupyter that you guys can have sometimes. Just a little space button will make it work or not work. So really be careful about it. I'm not gonna give you a complete course of how to debug all errors, because once again, this is just a really basic line of code. So right now you guys understand how exactly works Jupyter. So it's pretty simple. Jupyter is, as I said, a text editor and well, a notebook. And you can use it to write down your lines of code. And right now you know exactly how it works, what all the buttons right here means, and how everything works. Don't forget to save your work. So pretty simple, you simply save it. So this way, next time that you connect to your Jupyter, you will be able to see your work. So in this case, if for example, we decide to click on X right here, we have our project, which is right there. We can just run it. So we can simply click on our project. And as you can see, we will have our project right here. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about data analysis and data science, the complete introduction with the use of Python. So in today's class, we are going to have a complete introduction to the concept of data, to understand what exactly is data, how it works, and this way you guys will have a complete knowledge about this subject. So let's jump right into it. So basically, what is data exactly? So data is the concept of data. It can be something really general. Your cell phone, for example, when you click on your cell phone, this could be considered as data. When, for example, you are using, I don't know, your GPS, where there is data there. When you're typing something on your keyboard, it could be data as well. Basically, how we can see data could be seen as statistical sets or facts that can be used for analysis. So basically, let's say, for example, you guys are walking outside and you are making steps. Those steps could be considered as data because they could be used to know exactly how many miles you guys are walking each and every day. Let's say, for example, we want to calculate how many steps we need to do per day to be able to stay healthy. Well, the steps that you guys do each and every day can be counted to be able to say that, for example, you guys have walked 1,000 steps and you guys are healthy. Well, we can make an average of everybody who is walking and say that, oh, okay, in general, on average, each person that walks 1,000 steps a day is a person that is healthy. Basically, not only steps, but as I said, it could be absolutely anything that can be quantified, but not only quantified, because there are different data types that exist. We're going to talk about it a bit later. So principally, we can have numbers, as you can see here. We can have quantities, informations, measurements, facts, observations, graphs as well. But graphs, I see them more as a visualization tool because they allow us to see the big picture. So let's say, for example, we're talking about those steps as well. So how many steps you're making a day. So you will be able to visualize how many steps you guys are making per day with the graphs. Another thing that is very important to understand with data is that it have to fit four big things. First of all, it has to be able to be collected and stored. So basically, all types of data need to be collected and stored. So if it can be collected and stored, well, it's not really data. Second thing, it has to be measured. So basically the data that you collected, you can be able to measure it. So you can be able to measure it numerically or with any type of measurement. You should be able to analyze this data. Once again, you should be able, if we're talking once again about our steps, this can be considered as raw data. So this is really raw data. And those steps, we can analyze them to, let's say, for example, know how many steps someone who is healthy is walking. But we can analyze it once again, and instead of having this conclusion, we can calculate, for example, on average, how many steps each person makes per day. On average, how many persons per day are walking at least 30 minutes a day, for example, once again. And we can do a lot of analysis with all this. And finally, your data should be able to be visualized. So once again, those steps, you can visualize them on a graph or on any other tool that can be used in data analysis to visualize things, well, let's say your conclusions. So in this case, we can visualize our steps on graphs. So let's say day 1, the person walked this amount of steps. Day 2, this person walked this amount of steps, etc. So basically, this is for data. The second thing that we are going to talk about today would be the types of data, because once again, this is a huge part of our data part. So types of data, there are two principal categories of types of data. We have the qualitative one, or the categorical. Basically, it's the same thing. And you also have the numerical or quantitative data. So basically, the first type of data, which is the qualitative data type, is not really, there is like no numbers in it. You can't really measure what's inside of it with numbers. And the numerical or quantitative type of data is really all about numbers. So let's see what it all looks like. So the first step, as I said, would be the categorical one. And inside of the categorical one, we have the nominal and the ordinal data. So for the nominal data, basically, it's pretty simple. It can be used to label variables without providing quantitative values. So once again, let's say, for example, you receive a questionnaire where they ask you with what you prefer to write down, with your pencil, your pen, I don't know, a Sharpie, for example, or any other answer. Once again, you can't quantify the answer. You can only qualify this answer. For example, the person answers with a pen. So, okay, the answer would be a pen. If we say the number of pens, the number of persons that prefer writing with pens, this would no longer be a nominal data. The nominal data would only be the pen. The number of persons that prefer writing with pens would be another type of data in this case. Second thing, it could be, for example, another example that we have here. Let's say, for example, your favorite animal. This could be, once again, another type of nominal data. Why? Because, well, in this case, the animals, you can't quantify them. And once again, there is no numerical value to it. And another really important thing to understand the difference between nominal and ordinal data is that the nominal data is not ordered, but the ordinal data is ordered. So let me explain it differently. So for example, if we take our first example, which would be, let's say, do we prefer writing with a pen or a pencil? If I choose pen or if I choose pencil, there is no order between it. It could be a pen, it could be a pencil, it could be a Sharpie. All the answers are the same, but ordinal data would be a bit different. For example, let's have an example of ordinal data. Let's say, for example, I'm asking someone, do you like this type of exams on a scale of, let's say, for example, bad to excellent? So if the person doesn't like it, well, the person will say bad. If the person likes it, the person will say excellent. And as you can see, there is a certain order between those, those emojis. Here we have emojis, but it could be, for example, things like don't like, okay, fantastic. There is like a certain order. But if we ask someone the difference, if they prefer a pen or a pencil, or if they prefer a dog or a cat, there is not necessarily a difference between those. There is not no difference between one or the other variable. So we can't really see the difference. For us, it's pretty much the same thing. So this is for our categorical parts of data. As you can see, the main characteristics of those data is that they can be quantified, and they are really about about quality. So it's really about the qualifying something, not really quantifying something. All right, let's jump to the second part, which would be numerical and quantitative data. So basically, in those types of data, we have two types of data, which looks the same but are very, very well. They're not really different, but well, they're pretty much the same thing with some subtle differences. So for the discrete types of data, basically those would be complete numbers. So let's say, for example, it won't be an infinity of possible numbers. For example, let's take the age. The age of someone could not be, for example, 1.55349. For example, it will be 1 year old, 2 years old, 3 years old. The height of someone will be, for example, 1 meter 10 centimeters, 1 meter 80 centimeters, or 6 feet, or 5 feet 5. For example, it's something that is not infinite. For example, once again, for example, right here we can have sample versus consumer. Once again, here it's something that is that has an end. If we're talking about continuous data, so once again, just for you guys to understand, this would be a point on the graph. So there is nothing. For example, let's talk about the cost versus the number of tickets. If I buy one ticket, it's gonna cost me, for example, $20. If I buy 2 tickets, it's gonna cost me, in this case, $40. But I can't buy, in this case, 1.3 tickets, which in continuous would work. Because, for example, in continuous, you will have another thing, which would be, in this case, pound versus cost. And in this case, you will have, let's say, for example, there is an infinite possibility. So basically the difference between discrete and continuous is that in the discrete type of data, you don't have an infinity of possibilities, because right here, for example, we can have the age versus the height, and we have points, and those points are finite. So there is an end. So for example, we have age number 1, age number 2, age number 3, age number 4. In this case, it's different because we have an infinity of ages. Even if we have complete numbers, we have an infinity of ages. We have, for example, 1.345 years. If you guys get the point. So there is an infinity right here. So this is why we can see that there is, well, the line right here, that's a straight line. And here we have points. So that's the main difference between discrete and continuous type of data. So we have the discrete type of data. As I said, it's really finite, and the continuous type of data that could be considered infinite in the way that, for example, after the comma, so it could be, for example, the age of someone would be 30 years, comma, 5, 4, 3, 2, 1 year. Once again, that's just an example. So this is for what is data part. So right now, guys, you understand what exactly is data, how it works, the different types of data. So in this case, we talked about numerical, quantitative data, as well as categorical types of data. So I hope you guys understand all those concepts. As you can see, it's pretty simple until now. If there is anything that you guys don't understand, don't hesitate to simply rewatch this class, because once again, this is pretty simple. It's only the basics of what exactly is data. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science as well as data analysis with the use of Python. So in today's class, we are going to talk about a really important part of data science, which would be statistics. So basically, statistics are not the base of data science, but are a huge player in data science. Indeed, a lot of techniques, a lot of statistic measures are used in data science, and this is why it's really important. So in this class, we will just have a small introduction to statistics. We're not going to talk about all the statistic terminologies and all the statistics measures that are used, but just have an introduction to statistics. What is it exactly, where it can be used, and in the future classes, we are going to talk about the basics that you guys will need to have in statistics to be able to understand data science. So let's start. So basically, what is statistics? So if I go with a basic explanation of what is statistics, that's simply a branch of maths that will deal with the collection, analysis, interpretation, and representation of masses of numerical data. So basically you take a population and you will work with, let's say, a sample of this population. Indeed, it's possible to work with the whole population, but once again, this could be really complicated because it's not always possible to, let's say, for example, make surveys to the whole population. So we will work with the samples of population. So let's say, for example, we want to work with the, I don't know, with all the American population to know what is their favorite color, for example. So instead of asking all the American population, we'll take different samples. So we're not gonna talk about sampling in this class, but this is just an example. So you can take a sample, for example, from each city in each state. So this is just one example. And from that sample, since it's random people, we will be able to come to a conclusion that the favorite color of this sample is red. So we'll say that the favorite color of American based on a certain sample is red. So this is, for example, this is one example of how statistics could be used. And as you can see, this is some really basic data science things that we have here. Statistics could be used in many fields. So as you can see here, it could be used in education to know, for example, I don't know which, well, we can use statistics to see, for example, in which type of classes students perform the most or perform the less, and try to find out the problems in, for example, those classes. For example, let's say students have problems in maths in this field exactly, then we will try to find out the problem, why students have problems in this field. Maybe it's because of the way it's presented. Maybe it's because I don't know, students are just not motivated by this field. Maybe there is any, well, we'll try to find the explanation to this. And it's possible to do it with statistics as well as data science. But once again, statistics will be the basics of all this. It could be used in stock market, life science, weather, retail, insurances, and many other fields. Once again, it's not used alone, it's used with other mathematical fields as well as data science. So right now, we'll talk about the types of statistics. Basically, we have two types of statistics: descriptive statistics and inferential statistics. We are not gonna come into details of each of them, but I'll try to give you a brief definition of what are those two types of statistics and just give you a small example of what it could be. So basically, for the descriptive statistic, it will help us organize data and focus on the character of data providing parameters. So this would be for the descriptive statistic, and it's really used to, well, it's the use of data to provide a description of a population, either through numerical or graphs or tables. So this is basically for a descriptive statistic. And inferential statistic, it's a bit different. It's simply generalize a data set and applying probabilities to arrive to a conclusion. And the inferential statistics will make inferences and predictions about the population based on a sample of data taken from a certain population. So basically, let's say that we have wine. So let's say you guys are producing wine in huge quantities, and you guys want to know, well, you guys want to look at the age of your wine. So basically, with the descriptive statistics, the way you guys will stock the age of your wine, you will have the average. So you will have the average age of your wine. You will have the max. So the highest age of your wine. The min, so the lowest, the wine that is the less aged. And basically you will divide it into three categories like this. In inferential statistics, it's gonna be a bit, it's gonna be a bit different. You will still have your average in the center, but you will have a category that will be, in this case, aged wines, not max aged wine. So you will just have aged wine, where you will have all the wines that are aged more than a certain, let's say, age, and you will have less aged wines. So in this case, you will have, let's say, all the wines that are less aged than a certain age. So in this case, you will work more with the quartiles instead of just working with maximums and minimums. You can also apply this to, let's say, a population. So a population that is short or small. a population, so you want to know the height of a certain population. So in the descriptive statistics, you will have the highest person, you will have the max height, so you will have the highest person in the room, and the shortest person in the room, and you will have the average. So basically you have those 3 persons. And in inferential statistics, you will have a category that will be tall, a category that would be short, and you will have the average as well. So basically those are for the 2 types of statistics. Then why statistics are useful in data science. So basically they are really useful for plenty of reasons, but for me personally, I think that the 2 main reasons why they are really useful is that it will give you a basic understanding of different analyzing methods and techniques as well. So basically statistics brings to data science many techniques and methods that could be used in data science to be able to analyze way better the data. So basically this is why statistics are really important in data science. And as I said, statistics are really the base of data science, and this is why it's really important. The second reason is because it will allow data scientists to use many measures, such as those are just some of them. So you'll have the median, the mean, the standard deviation, and many more, to be able to make a complete analysis of something. Well, when I say something, it could be for example in the financial field. So let's say you want to analyze a stock, you can use the standard deviation, and this is something that is really important because for example, for a stock, a high standard deviation means that the stock is very volatile. A low standard deviation means that the stock will not move that much. And once again, this is something that comes from statistics and that can be used in data science. Once again, the median, for example, I want to find out the median of something. I want to find out the mean or the average of something. That's all coming from statistics, and it is very used into data science. So what you see here are just some graphs of some analysis that have been made. You will be able to perform those types of analysis. Those are simply results of analysis that have been made. I don't know what are those analyses, but those are just the results. So the results look something like this. And at the end of the day, this is a mix of statistics and data science put it together to be able to analyze a population or a certain data set, to be able to answer a certain problematic in this world, and to come to a conclusion about something, and to solve a problem. So because this is the main goal of data science as well as statistics in data science, to solve a certain problem. So I hope you guys right now understand why statistics are that important. Now it's time for us to start learning all the bases that will be really important for data science. Well, all the statistic bases that will be really important in data science for this course and for your future as a data scientist. So that's it for this class, guys, and see you all in our next class where we are gonna learn all those basics. Hello guys, and welcome back to another class of our course about the complete introduction to data science and Python programming. So in this class, we are going to have a basic introduction to some statistical concepts. So in the past class, we talked about what are statistics, and in this class, we are going to talk about some basic statistic concepts. So basically, the statistic concepts that we are going to cover in this class would be the sampling, and this is exactly what we are going to talk about. So let's jump right into it right now. So basically, it's possible, well, in statistics or in the world in general, there is a population. So let's say, for example, we want to study a certain population. We want to study, for example, the population of the United States. So to know, for example, if they love pizza. Once again, this is just an example. So we can ask each citizen of the US or each person who lives in the US if you love pizza by sending them a survey, by just asking them a question or whatever. So basically you can ask the whole population, but it's not possible to ask the whole population because first of all, it's gonna take too much resources to monitor, control and well, be able to ask the whole population this question if they like pizza, for example. And also because logistically it's almost impossible, and there is there will be no outcome. So basically you will not make more money by asking the whole population if they love pizza. So what exactly would we do? So instead of asking the whole population, we will ask a sample of the population. And this is where we have the difference between a population and a sample. So basically, as you can see here, the population will be the whole, all the US citizen, all the US population. And the sample will simply be a part of this population to who we will ask the question. So first of all, having a sample is way easier. So in this case, when you guys have a sample to who you will ask a certain question, it's easier to monitor, it's easier to control, it's easier to find a sample than to ask the whole population. Logistically, it's way easier, and usually the results are pretty much good. But there is a lot of different sampling techniques, and not all of them are perfect, but usually they work pretty well. So you have two types of sampling methods. So you have probability sampling method and no probability sampling method. Basically, the main difference between both of them, so probability and no probability, is that the probability sampling method will be based on selecting random people. So you will try to select the much random people as possible. And the no probability sampling method will not necessarily select random people always. So yes, you will have random people, but you will understand in the next few slides why it's not as randomized as the probability sampling method, which is based really on random people. Does it make the no probability sampling method worse than the probability sampling method because the people are not necessarily 100% random? No, but at the same time, it's not the best. So usually experts prefer using probability sampling method because it's based more on random people, and it's really, it's more randomized than the non-probability sampling method. But once again, sometimes it's way more practical to work with non-probability sampling method, even if it's not the best, than to use the probability sampling method. So let's understand what is exactly the probability sampling method and what are all the sampling methods right here. So basically in the probability sampling method, we have 4 sampling methods. So we have the simple random samples, the systematic samples, the stratified samples, and finally the cluster sampling. The simple random sample is basically, let's say for example you have a population and of 1,000 people, for example, and you want to select let's say 10 people. You need 10 people for your sample. So instead of saying, let's say, I don't know, I select him, I will select really random people of those 1,000 persons. So I will select, for example, I will select really 10 random people. And this would be really simple random sample. And this is really simple to do. So you just select 10 persons. The next one would be the systematic sample. It's pretty much it's not the same thing as the simple random sample. It looks like the simple random sample, but it's a bit more different. So let's say, for example, we have once again our population of 1,000 people, and we will give a number to each person. So let's say, for example, each person will be number 1, number 2, number 3 until 1,000. Then from that moment, let's say, for example, you select the person number 5, and from this person you say, okay, each plus 10 would be used inside of my sample. So in other words, you select person number 5. Then the next person in your sample would be the person number 15. So you'll take the person number 5, 15, 25, 35, 45. So as you can see in the picture here, you will select the person number 5, here person 25, 15, 25. And it's gonna be the exact same jump each and every time. For the stratified, so this is for the systematic sample. As you can see, it's not really complicated. So the next one would be the stratified sampling. This one is a bit different. So once again, it's based on random people, but you want to, let's say, for example, you want to have a clear, how you say it? You want to have a clear representation of each population inside of your sample. So let's say, for example, you have once again your population of 1,000 people, and you have 200 people who wear a green t-shirt and 800 people who wear, let's say, a blue t-shirt. So what you will do, you will select two, and you need a sample of 10 persons. So you will select 2 persons who wear a green t-shirt, and you will select 8 persons who wear a blue t-shirt, just to be able to represent properly each population inside of your sample. So you will not select just random people in this population, because let's say you have 5 persons who wear a green t-shirt and 5 persons who wear a blue t-shirt. This will not be representative of your population, because you have way more persons with a blue t-shirt. So in this case, let's say you select 8 persons with a blue t-shirt, but you will select random people inside of this population of 800 people with a blue t-shirt. So basically, the stratified sample is really selecting people, well, the right amount of people in each group. So basically, if you have a bigger group of people with a blue t-shirt, necessarily you will select a higher proportion of people in the group of people who have blue t-shirts. So this is for the stratified sample. The last type of sample that is in the probability sampling method would be the cluster sampling. And basically, this method is really, involves dividing the population into subgroups. And each subgroup would have similar characteristics to the whole sample. So in other words, instead of sampling individuals from each subgroup, you randomly select entire subgroups. So basically, what does this mean? It means you will work with let's say you have your population of 1,000 people once again, and this population, you will divide it into groups of, let's say, 5 people. So instead of selecting 1 person, you will select a whole group of 5 people. So it's like the random sampling, so the simple random sample, but instead of working with 1 person, you will work with small groups. So basically, this would be groups. So this is for the probability sampling methods. As I said, those methods are really into random, so you work with random people, and as those are really the most used by experts, because they are more representative of the population, and you will have more representative numbers in general with those sampling methods. So the second type of sampling methods would be the non-probability sampling method. And in this case, as I said, this one is not, it's a bit different from the sampling method, because you will work with people, not who you know, but that are more accessible to you. So basically, you will select the people with who you will ask, or to who you will conduct the survey, or whatever you want to do. So your study, let's say you want to study people who love pizza, so you will decide to who you will ask the question. So let's see those 4 sampling methods. So first of all, we have the convenience sample, which is the first one right here. Then we have the voluntary response sample, the purposive sample, and finally the snowball sample. So first of all, we have the convenience sample. This one is, the simplest. Basically, how it works, it's pretty simple. It's, imagine you, and you need a sample of 10 people. And you don't select random people, you just select people who you know. So in this case, let's say, for example, you have friends, and this is way more convenient for you to ask your friends to fill up the survey than to go and ask some strangers somewhere. So basically, this is the convenience sample. So you will ask, let's say, for example, your friends, your 10 of your friends, and you have your sample of 10 people. And here we go, you have your sample, and you conduct your study just with your 10 friends. But let's say, for example, the 10 of your friends like pizza. Once again, it's not representative of the whole population, because once again, you controlled the sample. So this is why it's not always a good thing. The second thing would be the voluntary response sample. This one is pretty much as the convenience sample, but instead of asking your friends, you will ask, well, you will ask people to answer, well, with surveys and everything, you will ask people to volunteer to respond to your sample. So basically you, let's say, come somewhere, you drop your survey, and people come and fill up your survey. Once again, this is really limited, and this is not really random and representative of the whole population, because let's say, for example, you're at the university, you come at your campus somewhere, you sit down, you put on your survey. You will not necessarily have access to the whole population or to a representative sample. You will have people, let's say, from one department who are studying at that department at that university, who will majorly answer your survey, which is not really representative of the whole population. It's just representative of the department where you conducted the survey in question. All right, so this is for the voluntary response sample. Then after that, we'll have the purposive sampling. So this method of sampling will simply involve the researcher using their judgment to select a sample that is the most useful to the purpose of the research. In other words, you select the people to who you will conduct the research. So once again, this is not representative at all, in my opinion. Once again, of in this case, if you wanna stay as random as possible, this is not representative at all. Why? Because once again, the researcher will select the people who, for him, are fit to conduct the research. So let's say, for example, you want to look for people who, I don't know, love pizza. And the researcher wants to have a positive, let's say, for example, a positive answers in his I don't know, his survey. So he starts asking people who he knows love pizza to answer his survey. So once again, the results will not necessarily represent the population in general. So basically, purposive sampling is just, it could work in some cases, that you really need some exact people, you need subjects that fits certain criteria. But if you want to stay as random as possible, it's not the best way to conduct a research. This is the third type of non-probability sampling method. And the last one would be the snowball sampling. So in this case, you will do the exact same thing. So it's gonna be, the way it works, it's like convenience sampling, but just with a snowball effect. So let's say, for example, you ask two of your friends to answer your survey, and you ask your friends to share your survey with some other people. So your friends will share your survey with people who will share your survey with other people, etc. So basically, as I said, it's like a convenience sample, but just with a snowball effect. In some cases, this could be really effective. So let's say, for example, you are studying a certain community somewhere in a country, and you know just one person inside of this community. So maybe this person, you can ask the person to fill up your survey and ask this person to, share, for example, the survey in his or her community. And in this case, you will be able to conduct your study on this community in general. Once again, this is not necessarily representative of the community, because it's maybe representative of the community in a certain place. So for example, you are studying, population of people who wear a blue t-shirt in the United States, but you are conducting your research, let's say, in New York City. So you ask someone to fill up your survey and since you don't know people who are wearing blue t-shirts, so this person who is wearing a blue t-shirt will simply hand your survey to other people who are wearing blue t-shirts. Once again, this is just an example for you guys to understand. So in this case, it could be representative, but until a certain point, and it's not like the best way to represent, to represent and conduct a random study, to represent the population in general, and to conduct a study. So this is for the sampling methods that exist. So as I said, you have 8 of those sampling methods. You have 2 groups of sampling methods. You have the probability sampling method and the non-probability sampling method. to understand the difference between both. The first one is really randomized, so you ask some random people and you work really with random people, which is more representative of the population in general. And the second one would be the non-probability sampling method, which is not necessarily worst, or which is not necessarily, well, it's more efficient and way easier to do, because you will ask, for example, friends, you'll ask people who you know. But once again, it's not necessarily representative of the whole population. It could work, it could bring you numbers. Once again, those numbers are not necessarily exact. So that's it for this part of the course, guys. Right now, you know the difference between all the sampling methods, and see you all in our next class. Hello guys, and welcome back to another class of our course about data science, the complete introduction. So basically in today's class, we are going to talk about the basics of statistics, and we are going to talk about some basic formulas. So really basic concepts. You'll see it's really easy to follow. So basically the three formulas that are going to be covered today would be the median, the mode, and finally the average or the mean. And as you can see, those are pretty simple, but yet really important in statistics. So basically the first thing that we are going to talk about today would be the median. And basically the median is simply the middle number inside of a data set. So let's take an example right here. We have 1, 2, 3, 4, 8, 9, 22. In this case, the median will be 4, even if it's not the center number. In this, well, the center number means the number between 1 and 22, which would be 11. In this data set, this is the middle number. So this is the number that is in the median. Well, in what is the median? Here, as you can see, it's the exact same thing. It's a perfect representation of it. So right here, we have a data set, and the median will be right there, because this is the number that is in the center. So basically, each time that we have a number that is in the center, no matter how big the data set is, this would be the median. So let's say, for example, we have 1, 2, 3, 4, and 1,000. Well, in this small data set, the median number would be 3, even if the average between 1 and 5 and 1,000 would be 500. But in this case, it's going to be, well, the median would be 3, because this is the number that is in the center. So this is for the median. The second thing that we are going to talk about today would be the mode. The mode basically is a bit different from the median, very simple to understand as well. Basically, the mode is the number that will appear the most inside of a data set. It's possible that we have data sets with more than one mode, and also it's possible that we have data sets with no mode at all. So let's say, for example, the data set right here, which is 1, 2, 3, 3, 3, 4, 8, 9, 22, 22. Basically, in this data set, the mode will be 3, because 3 appears 3 times in this case. And since it's the number that appears the most, this would be our mode. Same thing for 22. In this case, 22 is not the mode of this data set, because it appears 3 times. It appears only 2 times, and the number 3 appears 3 times. And if we didn't have the number 3, in this case, the mode will be 22. If, like for example, in this data set, we have 5 numbers and all the numbers appear only 1 time, there is no mode in this case. So we have in this data set no mode at all. And if, for example, we have here 3, 3, 3, and we had 22, 22, and 22 that appears 3 times, in that case, the mode would have been 3 and 22, because they appear the same number of times. So as you can see in this picture, this represents it really good. So basically, we have the number 10 right here, 30, here 50, here 70, and here 90. So basically, the number 70 appears 40 times, and this is why this would be the mode of this data set right here. All the other numbers don't appear as much. So if we had, for example, 90 that appears as well 40 times, 90 would have been a mode as well. So we would have had 2 modes inside of this data set. Finally, the last thing that we are going to talk about today would be the mean. And as I said, this is pretty simple to understand. Basically, the mean would be the average of a set of numbers that we have. So in this case, the example is directly here. So let's say we have 5 numbers. So the height of some people. Basically, the mode in this data set would be there is no mode. So since everything is the same, the median would be 1 meter 70 centimeters. So basically, in this case, 170 centimeters. And finally, the average or the mean, the way it's calculated, it's pretty simple. You simply make an addition of all the numbers that we have right here, and we'll divide it by the number of numbers. So in this case, we have 5 numbers or 5 entities. So we will divide it by 5. So the calculation is right here. What we have done is pretty simple. We made an addition of 150, 160, 170, 180, and 180 right here. So I made a mistake. We have a mode. It's 180 because it appears 2 times. I didn't say it. And finally, the answer would be 840 divided by 5 because we have right here, we have our 5 numbers. And divided by 5, it's 168 centimeters. So if I make a quick summary, it's pretty simple with this example. So first of all, we have the median, which is 170 centimeters. The mode, which would be 180 centimeters because it appears 2 times. So since it's the number that appears the most, it's our mode. And finally, our average, which would be 168 centimeters. And how we made the calculation, it's pretty simple. We simply made an addition of all the numbers that we had here, and we divided by the number of numbers, which is 5. So as you can see, those were the 3 basic formulas that we talked about today. So in the next class, we are going to learn some concepts and formulas that are a bit more advanced. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science and Python. So in today's class, we are still talking about some more statistical concepts, and this is what we will cover in this whole class. So we are going to talk about 4 very interesting statistical concepts that are very, very used in data science as well as in statistics in general, and that will be really interesting for you guys to know, once again, for the purpose of this course, but for your life in general as well. So let's jump right into it. So the first statistical concept that we are going to talk about would be the range. So basically, let's say you guys are in a data set and you want to know the range of the numbers that are in this data set. How exactly do you calculate the range of those numbers? So it's pretty simple. You take the highest number, so the max, minus the lowest number, which is the min, and this would give you the range of those numbers. So for example, in this case, as you can see, the max would be 8, and the min is, well, in this case, 4, because this is where it starts. So the range would be 4. So basically, if we read the definition, it will be the difference between the max and the min in a data set. So it will allow us to know what is the spread in the data or the data set that we have. So basically, the highest number that we have minus the lowest number that we have, and this would be our range. So in this example right here, the range will be 10. So the highest number is 12, and the lowest number would be 2. All right, the second thing that we are going to talk about would be quartiles, and basically this or percentiles. So basically, those things will allow us to know, for example, who is the 10% best or the 10% worst of something, or it's just a measure in statistics. So basically, this is a division of observations into 4 defined points. So you have the Q1, the Q2, the Q3. And as you can see right here, we have a graph of quartiles. So basically, the Q1 would be the 25th percentile. The Q2 is basically the median or the center. So basically, this would be the center. And finally, the Q3 would be the 75th percentile. So if we take a basic example of some numbers, like here, for example, we have the 2, 4, 4, 5, 6, 7, 8. So in this case, the Q1 would be 4. So it would be the 25%. The median would be 5. The third, the Q3 would be 7, so the 75th percentile. And the max would be 8, the min would be 2. So once again, these are just basics. But let's say you have a data set of 100 numbers. In this case, it's pretty simple. The 25th percentile would simply be the 25th number. The 50th percentile or the median would be the 50th number, and the Q3 or 75th percentile would be the 75th number. So basically, it's just a division into percentages. So the first 10% would be the I don't know, the 10th percentiles, so the 10th worst percentiles. All right, the next thing that we are going to talk about would be the standard deviation. And this is where it will be a bit more complicated because, well, the formulas are a bit more complicated. So first of all, what is the standard deviation? Basically, the standard deviation is the measure of variation or dispersion of a data set. It's something that is really used in finance as well, with the variation that we are going to talk about, well, the variance, sorry, that we are going to talk about a bit later in this class. So basically, the standard deviation works, well, with the data sets. And the way it's calculated, it could be calculated on a sample as well as on a population. So this is the formula basically. And what exactly does it mean? It's pretty simple. So we have the x right here. The x would be our number. So let's say, for example, we have a data set of 1, 2, 3, 4. So it will simply be 1 minus the mean of our data set. So in this case, it could be 1, 2, 3, 4. So the mean of 1, 2, 3, 4. All this at 2. So basically you make the square feet, so you multiply it by itself and you make the addition of everything. So it's gonna be, for example, in this case, if we have a data set of 1, 2, 3, 4, it's gonna be 1 minus the mean of our data set, everything multiplied by itself, plus 2 minus our mean multiplied by itself, plus 3 minus the mean multiplied by itself, plus 4 by it mean the minus 4 multiplied by itself, and everything divided by the number of numbers that we have. So if in our data set we have 4 numbers, it's gonna be 4 minus 1, which would be 3. For a population, it's a bit more different. Instead of making minus 1 at the end, so we will simply divide it by the number of numbers that we have. And at the end, it's gonna be the square feet of everything, the square root of everything. How to interpret the variance, the standard deviation, sorry. It's pretty simple. So basically, let's say you have a data set and you have a mean of 10. And in this mean of 10, you have a standard deviation of 2. So basically, if you add to your mean or your average 1 standard deviation, you have 68% of chances to be on target. If, for example, I don't know, you are, well, it's really used in the stock market. So let's say you want to predict your stock, it goes up or down by how much. So it's pretty simple. You will simply take your data, the data of the stock, and then you will simply calculate the standard deviation of this data. So let's say, for example, the mean or the average of this data would be 10 with a standard deviation of 1. So in this case, the price of your stock has 68% of chances to be 10 plus 1 or 10 minus 1. So it's going to be between $9 and $11 in the next, in the next X amount of times. So if you want to have 95% of chances to be right, it's going to be $10 plus 2 standard deviations. So in this case, it's going to be 2 multiplied by your standard deviation, or 10 minus 2 multiplied your standard deviation. So your stock would be between 8 and 12 in this case, because you have a stock that has an average of $10 and a standard deviation of 1. So it's pretty simple, and it's the same thing for 3 standard deviation. It's if you want to have 99.7% of chances to be on target, well, the price of your stock would be between $7 and $13. So those would be your extremes, or those would be like if you want to be sure to be 99.7%, having 99.7% of chances to be on target or hitting your stock price, you will add 3 standard deviation. Usually adding 3 standard deviation is not that much of a good thing, because it doesn't give you the opportunity to take risks, or your risk is really small, so the profit that you will make would be also really small. So this is for the standard deviation. The next thing that we are going to talk about would be the variance. So basically the variance is pretty much like the standard deviation. The only difference is that you will well, basically the standard deviation is simply the square root of the variance. So basically the variance is simply the standard deviation of at 2, so standard deviation multiplied by 2. So basically how it works, it does pretty much the same thing as the standard deviation. It's a measure of spread in a certain data set. So basically it works pretty much the same way as the standard deviation. So usually people don't really use it. People use the standard deviation, but it's also really important to understand. So as I said, the method of calculation is the same thing as the standard deviation. You have two methods of calculation for a population or for a sample. The main difference is the n right here, so it would be all the numbers that we have, or if you calculate it for a sample, it will be all the numbers that we have minus 1. So if, for example, you have a data set of 10 numbers, it's going to be 10 minus 1. You will divide it by 10 minus 1 at the end. And if we compare both formulas, as you can see for this standard deviation, it's pretty much the same thing. The only difference is that you have a square root. That is the only difference. So basically the variance is simply the standard deviation multiplied by itself. So it's pretty much the same thing. Well, with a difference because it's multiplied by itself, but at the end of the day, it gives us the same measure. It measures the spread of a certain data set. So this is really important to understand. So those were the things that we talked about in this class. So first of all, we talked about the range, which is simply the max minus the min. Then we talked about the quartiles, which are percentiles as well. So you have the 25th, the median, and the 75th percentile, which are Q1, Q3, Q1, Q2, and Q3. So quartile 1, quartile 2, and quartile 3. Then we talked about the standard deviation, which is a measure of spread in a data set. So measure of of spread. So you just to know what is the spread or how much something is volatile. So if we use it, for example, on a stock, it's a good way to know how much a stock is volatile and how much risk we are ready to take. And then we talked about the variance, which does pretty much the same thing as the standard deviation. But if you guys want to use something, for example, to predict stocks, once again, I really and highly suggest you to use the standard deviation, which is way better. So that's it for this class, guys, and see you all in our next class where we are still talking about statistics. Hello guys, and welcome back to another class of our course about the complete introduction to data science. Basically, in today's class, we are still talking about some statistical concepts, and one of the most important statistical concepts that is very used in data science is called decision trees. So once again, we can make a full 45-hour course about decision trees, but my goal here is not to, well, create a full course about decision trees and talking about all the mathematical concepts that are around decision trees, but just to give you guys a brief introduction so you will understand that it works, well, that it's really present into data science, machine learning, as well as all the things that are around those concepts. All right, so basically what exactly is decision tree? So if we talk about ourselves, we have a brain, and let's say we, for example, want to make a decision. So our brain is a huge computer. Let's say, for example, our brain wants to make a decision. So our brain will automatically create a decision tree. Once again, it's not gonna be like it looks like this. It's gonna be more different. And well, the brain will say, okay, if I make this, I will have this outcome. Or if I make this, I will have this outcome. For example, let's say you have the choice between eating healthy and eating, I don't know, a pizza, for example. So your brain will say, okay, if I eat healthy, what will happen? So the outcome, for example, if I eat healthy, I will be, well, I don't know, I will build muscles. If I build muscles, well, this will happen. If this happens, is it good or bad? Okay, it's good. Okay, if, for example, I eat pizza, what's gonna happen? Okay, I eat pizza, I will be satisfied right now because I just ate pizza. And once again, oh, I will be happy, but what will happen in the long run? Okay, if I eat pizza, I will be happy, but after that, I won't be happy anymore because I won't be in shape, etc., etc., etc. So basically how we can see decision trees, those are simply diagrams or charts that people use to show statistical probabilities or to determine the possibility for an action to happen. So basically you can see it just right here. So once again, I tried to find a very simple decision tree. So right here we have an example. So let's say, for example, A is lower than B. So if yes, then B is lower than C, and etc. And at the end, this would be our question, and we will be able to find out an answer that looks something like this, just with yes and no's. So at the end, with A is smaller than B. If it's smaller than B, we can say at the end that A is smaller than C, it's smaller or equal to B, or C is smaller or equal to A and smaller than B. And same thing right here, if for example B is greater than A, this could be our outcome. So the main goal right here is really to go from having a question that we ask ourselves to an outcome that we will have at the end. So basically the best outcome would be one of those, and the best outcome usually comes with well, there are mathematical formulas that we'll talk about a bit later in this course. We'll not talk really in depth about them, but just to give you guys well, an introduction to this. So as I said, you will have you will have this that needs to be resolved, and it's resolved by using mathematical formulas and by building up decision trees. So like here, for example, we have a decision tree, and the decision at the end is done with the mathematical formulas. For example, we have entropy that will be calculated, and we'll have some other things that will be calculated as well. So if we stay in decision trees, once again, we can have some decision tree examples right here that I found. Once again, those decision trees examples are pretty simple, just for you guys to understand what a decision tree is. So right here, for example, is a person fit? So if the person is lower than 30 years old, if yes, does it eat a lot of pizza? Yes, then the person is unfit. If no, then the person is fit. Same thing right here, is the person higher than 30 years old? Well, no. Is the person exercising in the morning? Yes, then the person is fit. If no, then the person is unfit. Once again, this is really, really simple. Even the decision tree right here is pretty simple. Usually you have way more variables, and it's way more calculated. It's way more hard to calculate everything and find out the best combination. But once again, this is just a small example of what you can find if you work with decision trees. So basically your brain does this automatically, so you don't even think about it. Your brain does this automatically when you have to take a certain decision. It could be basic decision, for example, I'm walking or I'm driving, I will turn right or left. Or it could be more complex decisions, for example, when you are sitting at a certain exam and you need to write down an answer. Alright, so the mathematical aspect of all this, basically there is a lot of variables that can be calculated, but personally I think there is two very important formulas that we will talk about right now. Once again, you don't necessarily need to understand them 100%. This is just an introduction. So the first one would be the formula of entropy, and basically entropy will be used to calculate the homogeneity of a sample or the impurity of a database. So basically, usually entropy is used when you work with the databases and you build up your decision tree with those databases. What you need to understand is that if entropy is 0, the sample is homogeneous. So like this, for example. And if entropy is 1, it's equally divided. So everything is equally divided. What's important also to understand is that entropy is somewhere between 0 and 1. It can be higher than 1. Usually it's between 0 and 1. Also, entropy is very important to make the second part of our calculation because it controls how a decision tree will decide, well, how a decision tree decides to split the data, and will have an effect on how the decision tree will draw its bases. So basically this would be for entropy. So the entropy is the first part of the calculation, and after that we have another part that is very, very important, which is the information gain. So entropy help us after that work with information gain. So information gain would be another mathematical calculation that we will make to be able to choose the right path to take inside of our decision tree. So here is our information gain formula. Basically it looks a bit complicated, but it's pretty simple. Right here we have our complete entropy, so basically the whole entropy of the whole decision tree, and here we'll have, for example, the entropy of the left side and the right side, for example. Usually the calculation is a bit more complex because you have sums of all entropies, but and this would be the entropy of the whole decision tree. But once again, this is with just one left and one right side. But what does information gain? It will give us how much information a certain variable give us about the outcome, and to interpret it, it's pretty simple. So a high information gain allow us to create a decision tree that will be more representative of the results that we expect to have. So basically, if we come back to our decision tree right here, and let's say this outcome right here has an information gain of 0.9, well, this would be the outcome, this would be the decision tree and the outcome that we will look for. So basically, the higher the information gain is, the higher this would be the decision part of the decision tree that we will take, because the results will be more representative of what we are looking for to have at the end. So besides of that, those are the two formulas that are pretty important. So we have the entropy and the information gain. But in all this course, what I want you guys to understand is the concept of decision tree. So this is a really important concept to understand. The mathematical part, once again, you are not professional right now, and it will take time for you guys to understand it as a whole. But the concept of decision tree, as I said, it works pretty much as the human brain. So basically, when you want to make a decision, you will automatically create a decision tree inside of your head. You don't even need to think about it. And this works pretty much the same way. So for example, if you are building up a certain algorithm that, well, not an algorithm, but let's say, for example, you're building up a machine that will think by itself. What you will add to it, you will add an algorithm that will learn by its experiences. So it will try, for example, something. So I don't know, you wanna create an algorithm that will identify faces. So you will give to this algorithm, I don't know, 100,000 faces, and this algorithm will work. Will see how each face, what each face looks like, and it will learn by itself. And after that, when you will give a face to this algorithm and tell him, okay, is that a face, yes or no? And what the algorithm will do, it will build up a basic decision tree to be, well, it will be more complex than the basic one, to be able to tell you at the end if this is a face based on variable 1, 2, 3, 4, 5. So it will test some things, for example, number of pixels, number of, well, a lot of things. It will test a lot of things, but at the end of the day, it will have a certain decision tree to be able to tell you, yes, this is a face, or no, this is not a face. This is, I don't know, for example, this is a water bottle, for example. So I hope you guys understand the whole concept of decision tree and the two formulas that comes with it. So that's it for this class, guys, and see you all in our next class, where we will still talk about some other statistical concepts. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in this class, this will be our last class about statistics, and in today's class, the main topic would be probabilities. So we are gonna talk about what exactly are probabilities, where they're used, and some of the formulas that you guys can find in probability. We're not gonna go too much in depth in those formulas, because just the concept of statistics and probability, just the concept of probability, could be a complete class of at least 45 hours that we can talk about all the functions that are implied, how to use those functions, and many other things. So I'll try to be as brief as possible and give you a brief introduction to this topic. So let's jump right into it. So basically, what exactly are probabilities? In this case, probabilities are the measure of likelihood that an event will occur in a random experiment. So basically, it's just the probability of something happening. So let's say, for example, you are playing with a $1, so a piece of money, and what are the chances that when you throw that piece of money, it will fall on a head, so on a face, so it will fall on face. So you will have 50% of chances that this piece of money, if you throw it, it falls on face. So basically, those are the probabilities, would simply be the odds of this happening in that case. Probabilities are used in many places, not only in data science. Well, it's really a huge part of it, but it can be used in many places. So basically, it's simply calculating the odds of something happening. So one of the major places where this is used is casinos. So basically, when you're going to the casino and let's say you are playing a game, why the casino always win? It's because you have statisticians that have studied the game, that have created a game that gives the casino an advantage on the long run. So yeah, sometimes the casino might lose money on the short run. So you come here, you play, you win, you go home. But on the long run, on let's say 100 plays, 1000 plays, the casino will always be positive. So basically, that's the goal of the casino, being positive on the long run. So basically, where exactly probabilities are used, it can be used in many places, as I said. So the first one would be games of chances. So in this case, everywhere where you need to gamble. So it could be sports, it could be, I don't know, it could be, for example, casinos, it could be lottery, it could be all the places where you have to gamble. So once again, if you don't imply a mathematical calculation and you just speculate on a certain outcome, those would, well, you will include probabilities in it. If you start calculating and including maths, it's no longer gambling. Second place, the weather prediction. So basically, for those who don't know how exactly works weather prediction, so you have someone that will analyze analyze some things. For example, looking at clouds, looking at the sun, and some other variables that I know nothing about. But they will analyze some variables, and by analyzing those variables, they will be able to make a prediction based on many variables. Once again, this prediction is never 100% sure. It's only based on past experiments. This is why the weather is not always accurate. But based on past experiences, the weatherman is able to say, hey, tomorrow we will have a sunny day, and we have 30%, we are 30% sure that it's gonna rain. But once again, it's just 30%. And once again, it will predict based on different variables. The third part would be finances. So for everybody who is speculating on the financial market, probabilities are really a huge part of it. So to be able to calculate the risk that the person is taking, so just putting the risk as a number, it's really important. Well, putting it in a number and understanding it, understanding how much profits you could be able to make, understanding all the variables that are around the financial investments, require a lot of probability knowledge. After that, mathematics, since statistics and probabilities are part of statistics that are part of mathematics. Of course, mathematics, have a lot of probabilities in them. It's a part of it. And finally, any other place where you are required to make provisions, and you are required to speculate on something that will happen or no. Second part, what we are going to talk about today will be the type of events. So basically in probabilities, you have two types of events that can happen. So you have disjoint events and once again, non-disjoint events. Basically, the difference between both of them is that one will include two variables. Well, the first one will be disjoint events. So if two events cannot both happen at the same time. So basically the first one will include that two events can't happen at the same time, and the other one will be able to let you have two events that happen at the same time. So if we start with the first event type, so the disjoint event, so a good example that we can have is the one that I wrote right here. So the probability that we get 1 and 2 simultaneously by rolling a dice. So let's say you have a dice in your hand and you throw that dice. Is it possible to have 1 and 2 at the same time? No, it's not possible because you only have one dice, and it's possible to have a 1 or a 2. So this would be a disjoint event because you can't have those two answers at the same time. But let's say right now you have two dices and you throw them, and you throw those dices and you have a 1, and you can have a 1 and a 2 at the same time, because the fact that the dice number 1 falls on 1 is not dependent on the dice number 2 that falls on number 1 or number 2 or whatever. So there is an independence between the two things that are thrown, in this case the dice that are thrown, and this independence makes it a non-disjoint event. So basically, disjoint event, there is a dependence between the two events. So if we throw one dice, it will have a dependence. So the fact that it falls on one make the dice, will create a situation where the dice can't fall on two because it already fell on one. But on the non-disjoint event, if we throw the two dices, the fact that the dice number one falls on one doesn't make a situation when dice number two can't fall on one or two. The dice number two will fall on one or two or whatever. So there is no dependence between two dices. So here you can have an example of it. So you will have mutual exclusive events that will be disjoint events, and you will have non-mutual exclusive events that are non-disjoint events. And basically the difference, as you can see, so A and B can't happen at the same time, and here A and B can happen at the same time. So in the non-disjoint events, it's possible to have them happening at the same time. Next thing that we are going to talk about today will be the types of probability, and basically in this case we have three types that are very important that we are going to talk about. So we have the marginal probabilities, we have conditional probabilities, and finally we have joint probabilities. The first one, that is the marginal probability, is pretty simple to understand. It's simply the odds or the probabilities that something happens right now or happens at a certain moment. So basically, let's look at this example. So the probability of drawing a black card in a deck of cards. So let's say you have a deck of cards right now, and you take a card. So the probability that this card would be a black card. Basically, half of the deck is black, half of the deck is red. So you will have 50% of chances of taking out a black card. So basically, this would be an example of a marginal probability, the probability that something happens right now on the spot. Second thing would be conditional probability. In this case, that will be the probability of an event occurring when another event has occurred. So basically, let's say something happens. Let's say you have drawn a certain card. So like in the example right here, you have drew a king in a deck of cards. And then this king, what are the odds that this king would be, let's say, red? So would be a red card. So once again, the chances of this king being a red card would be 50% because you have four kings, you have taken away a king, and the probability of this king being red would be simply 50% because you have four kings, two red, two black. But in the other case, if let's say, for example, you have taken out a red card, what are the odds that this red card is a king? Well, in this case, it's a bit more different because you have 52 cards in a deck. So you will have in this case, you will have 26 cards of each. So 13 cards that are red. So the chances of you having a king in those 13 cards would be 1 on 13. So once again, this is a fraction, but it's going to be something like 7%. So you will have 7% of chances that this card that you just took out would be a king. All right, so the final one, the joint probability, it's looks like the conditional probability. You will see it's pretty much the same thing, but there is a small difference between both of them. So the joint probability is the probability that two events occur at the same time. So what are the probabilities that you drew a 1 and a heart in a deck of cards? So basically, what are the probabilities that you drew a 1 heart in a deck of cards? So basically, this probability would be 1 on 52 because there is just one heart, so 1A. In this case, it's gonna be A. What the ace? So basically, in this case, it's going to be 1 on 52 because you only have one ace of heart inside of the deck of cards. If the probability of you drawing a ace of red, so in this case, it's gonna be 1 on 26. So the probability of you drawing a ace red, it's gonna be greater than the probability of you drawing a ace that is of heart. So basically, this is the difference between the conditional and the joint. So basically, the conditional will happen if an event occurs, the probability that another event occurs as well. So this would be the conditional. So something happens and then you are looking at the probabilities that something else happens. So it's basically two probabilities, and in the joint probability, it's like putting those two probabilities together. So basically, let's take once again this example right here of the king. Let's say you took a king of your pack of cards. In the first case, you will calculate the probabilities of you drawing a king. Then you will calculate the probabilities of you drawing a red king. So in this case, that you drew a red card as well. In the joint probability, you will simply calculate the probability of you drawing a red king. So this would be just this calculation that will be made. So this is for the type of probabilities. The last thing that we are going to talk about are the probability distributions. So once again, this is the part of the course that takes the most of time because there is a lot of formulas. They pretty much look like this. So as you can see, basically what you need to understand, we're not gonna go through each of the formulas, through each of the functions, but what you need to understand is that the probability distributions are a function that describes the likelihood of obtaining a possible value that a random variable can assume based on different criteria. So basically you have a situation that happens and you want to calculate the odds of something happening. So how exactly do you calculate it? So you'll need to take all the variables in consideration, and based on the situation you will have to use a certain function. So you will not use the geometrical function at the same time that you will use the Bernoulli function, for example, or the binomial function or the Poisson function. All those functions are based on different situations and are based on different type of events. So let's say, for example, if you have a situation where you, I don't know, draw cards, for example, from a deck, and you put them back inside of the deck, and you want to have the probability of you drawing 2 times the same card, you will not use the same function that if you don't put back the cards in the deck. So basically you will use 2 different functions, because in the first situation you took the cards from the deck and each time you put them back inside of the deck, and in the second situation you didn't put the cards back inside the deck. So there is, depending of the situation, you will use different probability distributions, so different functions. So this is what you guys need to understand about probability distributions. Once again, there is a lot of them, and to become more advanced and understand them all, you need to practice. So if you guys are interested, I highly suggest you to just take a statistics course, and you will have everything that you need inside of it. Especially if you want to know a bit more about those functions. So basically what we talked about inside of this course are probabilities in, we talked about probabilities, we talked about types of event, we talked about different types of probabilities, and finally probability distributions that are this part of the course. So this, as I said, the statistical part of this course can easily be done in at least 2 university level courses. So it's really complicated. I try to make it as easy as possible for you guys to understand it. So once again, this is just an introduction to it. So I hope you guys liked it, and if you liked if you like the statistical part and want to get to understand it a bit better, I highly suggest you to take a statistical course or just to practice a little bit, and you'll see it's not that hard, it's not that complicated to understand. It's just a question of practice. So that's it for this last course about statistics, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So until now we talked about statistics, and I hope you guys have a good understanding of this topic. Now it's time to get a bit more into action and to learn about some tools that are used in data science and when we are analyzing data. So it can also be used in machine learning as well as deep learning. So basically one of those tools is NumPy. So in this class we are going to have an introduction to NumPy. We are not gonna practice with it, it's gonna be in the next few classes, but in this class we are gonna talk about what is NumPy, what's the difference between NumPy and lists, and what are the advantages of using NumPy in general versus Python lists, of course. So let's start. So basically NumPy stands for numerical Python, and what you guys need to understand is that it's a Python library that consists of multidimensional arrays, objects, and a collection of routines for processing those arrays. So basically, NumPy, as I said, it's it's a library in Python. So there are many features of NumPy that NumPy has. First of all, it will allow you using multidimensional arrays, which is pretty cool, and will allow you to make faster operations. So if you need to make faster operations, it will allow you to make faster operations. It has functions and operators for those arrays. So once again, you will be able to create 1-dimension, 2-dimension, 3-dimension arrays, and you will have different functions and operators that will be used with those arrays to make it faster for all the calculations. It's a good alternative for MATLAB. So for those of you who know what MATLAB is, it's a Python alternative for this for MATLAB in general. Also, it's a Fourier transform. It's the Fourier transforms and shape manipulation. So it will allow you to have shape manipulation. So when you create your 3D multi-dimensional arrays, you will be able to use the shapes and control the shape manipulation. And finally, there is linear algebra and random number generation that is integrated to it. And with linear algebra, you will be able to, faster your calculations, because using multi-dimensional arrays will allow you using linear algebra as well, and faster this way your calculations. So once again, there are plenty of advantages of using NumPy. So as I said, the first of all would be the array-oriented computing. So those are the arrays that we are talking about right now. So this would be 1-dimensional array, 2-dimensional arrays, and those are 3-dimensional arrays. So here it's presented very simply. Usually the arrays are way bigger, so the amount of calculations that is here is that you will be able to do by using NumPy is pretty huge versus working with the Python list, for example. It's a efficient multi-dimensional array implementation. So this is exactly what I was talking about. So it's really efficient. There are multi-dimensional arrays are pretty efficient, so it will allow you, as I said, to make huge calculations in a fast amount of time. It's really created for scientific computation also. So as I said, once again, it's for huge calculations. So it's not like Python list. You can use Python list, but once again, it will not be as efficient as using NumPy. Faster resolution of operations on entire arrays of data without writing loops with the use of standardized mathematical functions. So as we said before, there is linear algebra and some other functions and operations that are integrated with the NumPy that will allow you to make huge operations on arrays, on 3-dimensional arrays that will also be really huge. And this will save you a lot of times when you guys are making huge operations. Once again, maybe right now you don't see why you will use this. Once again, if you guys create huge programs, the use of NumPy is really recommended. There are different tools that are integrated with NumPy. First of all, you can read on array data. You can read array data on disk. You can write array data on disk, and you can work with different memory mapped files, which is pretty cool as well. As we said before, there is an integration of Fourier transform capabilities. And finally, as we said in the past PowerPoint, there is linear algebra and random number generation. All right, so finally, NumPy versus Python list. So as I said, NumPy is a Python library, and the three main reasons of why using NumPy. The first one would be it will consume less memory since there is less operations to do. It will go way faster and it will consume way less memory. Has an execution speed that, this will bring us to the second point, that is having an execution speed that is way faster than Python list. So as I said, it goes way faster than working with Python list, especially if you guys want to work with huge operations. Once again, this is an interesting thing that I found, so you can compare the speed of NumPy arrays versus lists. So as you can see, well, the time is in milliseconds, so it's not even 1 second, but you still can see that NumPy is at least 4 to 5 times faster than than Python list. So once again, there is a huge, well, this is a huge difference, especially if you guys work with huge operations. If you can, with NumPy, for example, resolve an operation in 1 second, it will take you with Python list maybe like 5 to 10 seconds to resolve. So if you have a set of operations, NumPy is really the efficient way to be able to resolve all the operations. And finally, it's just convenient to use. So it's pretty much, it's not, well, you have to get used to it to use it properly, but it's not that complicated to use since it's a Python library. It's already integrated into Python. So right now you guys know exactly what NumPy is, how, well, maybe not how it works, but you know exactly how what it is, why exactly we use it, and why we prefer using NumPy instead of Python list. So all the advantages and the features of this library, well, Python library. So in the next few classes, we are going to practice a little bit writing NumPy functions with Python, of course. So you will see what it looks like, and you will have a certain introduction to this Python library. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in this class, we are going to set up NumPy on our text editor. For the purpose of this course, I'm gonna work with PyCharm since it's one of the biggest text editors for Python. And yeah, so this is, we are gonna work with it. So to install PyCharm, it's pretty simple. Simply go on Google and write down PyCharm. When it's all done, you should be on a window like this. And to download PyCharm, it's pretty simple. It's gonna be here, so simply click on the download PyCharm link. Then pretty simple, you have two versions. You have professional and community. Download the community version. It's free and it's open source, so all the steps to install it are here. So simply click on the download button and you are supposed to have it. When it's all done, you should be on a page that looks something like this. So it will ask you a few questions. But basically, when all the download is done and you have created your first project and everything, now it's time for us to set up NumPy on our PyCharm text editor. So pretty simple how this will work. So first of all, you guys will need a project. So simply create yourself a project right here. So it's gonna be new project. When you guys have a project, in my case, I have a project, it's project 1. So pretty simple, we are going to go on settings. And in this case, you guys will have a lot of tabs. So you have appearance, you have version, you have project. In this case, it's project 1, which is my project. And you will download, well, you will put PyCharm, you will put NumPy on your project. So in this case, it's pretty simple. You will simply go on your project, you will have project structure and Python interpreter. You should have two things, so pipe and setup tools. So pretty simple, you simply click on the plus button right here. And here you look for NumPy. So basically all our Python tools that we are gonna work with them, we will download them all right here. So pretty simple, you simply write down NumPy here and then you click on install package. So as you can see, the installation is happening right now. So basically this way you guys will all have NumPy installed on your text editor. And from this moment, we are able to write down all codes in NumPy. So as you can see, package NumPy installed successfully. And this is, so from this moment, all codes written with, all codes or all orders that will be written with NumPy features in them will work. Besides of that, you will not be able to execute the codes that you write with NumPy features in them. So you really need to do this first step before being able to make any calculation with features to NumPy inside of your code. So that's it for this class, guys, and see you all in our next class where we are going to start writing our first Python codes with NumPy features in them. Alright, so hello guys and welcome back to another class of our course about the complete introduction to data science. So basically until now you guys should have your PyCharm text editor ready with the NumPy feature on your project. So basically right now it's time for us to start learning how NumPy works. So pretty simple, the first thing that we want to do is simply import the NumPy feature inside of our project. So how do we do this exactly? It's pretty much the same way as if we want to import math features inside of our project. So we will start by writing down import. So import. Then what we want to import? We want to import NumPy. As what? So the as feature, so here we need to select something, and each time we'll write down this argument, it's gonna be referred to NumPy feature. So in this case, let's say it's gonna be NP because NumPy is NP. So right now with this line of code right here, we have imported NumPy features to our project. From this moment, what we'll learn in this course is pretty simple. So we'll learn to write down one-dimensional arrays and two-dimensional arrays. And at the end, we will see how we can add them, make an addition of those arrays together. So pretty simple, how exactly do we write down an array? So a one-dimensional array is pretty simple to write. So the first thing we need to create is a variable where we will store our array. So in this case, our variable could be anything you guys want. Let's call it var1, so variable 1. So pretty simple, so var1 equals to what? Equals to np, so we refer to a NumPy function in this case, so a NumPy feature, which is array. So we refer to a NumPy feature, which is array. We open up our parentheses, and we write down our array. So let's say for the purpose of this example, we'll write down an array that is composed of even numbers. So pretty simple. We open up those parentheses and then we can write down our array. So it's going to be 2, 4, 6. So not something that is complicated, something pretty simple. So right now we have created our one-dimensional array. So as you can see, there is just one line. It's a 1D array. So right now what we want to do, we want to generate this array inside of our terminal right here. So pretty simple, we'll simply run this, this really basic app, which is an array. So we want to print var1. And then it's simple, we just run the project. And as you can see, we have our array that is printed right here. So 2, 4, and 6. So this is how we create a one-dimensional array. So right now, let's say we want to create a two-dimensional array. So how exactly this works? So it's pretty simple. We just need to modify our array right here. So let's say I want to create a two-dimensional array that has even numbers and odd numbers integrated in it. So pretty simple how this would work. So first of all, we keep those parentheses right here. We keep our numbers right here. What we want to integrate right now is pretty simple. So we'll just delete everything we have right here and add a parentheses. So from this moment, we want to write down our numbers. So let's say it's going to be 2, 4, and 6. We close our first parentheses, have a comma, and our second array would be, in this case, 1, 3, and 5. So we have even numbers as well as odd numbers. When it's done, simply close all your parentheses. So in this case, we have all those parentheses. And our function is ready. So basically what we can do right now, we have our 2D array, and what we can do, we can print it right now. So pretty simple, just run your app. And as you can see, you have your 2D's array right here. So it should look something like this. All right, so next thing that we are gonna learn today is how to make an addition of arrays. So how exactly we make an addition in Python. So basically it's pretty simple. You can addition numbers. So basically arrays are a set of numbers, so you can make an addition of them. But before, we can addition them in form of arrays, but you can addition them inside of variables as well. So what we'll do right now, we'll create a second variable where we are going to store our arrays. So, where we are gonna store another array. So pretty simple, just write down var2 equal, And in this case, instead of writing down the same thing once again, we are just gonna copy everything right here and paste it down there. So we have the exact same thing. And what we'll do, we'll simply addition those two arrays together. So pretty simple, we'll just write down print and addition var1 and var2. So it's pretty simple. What we are doing right now, we are just additioning arrays. And what you will see right here would be the addition of those arrays. So basically the result of the addition. So as you can see right here, it gave us the result, which is 4, 8, 12, 2, 6, and 10. So basically what it does, it simply additioned the arrays together. So this is basics of linear algebra. So right now you guys have learned how to import NumPy as, to add NumPy to your Python project, to use NumPy features to your project. You learned how to create arrays, and you learned how, to create 1D and 2D arrays, and you learned how to make additions and other types of things with your array. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So until now we talked about many things, and we talked as well about NumPy. So until now you guys should have your PyCharm terminal ready with NumPy installed on it. So basically having access to all NumPy functions and features. So in today's class, we are gonna learn some basic NumPy operations in this class, as well as in the next class, and we are gonna talk about some NumPy functions, but more in the next class. In this class, it's just an introduction, so we are gonna learn some basic operations. So basically, as I said, we are gonna learn some basic operations that we can do with NumPy, so you guys will have a little introduction to it, and you're gonna see it's not that hard to understand. It's basically like Python programming, just with more features. So the first thing that we want to do to have access to those functions is pretty simple. We will import our NumPy, import our NumPy functions. So as always, we'll write down import NumPy as NP or as anything you want. And the first thing that we want to do is create ourselves an array. So basically all those operations work with arrays. So, the operations that we are gonna learn today, so basically those operations will tell us many things. So for example, the number of dimensions inside of array, the size of an array, the shape of the array, and many other things. So let's start. Basically, the first thing that we wanna do is create ourselves a variable. So let's create a variable and call it var1 in this case. And var1 will be equal to what exactly? So just create yourselves an array. So the array could be anything you want, so don't forget np.array. And from this moment, you want to create yourselves an array. So let's say it's going to be 2, 4, 6 for the purpose of this example. So with the knowledge that you guys have about arrays, you should know that this is a one-dimensional array. All right, so basically what we want to do right now is just print this array to see that everything works perfectly. So we will print our array, so print var1. If we run our little Python app, as you can see, it's gonna be 2, 4, 6. So everything works fine, everything is perfect. Awesome. Right now, the first thing that we will learn to do is learning what is the item size of each element of our array. So basically learning to know what is the item size of each of those numbers, in bytes, of course. So pretty simple. You will simply write down print var1 dot item size. So basically, this is a simple function or formula that will allow you to know what is the item size of each element right here. So in this case, it's 4. No matter what number you write down, it's gonna be 4. So for small numbers, if you write down bigger numbers, maybe it's gonna change. So in this case, it's still 4. All right. So this would be the first operation that we are gonna learn. The second one that we are gonna talk about would be an operation that will allow us to know what is the data type of the elements that are inside of our array. And basically how this works is pretty much the same way. So it's gonna be the end function. So the first thing you need is your array. Then you will print the name of your array dot d type. So very important, d type. And if you run the app, you will see that ENT32 is the data type of elements that are inside of our arrays right here, inside of this array right here. So basically those are the two first operations that we are gonna learn. Next one that we will talk about is an operation that will allow us to know how many dimensions there is inside of our array. So in this case, as we all know, this is a one-dimensional array. So if we want to know the number of dimensions, it's pretty simple. We will do the exact same thing. We will just write down n dim. And if we run the app, as you can see, it's gonna be 1. For the purpose of this example, let's just add another line of code that will print our array as well. So if we run our app, we will have our one-dimensional array right here, and we'll have a little 1 right here. Now let's say we want to add another dimension to our array. So pretty simple. What we'll do is we'll simply add some parentheses, and we will just copy our line of code and put it right here. So let's say we want to change it just to make it a bit more fancy. Add a 3 right here and a 5 right there. So we have odd number and even numbers. If we run our app, as you can see, changed. It became a 2-dimensional array. So we have a little 2 right here. And even if we add some other lines right here, so it's still going to stay a 2-dimensional array, as you can see there. All right, so this is for the 3 first formulas. The next thing that we are gonna talk about is how to find out the size of a certain array. So in this case, it's pretty simple. What we want to do is let's just keep it a 2-dimensional array with just 2 lines and 3 columns. With the 2 columns and 3 rows, sorry. So pretty simple. What we'll do right now is simply try to know what is the size of this array. And basically what we'll do is we'll simply write down our variable dot size. And if we run the app, as you can see, the size of this array would be 6 elements, since we have 6 elements right here. If once again we add some more elements, so we add some other lines, so it's gonna change. It's gonna be 12 in this case because we have 12 of them. If we make it a bit smaller, as you can see right here, we'll have 9 of them. All right, so basically those are pretty simple, as you can see. The next function that we are gonna talk about will tell us what is the shape of the array. So in other words, how many columns and how many rows there is inside of our array. So basically right now, if we just delete, well, right now we have 3 columns, 3 rows. It's pretty simple. But in this case, right here, we'll have 2 columns and 3 rows. So if we decide to run our app, what we'll do is pretty simple. We'll just go here and write down var1.shape. And if we run it, as you can see, we have right here 2 columns and 3 rows. So basically 1 column is the thing right here. So 1, 2, and 3 rows. So 1, 2, and 3. So pretty simple to understand. All right, so next thing that we are gonna learn is how to reshape our array. So let's say in this case we have 2 columns and 3 rows. In the next in the next function, what we'll learn to do is how to transform this function into a function that has, well, how we can transform this array that has 2 columns and 3 rows into an array that has 3 columns and 2 rows, because yes, it's possible to do it. So what exactly we want to do is pretty simple. So we will write down another line of code right here. We'll write down var1. So in this case, it's our variable var1. And what we want to do is want to reshape it. So we will write down the name of our variable again, dot reshape. So the name of this operation would be reshape. And then we open up our parentheses. And how many columns we want in this case? We want 3 columns and 2 rows. So what we'll do right now, we'll just run our app. And as you can see, it changed right now. So basically we have the exact same array, just this time with 3 columns and 3 rows. Basically you can't create another array with that, well, with this array right here. You can't have another array that has, for example, 3 columns and 3 rows. If you do it, you'll see it's gonna be an error. So if you try it out and you try to run it, as you can see, it's gonna be an error because it doesn't make sense. So you can transform 3 columns and 2 rows into 2 columns and 3 rows. It's possible, but it's not possible to like create weird things like, for example, an infinity of columns and infinity of rows. So that's just basic logic. So until now, you guys have learned plenty of basic operations. So the first thing we talked about the item size. We talked about the D type that allow us to know the type of data that we have. We talked about the ndim, the operation that allow us to know what is the number of dimensions inside of our array. We talked as well about the shape and the reshape function, shape and reshape function that allow us to know what is the shape of the array, and for the reshape function that allow us to reshape our function how we want it. So basically transform columns into rows and rows into columns. So until now, you guys can see it's not that hard to understand. So those are really the basics of NumPy with Python. So how to use NumPy on Python, those are the basic operations. So in the next few classes, we are still gonna talk about some other operations and some other functions that are pretty cool, and some other cool stuff that you can do with NumPy. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So basically in today's class, we are going to talk about plenty of very interesting formulas that you guys will see are really, really interesting and simple to use. So basically the 5 operations that we are gonna learn to do today are pretty simple. The first one would allow us to create an array. So it's gonna be the linspace operation that will allow us to create array with numbers that will be automatically generated. The second one will be slicing. So basically we are gonna slice our array into, we will be able to slice our array, for example, with multiple arrays, with multiple lines into an array with just one line with the numbers that we want. And finally, we're gonna talk about the min, max, and sum functions, which are also really simple to use and can be really effective. So let's start. So as I said, the first function that we are gonna talk about would be the linspace function. Basically how this function works is pretty simple. So the first thing, so why is it used at first? It's used to create a array with the numbers that are from an equal distance from one another. So how exactly this works? So pretty simple. We want to create a variable. So var1 in this case equal. So np, like always, dot. In this case, the function would be linspace. From this moment, we want the first number that we gonna enter here, because we have 3 elements inside of this variable. The first one would be the first number. So let's say we want to have 10 as our first number. Then that's our start number. So our second number would be, let's say, 50. So basically what we are asking right now Python to do is starting with the number 10 and finishing at the number 50. And we want Python to generate how many random numbers at equal distance, how many numbers at equal distance. Let's say we want Python to generate 100 numbers at equal distance between 10 and 50. Let's start with less than 100. Let's say we want to generate only 2 numbers. So what we will see right here, just printing the function. So print. Here we go. So what we will see is that Python will just generate 10 and 50. If we ask Python to generate 4 numbers, so in this case, it will generate 10 as first number, then 23.33, then 36, then 50. So those numbers are at equal distance. So basically they're at equal distance. So from 10 to 23.333 is at equal distance, that 23.33 from 36.666 from 50. As you can see, it's pretty simple. We can do this with really huge numbers. For example, 100 is just gonna take more time to complete. But as you can see, you can have really huge numbers, and it's gonna automatically calculate everything. So as you can see, this function could be really, really interesting for bigger projects. For the second function that we are gonna talk about would be the slicing function. And for this function, we would need to create ourselves an array. So like always, we will create ourselves an array, and pretty simple. So we want to start it with a variable. So once again, we'll have our var1 np.array. And from this moment, we'll create an array that will be two-dimensional, because this function works with two-dimensional arrays. So pretty simple. We will have our even and odd numbers as always. So 2, 4, and 6. And for the second array, we will have, in this case, 1, 3, and 5. So as you can see, it's pretty simple what we'll do. So we have 1, 3, and 5. So we have our array right here. So just to try it out, we'll print it. So print var1. Here we go. So if we run it, as you can see, our array works. So everything is fine. So what we want to do right now is work with, we want to slice our function. So basically, how exactly we'll slice our function, it's pretty simple. So let's say we only want the number 4. So how exactly we'll do this? It's pretty simple. We'll write down print. And what exactly we want? We want to print from variable 1 So from variable 1, we want to print inside of the line 0. So this line, the line 0, we want the first argument. So basically in Python, we start counting from 0. So this would be 0, this would be 1, this would be 2. So from the line 0, this would be our line 0. We want to print the element number 1 or number 2. So basically how we'll write it down right here. So from the line 0, we want to print the element number 2. So number 1 in this case, because in Python language, it's going to be 1. And if we run it, we will have 4. So as you can see, it's pretty simple to understand. Now let's say, for example, we want to print the number 4 and the number 3 right here. So basically for the two arrays. So how exactly we'll write it down? It's pretty simple. We will use the 2 points. So what does those 2 points mean? So from the line 0 until the infinity of all lines, so basically until the end, I want to print all the number 1s. So if I translate, basically from the line 0, from here to the end, if here I only have 2 lines, so basically from here till the end, I want to print all number 1s. So basically it's going to print the 4 and the 3 right here. So if I run the app, what it will do, it will print 4 and 3 as well. So for the purpose of this example, we'll add more arrays. So just to try it out. And inside of those arrays, we'll just write down some random numbers. So for example, 7, 24, 21, 10, 30, and 50. Here we go. All right. And if we run our app, it's going to do the exact same thing. So as I said, it's going to print all the number 1s in all the arrays. All right, so you guys get the point. Now let's say we want to print from here, from this line right here. So pretty simple. Instead of writing 0 right here, what we'll do is we'll ask Python to print from line number, let's say 1. So from this line right here until the end, we want to print all number 1s. So from line number 1, we want to print all number 1. So it's going to print the 3, the 24, and the 30. So if we run the app, as I said, it printed the 3, the 24, and the 30. So this is for the slicing part. So you guys get the point, and you understand why exactly do we use slicing. All right, so next few functions that we are gonna talk about, you'll see they're pretty simple to use, and they work the exact same way. So those are the min, the max, and the sum function as well. So as always, what we need right now, we need our array. So basically, we'll just create our variable. So in this case, var1, that would be equal to our array. So like always, np.array. We open up the parentheses. And in this case, like always, it's going to be 2, 4, 6. All right, so we get our array right here. Next thing that we want to do is just finding out the max of all this. So basically, we'll print First thing, we write down our variable name. So in this variable, so in var1, we want to print the max. So dot max, open and close parentheses, really important, and run the app. And as you can see, it will print us 6. So we have our 6 right here. So this is the max of this array. What's cool about it is that it works for all types of, well, for 1 dimension as well as 2-dimensional arrays. So if we add a second dimension to this array, so we have 2, 4, 6, and let's say we add 1, 3, and 5, like we always do, and we run the app. As you can see, it's gonna stay 6. But if here we have 50, for example, you'll see it's gonna become 50. So basically it's gonna work with the whole array right here. All right, so same thing for the min. If you wanna know the min of all this, pretty simple. Instead of max, just write down min, and you guys can run the app, and it's gonna be 1. So the min, the smallest number, is 1, and if we change 1 by 10, the smallest number will become 2. So in this case, it's gonna be 2. All right, and finally, the last thing is the sum. So basically what the sum function or the sum operation will do inside of this array, it will simply calculate the sum of all the numbers inside of this array. So very simple, just write down sum, very important, print var, so the name of our variable, dot sum. You run the app, and as you can see, it gives us 21. So basically it's the sum of all the numbers right here. So as you can see, guys, it's pretty simple to understand. Those are some other really simple functions that works with arrays and NumPy. So those are really simple NumPy applications. So I hope you guys learned some few things inside of this class. And in the next class, we are still going to learn some other NumPy operations. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are gonna learn some more mathematical operations that can be used with NumPy on Python. So basically the operations that we are gonna talk about today would be all the basic operations such as additioning, multiplying, dividing, and subtracting. All this with arrays, so it's gonna be basic matrix operations that I'll show you how to do. So we talked about it a bit earlier. We're just gonna have a refresher. We're gonna talk about putting everything into one single column. We're gonna talk about sum of axes, so basically how to make a sum of axes, and the square root and the standard deviation function. So let's start. So before we start, what we need a array. So basically what we'll do, we'll create a 2-dimensional array and we'll work with it for the purpose of the whole course. So pretty simple, we'll name it var1, and this 1-dimensional array would be, like always, an array with the odd and even numbers. So here we go. So we'll have 2, 4, 6. And the second one would be 1, 3, 5. So as you can see, pretty simple. Next thing that we will do, we'll have our second array. So in this case, here we go. We'll have our second array right here, which will be number 2. And basically you guys can change numbers or you can keep the numbers as they are. Basically I changed the numbers just for the purpose of the example. You don't need to have the same numbers as me. Just to show you that you guys can make some basic operations on arrays. Alright, so the first operation that we are gonna talk about in this course will be the addition. So basically, how do we make basic operations? So matrix operations on the arrays. Pretty simple. Simply write down print. And from this point, what you want to do is simply select your variable. So in this case, var1 plus var2. And you can run the app and you will have the answer right here. So basically what it will do, it will simply do a basic mathematical, a basic matrix operation. So in this case, it's an addition. So you can do the same thing for subtraction. You can do the same thing for multiplicating. So if you want to multiply arrays. And finally, for all array divisions. So it's gonna work pretty well. So as you can see, it gives us the right answers each and every time. So this is for matrix operations. So as you can see, it's pretty simple to understand. All right, next thing, let's say you guys want to print, so you want to put everything on the same row. So let's say you guys have, in this case, we just gonna keep one array. So let's say you have this array that is 2-dimensional and you want to put everything on just one column. So it's pretty simple. How do we do this? So if we print var1, and you guys can see right here that it's on 2 rows. So basically it's 2 rows. And if you want to put it on just one column, how exactly we'll do it? It's pretty simple. So I'll print both of them. So we'll have the original one and the other one. So it's gonna be pretty simple. Simply write down var1, in this case the name of your variable, dot ravel, open and close parentheses, and here you go. So if you print it, as you can see here, you will have everything, so all your numbers on the same column. So just one column for all the numbers. All right, next thing that we are gonna talk about is the sum of axes. And basically when I'm saying sum of axes, you guys can make a sum of all the columns as well as all the rows on your, in this case, array. So how exactly this works, it's pretty simple. So once again, we have our array right here. And to be able to make a sum of axes, it's gonna be a basic sum operation. So simply write down print. When your print is here, write down the name of your function, of your variable. So in this case, it's gonna be var1.sum. So usually if you do this, if you just run a sum function, it's gonna calculate the sum of your variable, of this variable right here. But in the case, if we want to calculate the sum of axis of a certain axis, the way that we do this, it's pretty simple. So we just open up the parentheses, and from this point we just write down axis. And in this case, the axis could be equal to 1 or 0. If, for example, write down 0, as you can see, it will calculate the sum of all the columns. And if we write down 1, what we'll do, it will calculate the sum of all the, in this case, rows. So if we print both of them, so if I print, for example, my, my variable, so in this case, var1, and I run it. So as you can see, first thing is going to be this. So basically, if I select axis equals to 1, it will calculate the sum of all the numbers right here and all the numbers right here. So 12 will be the sum of 6 plus 4 plus 2. So it's going to be 12. And 9 will be the sum of 5 plus 3 plus 1. If instead I write down equal to 0, and I run the app, it's going to be the reverse. So what's going to happen? 3 will simply be the sum of 2 plus 1. 7 will be the sum of 4 plus 3. And 11 will be the sum of 6 plus 5. So as you can see, it's pretty simple to understand. All right, so right now that you guys get the sum of axes, the next two things that we are gonna talk about would be the square root as well as the standard deviation. So basically how the square root function works, it's pretty much the same way as it works for if you make it on Python without using arrays. So it's gonna be the sqrt function, but it's gonna be written with NumPy, with the NumPy feature. So simply write down print np.square root, so sqrt, and then you enter the name of your variable, so in this case var1, and you can run the app. So basically what it will do, it will calculate the square root of all the numbers, so basically the square root of 2, the square root of 4, of 6, then the square root of 1 right here, the square root of 3, and the square root of 5. Same thing for the standard deviation. So basically what it will do, it will calculate the standard deviation of all the numbers and give you just one answer. So basically S is going to be std. So if you run the app, it's going to be a bit different. It's going to give you just one number. So basically the standard deviation of all the numbers right here. So we talked a little bit about standard deviation in the statistical part. So if you guys are interested to know exactly what is the standard deviation, you can just make a research on it. But to run a standard deviation operation, it's pretty simple. Simply write down std and it will work. Same thing for the square root function. It could be really useful, for example, well, for the standard deviation, it could be really useful if, for example, you want to compare a number to, for example, the mean or the average, or if, for example, you want to calculate, I don't know, let's say the volatility of something, if something is really volatile or not volatile at all, if there is a big difference between the numbers between them or no. So this is for this part of the course. So right now you guys know a few operations of NumPy. There is a lot more other operations that exist, but those ones for me are the basics. So that's it for this class, guys, and see you all in our next. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in this class, I thought that it would be great to have a little bonus and to add two functions that can work with NumPy as well. So basically, I just wanted to show you at first all the operations that NumPy can do on Python. But I thought that adding two more functions could be a good thing, and at the same time, you guys will probably love it. So basically, the two functions that we are going to talk about today would be the exponential function, or e at the exponent x, and the logarithmic function. And basically the goal today is just to show you that NumPy is able to, well, to make arrays and make those functions work with arrays. So basically apply functions on those arrays. So it's not something that is too complicated to do, and at the same time it's pretty cool. Well, at least. Alright, so the first thing that we will do is pretty simple. We need to write down our array, so basically our variable. So in this case, var1 would be our variable like always. And our variable, basically what we'll do with it, we will create an array. So np.array. We open up our parentheses, and in this case, we'll work with just a one-dimensional array. So pretty simple. So like always, we'll use some other numbers, so 3, 6, and 9. And right now we have our array. So the next step is pretty simple, is writing down our functions. And what's gonna happen is that Python will just apply those functions on each number inside of our array. So the first function that we are gonna have will be the exponential function. And basically how this function works is pretty simple. So it's simply e, or 2.72 and some other numbers, I don't remember them, exponent our number. So basically if we try it out, so simply write down np, so print np.exp, and in this case var1. So basically what I have just done is I wrote my print function. So I asked Python to print the exponential function of this variable right here. So basically, since we have an array, what is going to happen? It's going to apply the exponential function on all the numbers right here. So basically the exponential function on this number, this one, and this one. And if we run the app, we can see it right here. So basically for the first one, so basically for the 3, it's going to be this. For the 6, it's going to be this. And for the 9, it's going to be this. It works pretty much the same way if we want to have a logarithmic function. So basically, the log function is simply the reverse of the exponential function. It's not a log 10. Usually it's a log 10. In this case, it's not a log 10. So if we try it out, the only thing that you guys have to do is simply exchange the exponential function by a log function. So simply change the exp by a log, so a logarithmic function, and you can run the app. And as you can see, you will have the complete, well, you will have those answers right here. So basically, as I said, it's simply the reverse of the exponential function. So I'm not gonna give you guys a complete mathematical course about all this, but once again, it's pretty cool. Usually it's possible to show it on a graph, but I won't do it because I will need to use Matplotlib for it. That's a visualization tool, and we'll work with it a bit later in this class. So you'll see a bit later in this course. we will work with different tools that will let us visualize our data or put everything on graphs. Alright, so now you guys know how to work with exponential functions as well as logarithmic functions inside of Python with NumPy. You can work with any other, well, there are plenty of other functions with which you can work using arrays, and those are pretty cool. So that's it for this part of the course, guys. I hope you guys liked NumPy and learned a lot of things about it, and see you all in the next part of this course. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So we saw many things in the past few classes, and in today's course we are going to talk about data analysis and about pandas. So basically, we are going, in today's class, more specifically, we are going to have a complete introduction to pandas and talk about, well, what is it, what is data analysis, the concept of data analysis, and make a quick recap of what we can do with Python. And we are gonna have in this part of the course, not in this class, but in the few next classes, we're gonna learn how to use pandas, like we did for the past Python, well, for the past Python program that we learned a little bit before. All right, so let's start. So basically, it's important to understand the basics of Python before jumping inside of pandas. And for that, we will make a quick recap of what we saw at the beginning of the course. So basically, Python can have many applications such as web development, simple programming for different programs. For example, it could be for machine learning. It could be, for example, for, I don't know, in many fields. It could be in security. It could be in finances. It could be in many different fields. But it can also be in research and analysis. So basically in data analysis. And this is exactly what we are going to talk about in this part of the course. And we are going to learn some tools that can be really, really useful for this, to be able to do this part of the course. So basically to be able to do data analysis. So here are some things that you guys can do with Python. So as you can see, development, research and analysis, data science, and many others. There is no security here, so there are many other things that you can do with Python. All right, so in understanding data analysis, so basically the first thing that we need to talk about when we're talking about data analysis is the data life cycle, since data analysis is part of the data life cycle. So what you will see in, if for example you guys are looking for the data life cycle, is that you will see plenty of different things like this that will show you different data life cycles. They're all correct, so there is no correct or incorrect thing that represents well the data life cycle. Some of them will have 7, like this one right here. Others will have 6. Some of them will have 5. But at the end of the day, it's pretty much the same thing, just with different names and different things inside of it. So basically, it's just different names. But at the end of the day, it's the same thing. A word that will always come inside of those representations will be the analyzing part, since the analysis of the data is one of the most important things that you guys can do. Because when you analyze data, you understand, you transform this data. So you take raw data and you will transform it, because the analysis part is where the data is transformed. So you take everything, well, you are able to take all the raw data and transform it into data that you can use later to answer different questions, or for research purposes, or for any other purposes that you can that you want, basically. So it's pretty much explained here. So you have your data, you make your analysis, and at the end you are able to answer to your basic question, so to your first question, or simply make some discoveries. Even if it doesn't answer your question, you are able to make some discoveries just by analyzing this data. So basically, what is data analysis? So it's to perform data analysis with Python, it's really important to use. So as I explained data analysis a little bit before, now it's important to understand how we can perform it with Python. To be able to perform data analysis with Python, we will use a special model called Pandas. And this is exactly what we will talk about right now. So basically, Pandas is one of few models that, well, few of many models that exist with Python. And basically, it's a software that is used for data manipulation and data analysis. It's Panda is built on different other applications such as NumPy, SciPy, and Matplotlib. So as I explained to you guys a little bit before, Matplotlib is used for data visualization. So basically to represent charts, to represent graphs, and to represent many other things. So basically to represent your data. And it's also used, and NumPy and SciPy, sorry, are the fundamental packages for scientific manipulation. Scientific computing, sorry. So basically, it's important to understand that Pandas is really a whole, it works with all those applications. And there are plenty of benefits of using Pandas. So basically, some of the, here you can find some of them. And as I said, really, there is a lot of different things that you guys can do with by using Pandas. So the first one right here, as you can see, will be more done for less coding. So basically, you don't have to code that much with Pandas to be able to write down the exact same thing. So basically, there is less coding. It's really created to work with Python. So it's not only created to work with Python, it's made for Python. So this is another really good advantage of it. There is an extensive set of features. So basically, it's really powerful, and it will provide you with a huge set of commands and features that can be used to easily analyze your data, which is pretty amazing. It can also handle really large data and very efficiently. So basically, when you guys work with really huge databases, this is the perfect tool to work with it. And finally, there is a great data representation. So basically, it will represent data really in a great way. So it will offer you really streamlined forms of data representation. And there are many other things that, there are many other advantages of using Panda. I just didn't wrote them here. All right, so right now, guys, you have a small introduction to Pandas. So basically, you know that Panda is a tool that works, well, basically, it's a software that works with Python. So basically, it's an application inside of Python, and it's really used for data analysis. And in this part of the course, we are going to learn how to use it. So this way, you guys will have an introduction and will be able to work in the future with Pandas. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So today's class main topic will be setting up Pandas in your PyCharm text editor. So basically, if you guys want to work with the Pandas, it's pretty important to set it up first and install the plugin. It works pretty much the same way as we did with NumPy in the past part of the course. So this is exactly what we are going to do today. So pretty simple. The first thing that I'll ask you guys to do is simply opening up your PyCharm text editor. And then from this moment, you will go into your files and then in your settings. From this, when you guys are in your settings, what you want to do is simply look for your project. So in this case, I have my project Python 2. So I will just open it. When it's done, I will select project interpreter. So you guys will have project structure, but we want the project interpreter. Then the next thing will be simply adding Pandas to our, to everything that is here. So to the packages. So we'll install the Panda package. So pretty simple, simply write down Pandas. And you can find it just there. So powerful data structure for data analysis, time series, and statistics. This is exactly what we need. So when you find that out, what you want to do is simply click on install package. So what's going to happen? PyCharm will simply install this package, and you will be able to work with Pandas for the next few classes. As you can see, it's here. It's written package installed successfully. So when you see this message, this means that everything is good. Then you can simply click on X. So as you can see here, I have my Pandas that have been installed. So I just click on OK. Then if I want to import my Pandas, it's pretty simple. How exactly can I import my Pandas? For the next few projects, you guys will know it. So pretty much the same way as I import NumPy or any other package. So I need to write down import. Then what I want to import pandas as what? As, in this case, pandas will be PD. So I want to import pandas as PD. And from this moment, I can write down all the codes that I want and use all pandas terminologies, and it's gonna work perfectly. So right now you guys should have the Panda package already installed on your PyCharm platform, on your PyCharm text editor, sorry. And from this moment, you guys will be able to start working with Python and pandas together. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in today's class, we are going to learn how to use pandas. So basically, we're going to learn how to create tables inside of pandas with the use of Python codes as well as pandas operations. So it's pretty simple. Let me just explain you what I mean by tables. So let me just open up this little Excel folder. So basically what I mean by tables is just creating your first little database inside of Python. So basically you guys will recreate this little database inside of Python. So I created something that is pretty simple. So we have numbers, we have the names of employees associated with their numbers. And finally, we have their hourly salary or how much they earn per hour. So let's say you guys have all this on Excel and now you want to put all this on Python. So how will it work? So it's pretty simple. The first thing that you guys will need to do is open up your PyCharm, so right here, and import pandas as PD. So import, it could be as PD or as anything you want. So basically we import pandas. That's the first thing because we want to use some panda models or panda operations inside of our, well, when we will create our database. All right, next thing that we want to do is give a name to our database. So basically it's going to be employee. And inside of employee, we are going to store all the data that is going to be used to create our table or our database. All right, so we will start the creation. So right now, the first thing that we'll do, we'll open up parentheses like this. And the first thing is we want to enter all the numbers. So basically you open up, you write down 2 commas like this and you write down number. From this moment, 2 points, and you enter all the numbers that you have. So what are the numbers that we have? We have 1, 2, 3, 4, as well as 5. We do the exact same thing for names. So basically 2 commas like this, we write down name, and then we enter all the names that we have. So basically in this case, what are the names that we have? We have AB, John, Mark, and Bob. So basically those are all the names that we have. So here we go. Here, so we have AB, John, Lena, Mark, and Bob. And basically you guys can write down as many rows as you want. So each thing like this is 1 row, and this is all the elements that are part of the row. So basically we have numbers, 1, 2, 3, 4, 5. We have names. Then we will have hourly salary. If you guys want to add some other things, for example, where they live, where they work, and any other thing, it could work as well. All right, so the last thing, as I said, will be the hourly salary. So in this case, we'll write it down. So hourly salary. Then you write down your 2 points as always. So it's going to be 15, 25, 32, 27, as well as 40. All right, so right now we have everything that we need. Very important to check for errors if we didn't make no errors. So as we can see, everything is pretty good. Next thing what we want to do is print everything and look what it looks like. So you'll see it's not going to be as pretty as you think. So basically we'll print employee. So it's all going to be in a form of line. So as you can see, it looks something like this. So it's definitely not like a table right here, like the table that is right here. So what we want to do right now is we want to use pandas to be able to generate something that is more nice to see. All right, so what exactly we'll do right now? So we will put everything, well, everything that is right here inside of a table or inside of a database. So you will need to give a name to this database or to this table. So let's call it table 1. So in this case, it's gonna be table 1. And table 1 will be equal to. So first thing, we will write down PD because we are going to refer to PD operations. So it's gonna be PD dot data frame. So we are going to create a data frame. And we want this data frame, we want this data frame to go find its data. So we want the data frame finding its data inside of employees. So this is all the data that we have created. So this is all the data of our database. And we want to create a data frame with this database. And the name of this data frame will be table 1. All right, so what we'll write down inside of our data frame will simply be employee. All right, so if we run our app again, we're gonna receive the exact same thing because we are still running the employee data. So basically what we'll receive crude data like this. But if we want to receive our table, so basically we will need to run our table 1. And in this case, we'll receive our data frame or our database in a more nice way. So basically we have it right here. So number 1 will be AB, number 2 will be John, number 3 will be Lena, number 4 will be Mark, and number 5 will be Bob. So as you can see, we have our 5 employees in a form of data frame, or well, a database that is better presented. So right now, guys, you should be able to create your own database by using Pandas and Python combined together. So that's it for this class, guys, and see you all in our next class where we are going to learn some other basic Pandas operations. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in this class, we are still talking about Pandas operations, and we are going to learn a basic Panda operation that is called slicing. So to be able to explain to you what exactly is slicing, I'm going to present it by the use of this little database. So the database that we worked with a little bit before in this course. So pretty simple. Let's say you guys have your database right here. So you have your small database, but you only want the 2 first elements right there. So there is a way, or there is a function that you guys can use with Pandas and Python to be able to only generate the 2 first rows. Or if, for example, you want only the 3 last rows, or only the 4 last rows. So basically, there is an operation in Python that you guys can use to be able to only generate some rows, but not all the rows from your database. And this function is called head or tail. So you'll see it's pretty simple. So right here we have our database. So as you can see, the exact same database that we wrote. So we can write down table 1 right here to be able to run our database. So as you can see, we have our database that works perfectly. So what we want to do right now is pretty simple. So we're just going to add a little dot and we'll write down head. So what we want right now, we want to generate the 3 first elements inside of this database. So basically we want to generate AB, John, and Lena. So how exactly we'll do this? Pretty simple. We just write down head and then we enter the number of rows inside of the parentheses. So let's say we want the 3 first rows. So in this case, it's going to be 3. And we run our app. So as you can see, we have the 3 first rows that have been generated. So we have AB, John, and Lena. If we only want the first row, so we'll do the exact same thing. So we'll just write down 1. So we'll only generate AB. All right, so let's say right now we want to generate the last row. So we want to start generating from the employee number 5. So in this case, we are going to use another function that is called tail. So we will write down the exact same thing. So we have our database, we'll print our table, but we'll write down dot tail. And in this case, we want to generate which row. So let's say we want to generate only the 5th row. So we'll write down tail and in the parentheses, write down 1. So basically it's gonna simply start calculating from the down. So from the last one. So tail will start calculating from the last one. And head will start calculating from the first one. So let's say we write down tail and we write down 3. It's going to generate the 3 last. So in this case, it's going to be Lena, Mark, and Bob. So I think you guys get the point. So basically, if you want to generate the first elements of your database, you'll simply use head. So let's try it out. We write down head and we run our app. And if you guys want to generate the last elements of your database, it's gonna be tail. So basically same thing, but just write down tail, and you can run your app. And as you can see, it's gonna generate the 3 last elements of your database. All right, so that's it for this class, guys. I hope you have learned a new function of Pandas as well as Python. And see you all in our next class, where we are still going to talk about Pandas. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in this class, we are still going to talk about Pandas and some basic operations that you guys can perform with this amazing plugin to Python. So basically, today we are going to learn how to merge some data frames together. And what exactly means merge? It's pretty simple. It's, let's say, for example, you guys have more than one data frame. So let's say 2, 3, or 4 data frames. You can put them together in only one data frame. So basically, if each of those data frames are the same, so there is the same thing written on them, you can just put them all together in only one data frame. And even if there are some things that are not pretty much the same, you can keep some columns common by adding something to this operation. So we are gonna see how it works a bit more in depth right now. All right. So to be able to make work everything to run it pretty much well, to understand how this works, what we'll do is pretty simple. We are going to create a data frame. So pretty simple. We are going to do what we have learned to do in the past few classes. So first of all, we are going to import our pandas. So basically, here we go, SPD. And from now on, what we'll do, we will create 2 databases, so 2 basic databases. Let's say it's gonna be food. So basically, we'll have the number of the food, the name of the food, and finally, let's say the rate or the price of the food. So let's say we'll have here database that will be food1. And from this moment, we are going to create our database. So what we'll have at first is pretty simple. We'll have the number of the food. So basically, you can just give a number to your food. And in this case, the number will be from 1 to 5, since we are working with food. So 1, 2, 3, 4, and 5. All right. Then the next thing that we will have will be the name of the food. So basically here we'll give name to our food. So let's call it name. And let's do the exact same thing. So let's say we'll have apples. We'll have bananas. We'll have, I don't know, we can have pizza. Or anything that you want. You can just write down letters because it's just for the purpose of understanding how this works. So let's say apple, bananas, chips, popcorn, and let's say, I don't know, beans, or pizza. Pizza is better. Here we go. All right, so we have our 5 foods. And the last thing will be price. So basically we'll have here a variable that will be price. So we'll have a list of all the prices. So here we go. We'll have, let's say, $2, $3, $4, $8, and $6. All right. So we have our first database right here. So basically our first dictionary or list of databases that we will use to create our database. Then next thing, we'll create a second one a bit lower. So we have food1, and we'll do the exact same thing. So we'll create another one that will be called food number 2. And what is gonna be very interesting is that we'll keep everything the same. So to understand how it works, the merging, we are going to keep everything the same. And what we'll do right now, we will create data frames. So basically a bit lower right here. So we'll have our table 1, or you can call it food 1, table 1, how you want it. And from this moment, we'll create our data frame. So how exactly we create our data frame? Like always, we're gonna use pandas to create our data frame. So we will use the PD extension that you guys can see right here. So pd.dataframe. Here we go. You can find it right there. And from this moment, we are going to use food1. So food1 for our data frame. And we'll do the exact same thing for our table number 2. Here we go. So don't forget, just change the name when you copy and paste everything. So right now what we have our list of everything that we are going to use, or our dictionary. So for food 1 and food number 2, it should be pretty much the same thing. So what we want to do right now, so we have our data frames that are created right here. So as you can see, table 1 will be the data frame of food 1, and table 2 will be the data frame of here food number 2. So very important, number 2 as well. And from this moment, we want to fusion everything together, or merge everything together. So basically what we'll do, we will create a variable that will be named fusion. So we'll call it fusion. And here we are going to merge everything together. So basically we are going to write down, once again, we are going to use our PD extension that refers to pandas. And here we'll use the formula merge. So basically the function merge to merge table 1 and table 2 together. So table 1 as well as table 2 together. So right now here what have we done? It's pretty simple. Here we have merged the 2 tables together. So this is the formula to merge the 2 tables together. So as you can see, it's pretty simple. And what we want to do right now is simply print the variable fusion. Here we go. So we'll print fusion. If we run the app, as you can see, what happened, it simply printed everything together. So basically you have merged the two databases together. So let's say, for example, right now, instead of apple right here, we write down corn, and we run once again our app. What's gonna happen is that the apple will disappear because it's not the same thing. So what we'll do, it will merge the two databases together. But if it's not the same thing, well, it's just not gonna merge it, and it's not gonna appear right here. So basically it will just merge everything that is the same in the 2 columns right here. So in the 2 databases, the database number 1 and the database number 2. Right now, let's say that you guys want to keep some columns common and basically make it work, even if here we have corn and here we have apple. So basically, let's say here we have corn, here we have apple. The price of the corn is not $2. It's gonna be, I don't know, $8, for example. And here we don't have chips. We have, let's say, beans. All right. So let's say we want to keep the column name, so common. What we'll do, it's pretty simple. Right here, after our table 2, we will simply add a comma and write down on. So on equal to what exactly we want to keep common. So we want to keep the names common. So basically we'll just write down name because we want to keep the name common. And if we run the app, as you can see, what's going to happen, we'll have our names. So right here we'll have our banana, and we'll have everything that we want. So basically we keep the name common right here. If we want to do the exact same thing for numbers, we can do it. So we can just put everything, we can just take it and write down numbers. And we run everything together. And as you can see, it's going to do the exact same thing. So the numbers will be common in this case. So as you can see, the corn appears. And we have our corn for $8. And we have our apple for $2 as well. So as you can see, it's pretty simple to understand. So basically, the first thing that you guys want to do to be able to merge your, not functions, to be able to merge your databases, it's pretty simple. What you want to do at first, you want to create your databases. So basically here you will have your lists that will be used for databases. Then you simply put those, you create data frames with those databases that you have, well, with your lists. You put all your lists in form of data frames right here with this function right there. And then you simply merge everything with the function right here. So I hope you guys understood this operation. So it's pretty simple. What it does, it simply puts together 2 databases that are not together, And when I say together, it will simply put together everything that is the same in the two databases. So everything that is not the same will just not be put inside of this database. But it's possible to keep some columns common as well with the on function inside of our merge function. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So basically in today's class, we are still going to talk about some pandas operation, and the main operation that we are going to talk about today will be joining operation. So basically, what does this mean? It's pretty simple. So let's say you guys have two databases and you want to join them together. So putting those two databases together. To do this, you will be using the join function, and you'll see it's not really hard to do, and it can make really good results. All right, so before we start, what we'll do is pretty simple. We'll import the pandas extension. All right, so when this is done, what we'll do right now, we'll create our two databases. So basically the list that will be used inside of our database. So we'll work with the exact same thing. So we will work with foods, and it's going to be really simple. So the first list will be called food1. So here we'll have our food1, and basically we'll have the number, the name of the food, and the price of the food. So basically the same thing that we used in the past class that we did. So basically for the number of the food, we'll have numbers from 1 to 5. So we'll have number 2 points, so from 1 to 5. Then we'll have the name of our foods. Here we go. So for the names, like always, we'll have apple, banana, chips, popcorns, and pizza. So pretty simple. So chips, popcorn, and finally pizza. All right. And finally, the last thing that we will have will be the price of our foods. So as always, here we'll have our price. All right. So here we'll enter the prices. So let's say it's going to be some random numbers. So let's say 2, 6, 4, 3, 5. Here we go. So we have our prices. So we have our numbers, we have our names, we have our foods, we have our prices. All right. So this would be for the first part. Then we'll create our second list for our second database or data frame. We'll call it food2. And inside of this list, we will have some other variables. So here we'll enter colors, weights, and finally quantities. So let's say colors will be, in this case, so we'll call it color. So for apple, it's gonna be red. For banana, it's gonna be yellow. For chips, it's gonna be orange. For popcorn, it's gonna be white. And for pizza, it's gonna be, let's say, blue, because we're having a blue pizza. And finally, the last thing that we are going to use, well, we have two other things, sorry. So we'll have the weight. So the weight in, let's say, I don't know, gram. So weight. Let's say for the weight, it's going to be, in this case, Here we go. Right, then for the weight, what we'll have, let's say 100 grams, 200 grams, 150, 175, and finally 225. Great. Finally, the last thing that we are going to have will be the quantity. Here we go. And we can enter it right here. So basically for the quantity, let's say it's going to be 1, 2, 1, 3, 4. Great, so we have everything that we need. So we have our database, our list for the food 1, our list for the food 2. Next thing that we want to do is really create our data frame. So basically we'll create the formula to create our data frame. Just a quick parenthesis, it's possible to write down a line of code that will automatically create the data frame and at the same time enter all this list of things that we will use inside of a data frame. But once again, since I assume that you guys are doing this for the first time, I'm going in 2 steps. So basically we are entering everything right here and then we are creating the data frame. So basically we'll have table 1 in this case. And as always, we'll use the Pandas extension, data frame, and we'll enter food 1. We'll do the exact same thing for food 2. Here we go. So we have our table. Then we want to do the exact same thing for the food number 2, as I said. So here we start using our Pandas extensions. Then what we'll do, we'll fusion everything together. So as like in the past class, we use the fusion variable. We'll do the exact same thing. We'll give it the exact same name. So it's going to be fusion. But in this case, we will work with the join function. So how exactly does this work? So basically we'll use the table number 1. So it's going to be table number 1 dot, and then we'll write down our join function. So basically join, we want to join table number 1 with table number 2. So in this case, we have our table number 1 right here that we just created that will use the data frame of all the elements inside of the list right here. And we want to join this table 1 with the table 2 that have been created right here that will use all the elements of the list right here. So when everything is done, what we want to do is simply print our fusion variable. So we simply print fusion. Here we go. So when everything is done, we can simply run the app. And as you can see, we will have our 2 data frames right here mixed together. So basically, as you can see, we'll have number 1. It's going to be apple. The price of the apple will be $2. The color of the apple is red. The weight is 100 grams. And finally, the quantity will be 1. So what have we done? It's pretty simple. We simply joined or put it together the list right here, or the database that is content right here that works with the list right here, and the data frame or the database that is right here and that works with the list right here. So as you can see, it's pretty simple to do, and it can be a really effective operation. We can do, well, there are plenty of things that you guys can do with it, but those are just the basics of what you can do with a joining operation. So that's it for this class, guys, and see you all in our next class. Guys, and welcome back for another class of our course about the complete introduction to data science with the use of Python and many other tools. So in today's class, we are going to learn some really interesting things that is called munging. So basically, this is an operation that you guys can perform with Pandas when you use it with Python. And what it does exactly, it's pretty simple. It will simply convert your plenty of file types into some other file types. For example, for the purpose of this course, we are going to convert an HTML file, a CSV file, sorry, into an HTML file. So you'll see it's pretty simple. So before we even start, we need to create our CSV file. So I'll ask you guys all to open up Excel and just create a small table that looks like this. So basically you need numbers, letters, and you can write any words that you want. Just create a basic table, and we can start like this to create our CSV file. When it's all done, really important, you need to save this file in CSV. So don't save it into Excel, because if you do, it's not gonna work. So really important, save it in CSV. All right, So when everything is done, simply create yourself a folder. So before even creating your file, you need to create a folder that you will save on your desktop, because you will need to know where exactly your file is stored. So as you can see, the file is stored right here. All right, so what we want to do right now is pretty simple. We want to write down the lines of code that will help us convert this file into an HTML file. So before we even start, we need to import Panda. So really important, import Pandas as PD. All right, when it's all done, the next thing that we need to do is read our file. So before converting it, we need to ask Python to read our file. And in this case, let's name it color. So we want to read color. All right, so to read our file, we're gonna ask PD, so pandas, to read. And here we can choose what type of file we want to read. So here we have CSV, Excel, and plenty of other file types that we can read. But we want to read a CSV file. So it's going to be the first one. And then we need to write down the location of our file. So you guys need to know exactly where your file is located. So as I said, the file location should be somewhere right. It should look something like here. So basically something like this. Basically, as you can see there, it should look something like this. All right, so your file location should be here. So you just open up your folder. Here you have your file location. Then you simply add another tab like this, and you write down your file name. So in my case, it's work. And don't forget at the end, write .csv, because if you don't do that, it's not gonna work. So really important, don't forget your .csv at the end. All right, then to be sure that everything works fine, you just need to run everything. And as you can see, if the process finished with exit code 0, this means that everything works perfectly. All right, so the next step would be converting our file into an HTML file. So how exactly we'll do this? It's pretty simple. So we will write down our color. So basically this is the name of our file, dot to what we want to convert it. So here we can choose to what exactly we want to convert it. We want to convert it to HTML. So we will write down to HTML. And how exactly we want to name it? Let's say we want to name it nice colors. So in this case, we'll just name it nice color. Here we go. Then we can run our file. And if everything works fine, you guys should receive a text file right here. If you open up the text file, you will see here you will have all the HTML code linked with your file. So as you can see, if we go right there, here you will find your HTML, you will find your file that should look like this. And this is the HTML code that is linked with your file. All right, next thing that we want to do, we want to create a HTML file because this is a text file. So we will create an HTML file. We'll name it nice color 1. When it's done, we'll simply take all the code that we have here. So basically this is the code in HTML. We'll copy everything and we'll simply paste it here. So here we go, we have our HTML file here. So basically when it's all done, you guys can run your code. So you can choose your web browser. In this case, I'm gonna run it with Mozilla. So as you can see, I run it right here and I have my tab right there. So everything works fine and perfect. So let's just compare the two files. So let's compare the two tabs, sorry. So basically I have my tab right here that I created, and this is the tab that have been generated as HTML code. So as you can see, it's really cool. And I'm able to convert my CSV file into an HTML file with a simple line of code. So as you can see, it's pretty interesting. Once again, what I'm doing right now is really basic level, so you guys should be able to do it. And if this is just basic level, usually you can do some really cool stuff when you get more advanced and when you practice more. So I hope you guys liked the Pandas part. So it's a really good tool, and if you guys learn how to master it, you'll see there is really interesting things that you can do with it. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So until now, we talked about some tools that we can use with Python to be able to perform data analysis. So we talked about NumPy, that is specialized in mathematics and to do some really complex operations. And we talked as well about Pandas, that is specialized in data analysis. Today we are going to talk about SciPy, that works pretty much with NumPy. So basically it works with NumPy and it integrates NumPy operations, and it will help, well, it will allow us to make some complex operations to be able to perform data analysis as well. So basically, let's start and try to understand what exactly is SciPy. So basically, SciPy is like any other tool that we talked about in this class and we'll talk about in this class. It's a Python library. What is cool about it is that it's open source. So once again, as the other libraries that we are talking about, it's open source, so it costs nothing. And it's built up by the community, which is pretty cool. So it works with NumPy to allow more mathematical functions. So as I said a little bit before, basically it uses a lot of NumPy operations, and it works really with NumPy to allow some more operations. And it comes with many modules for commonly used tasks in scientific programming. So basically we're gonna talk about some of those modules, and we are gonna talk about some example of modules that can be used in SciPy, because there is a lot of them, and what makes SciPy really a powerful tool if you guys want to use it for data analysis. All right, so SciPy versus NumPy. So what is the difference between SciPy and NumPy? So what is really important to understand is that NumPy is really for basic operations such as sorting, indexing, and some other elementary functions. So if we need to really understand the difference between those two, we can say that NumPy is basically for basic operations, like I said, and SciPy contains all the algebraical functions, some of which are there in NumPy to some extent and not in full-fledged forms. So basically this would be the main difference between NumPy and SciPy. What are the advantages of using SciPy? So as I said a little bit before, one of the first advantages of using SciPy is that it's open source. So basically the fact that it's free, it's way better to use it. And also, if, for example, compare it to Matlab or any other program such as Octave, for example, SciPy, well, it's open source. So basically just with this, it starts automatically with an advantage. And also it's as powerful as those tools. There is a high level of commands to manipulate and visualize data, which is also really cool. So basically there is a lot of commands that you guys can use, and it's you will be able to visualize your data. It's powerful and interactive sessions with Python. What does it mean? It means simply that it works perfectly with Python. So basically with the Python programming language, it works really smoothly, and it's not complicated at all to use. Well, you need to understand programming, but once you understand the concepts and the logic behind it, you'll see it's like any other tool that we talked about a little bit before. It's not really complicated to understand. And finally, it's easy and fast. So basically easy, maybe not if you're a beginner. You need to understand, as I said, the logic behind programming, all everything that you need to understand. So basically all the programming mindset, and once you get it, well, you'll see it's not that hard to understand. All right, so right now let's talk about some of the sub packages of SciPy, because there is a lot of them. So basically the first one will be the cluster or hierarchical clustering. We have the constant, which is the physical constant and factor of conversion. We have the FFF, the triple F pack, which is the algorithm for discrete Fourier transform. We have integrate, which is the routine for numerical integration. The interpolate, so the tools for interpolation. IO, which is the input and output tools for data. LinLG, which is the routine for linear algebra, and many others. So I'm not gonna cite them all because, well, it's gonna be really long because there's a lot of them. But those are pretty interesting and works, are really useful in the case that you guys wanna make some data analysis. So basically, the modules are, there are plenty of modules that could be, for example, we have linear algebra, integration, ordinary differential equations, solving, and many more. So basically there is a lot of modules that are integrated with SciPy. So basically it allows us to make really advanced mathematics, which can be a really good thing when we know that data analysis and data science is really something that requires a lot of mathematics. So I hope you guys have a little introduction to SciPy. Once again, in the next few classes, we're gonna talk about a little bit more in depth about SciPy, and we are going to use this tool to resolve some real problems, and we are going to learn some operations that are really popular with this tool. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are going to talk about some really basic SciPy functions that can be used inside of Python. So as always, the first thing that you guys need to do is import SciPy inside of your Python. So basically, it's pretty simple how it's gonna work. It's like with any other things that we did. So basically, you just go inside of your settings, and then you go inside of your Python interpreter right here. Then you click on the little plus right there. You look for SciPy, and you simply click on import. So basically, it works pretty much the same way as for any other thing that we imported. So it's pretty simple. Just click on install package. So when you will install your package, it should be somewhere right here. So it will be right there. All right, so when you guys are all ready, the next thing that we will do right now is write our first basic functions with SciPy. So as always, the first thing that we need to do, we need to import SciPy inside of our Python, the text editor. So pretty simple. What we'll do, we'll simply write down import. Here we go. So we will import SciPy as SP. Now the next thing that you guys need to understand is that all the sub packages that will be used in SciPy has to be imported before being used. If you guys don't import the sub packages that you will want to use, you will not be able to use them, and you will receive an error message. So it's really important to import each sub package. When I'm talking about sub packages, I can talk about, for example, interpolation. This could be one of the sub packages. Integrate would be another sub packages. Cluster, which is a really interesting sub package, is another sub package. Constant is also another sub package. So there is plenty of sub packages. For the purpose of this course, we will import a few of them. So just this way, you guys will see what it looks like to import sub packages. So pretty simple. How do we import a sub package? We simply write down from. So from where we want to import our sub package? We want to import our sub package from SciPy. So really important to write down from SciPy. So we import our sub package from SciPy. And what sub package we want to import? So we want to import, in this case, integrate. So integrate. So here we go, we have a sub package from SciPy that we just imported. So we have imported integrate. Let's say we want to import, cluster, for example. So it's gonna work the same way. So let's say we'll write down from SciPy, import cluster. So right now we have imported integrate and cluster. We can import another sub package which would be fftpack. So this is used for Fourier transforms. We can import it. So let's import it as well. So from, in this case, SciPy, import fftpack. As you can see here, we have imported 3 sub packages. So basically, this will allow us to use all the functions that are with those sub packages. All right. The next few functions that we are going to talk about will not necessarily make any operation. It's just some operations that will give you information or simply help about the sub packages. So the first function that we are going to talk about will be the help function. So basically what it does, it will simply return you informations about keywords, functions, or classes that you guys would work with. So it's pretty simple. It's gonna, once again, it's really important to import the sub package that you want to receive help about, because if you don't import the sub package, you'll simply receive an error message. So in this case, we have imported 3 sub-packages. So what we'll do, we will seek help for one of those sub-packages. So let's say we want to have help for our integrate sub-package. So we'll write down help and then integrate. So we want to receive help about this sub-package. So pretty simple, simply you write down help, open up your parentheses and write down integrate. And when you run the app, you receive all the help about the integrate sub-package. So basically you will receive all the information about this sub-package and different formulas that you guys can use about it. If you just want to write down help, so in this case, let's say we write down help, what's going to happen? You'll receive help and then you will need to write down the sub-package about which you want to receive help. So in this case, we want to receive help about SciPy dot integrate. So about this package right here. And we just run the app. And as you can see, it's going to do pretty much the same thing. But if we don't import the sub-package, you'll receive an error message. So in this case, we have those 3 sub-packages. Let's say I want to work with ND image sub-package. So in this case, I'm going to write down ND image. And if I decide to run this, I'll stop this app right here. And I decide to run this app, I'll receive an error message because I didn't import this sub-package of SciPy. So basically, it's not going to work. All right, the next function that we are going to talk about will be the info function, and it works pretty much the same way as the help function. So it will return as well information about the keywords, classes, and functions. And once again, it will return some other type of information. So what we'll do, it works pretty much the same way. So in this case, we'll write down SP. So because we imported SciPy as SP, so we want to make a reference to our SciPy. So we use SP. Dot, in this case, we want information, so dot info. And we want information about our list, let's say FFT pack. So FFT pack. So we want information about this sub-package right here. And what we'll do right now, we'll simply run our function. So as you can see, you will receive all the information about this sub-package. So it's pretty interesting. So it's not the same thing as the help function, but it gives us a lot of information as well. So this is how you guys, if you need info about a certain sub-package, this is the way that you can use to be able to get this information. And finally, the last thing that we are going to talk about, or the last function that we are going to talk about, would be the source function. In this case, this function will simply return the source code of objects that are written in Python. So it works the same way. We are looking for the source of a certain sub-package. And it works pretty much the same way. So it's the same function. So we are making a reference to our SP, to SciPy. So we want, in this case, the source. So we are making reference to SciPy and we want the source of, let's say, the cluster pack. This is the one that we didn't use. So cluster sub-package. And we run our function right now. So what we'll receive all the source code of all this. So all the source code of this sub-package. So once again, as I said, those 3 functions are pretty simple and they give you more hints and help about different sub-packages. It's not, those are not functions that will give you abilities to make some operations or some other things. Once again, those are pretty simple operations that you guys can use just to get a really small and basic introduction to SciPy. So I hope you guys right now have a basic understanding of SciPy and how to use those really basic functions. So that's it for this class, guys, and see you all in our next class when we'll do a bit more interesting functions. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in this class, we are still going to work with SciPy and we are going to have an introduction to special functions or the special sub-package. So basically those types of functions are pretty cool because it gives you access to dozens and dozens of functions that will allow you to do really interesting things, such as having access to really advanced math and statistical functions. So basically, some examples of those functions would be, for example, the elliptic functions and integrals, would be the B-cell function, the array function, you will have derivative, you will have spherical B-cell functions, you have, for example, raw statistical functions, so plenty of them. And all those functions are pretty interesting if you guys have a really strong mathematical knowledge and want to do really advanced mathematical applications. So to have access to this sub package, it's pretty simple. The first thing that you guys would need to do is, as always, import your SciPy. So this is exactly what we'll do right now. We'll import our SciPy, so SciPy as SP. When it's done, the next thing that we want to do, we want to be able to work with our special functions. So we'll simply import the special sub package. So from SciPy, we want to import special. So we want to import all the special functions. So as I said, you guys will have access to plenty of those functions, so really advanced mathematical functions. So what we'll do right now, we'll simply test one of those functions, which is the Kelvin function. And you guys will learn how to write it down. So pretty simple. The first thing that we want to do is simply write down special. So we want to work with the special sub package inside of SciPy. So write down special dot. So we want to work with which function? In this case, we want to work with the Kelvin function. So special dot Kelvin. And next thing that we want to do is simply choose an argument, because inside of the Kelvin function there is only one argument. So in this case, we will write down 15. And we want to print all this, so we'll simply write down print. Or let's make it simple. Let's store it inside of a variable. So let's call this variable fun1 would be equal to special Kelvin 15. What we want to do right now is simply print our variable fun1. All right. So let's run the app and see what it looks like. So basically we have everything that is set up. We can run our app. And as you can see, this is the answer of Kelvin 15. So basically this would be our answer right here. It's printed right there. All right, so as you can see, this is one of the hundreds of different special functions that we have access to. There are plenty of them. So basically, if you simply make a simple research on Google, you will be able to find out all of those functions. All right, next thing that we are going to talk about are some really basic functions. So basically, in this case, we are going to talk about convenience functions. So basically, those functions are, in my opinion, really simple to understand, and we'll try a few of them. So basically, we are going to calculate the log of certain numbers, so x log y. So basically, we'll do this function. We'll also do the exponential 10 function and the exponential 2 function, and also try some x and, some cos, sin, and tan functions, just for you guys to see what it looks like. So let's start with the first function, which will be the x log y function. So how exactly do we write it down? It's pretty simple. We simply write down fun equal 1 equal special dot, and in this case right now we want to have access to our function, which would be x log y. So basically in this function there are two arguments, and what it will do, it will simply compute x multiplied by log y, so that the result is 0 if x equals 0. Basically, since we're multiplying x by log y, if x is 0, logically it's gonna be 0, because 0 multiplied by anything will be equal to 0. All right, so let's try this function out. So once again, you don't need to understand all those functions, you just need to understand the big picture and the concept of all this. So basically how to write those functions down. All right, so x log y, and right now let's say the first argument of our function will be 2, and the y of this argument, so we have the x and the y, would be, let's say, 10. And we want to print fun1. If we run the app, this would be our answer. So basically what it does, it simply multiplies x by, so x would be r2, by the log of 10. So in this case, it's going to be 4.605. All right, next thing that we can do, we will use another function that will calculate the exponential exp10. So basically we'll compute 10 by how much times we want. So basically it's going to be 10 at a certain power. So it could be 10 power, let's say 10, or 10 power 2, 10 power 3. So it's a really simple function once again. So it's exp10. So it's going to be written down the same way. So special dot exp, in this case 10. So once again, we want to have our 10 at power, let's say 5. So it's gonna be 10 multiplied by 10 multiplied by 10 multiplied by 10 multiplied by 10. So this would be our answer. If we put 10 at power 50, it's gonna be a bit bigger. So as you can see, this would be our answer. So basically it's gonna be 10 multiplied by 10 50 times. All right, so this is for our second function. Another thing that you guys can do inside of convenience functions, you can calculate the cos, the sin, and the tan of different things. So basically this can be used inside of trigonometrical calculations. So if you guys work in with trigonometry, you can calculate trigonometrical calculations. So we can try it out. We can try just to make the calculation for the cos, for example. So pretty simple. How we will write it down will simply be our variable right here. So fun1 special dot, it's gonna be sin dg, because we want degrees, work in degrees, and let's say we have 30 degrees. So in this case 30 degrees, and we want to print this variable right here. So basically the sin of 30 degrees will be this. We can do the exact same thing for 60 degrees, for example. So the sin of 60 degrees will be this. We can do it for 90 degrees. So just, you guys will see what it will look like. Oh, it gives us 1. We can use the sin, we can write down cos. It works pretty much the same way. So here we have the sin, we can write down cos. So as you can see, it's going to be minus or 0. It's going to be 0, the answer. So as you can see, those are just some examples of functions that, special functions that exist. You can do plenty of other things, and there are plenty of other functions that exist inside of special functions. Once again, I'm not going to demonstrate them all because it's going to take us a lot of time for nothing. But once again, just for you guys to understand that this sub package of SciPy is really interesting if you guys want to make more advanced mathematical Python apps. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with the use of Python. So in this class, we are going to talk about another sub package that is included inside of SciPy, and in this case, it's going to be the integration package, which is integrate. So basically, to understand this package, to understand what is it, I'll have a simple definition. Basically, the SciPy integrate sub package will provide several integration techniques that includes an ordinary differential equation integrator. An overview of the model is provided by the help command. So basically, you can use the help integrate methods for integrating functions given function objects. In other words, the integration function is simply used to find displacement areas, and it can deal with adding slices to determine the whole, so the complete whole that we have. So yes, it can sound complicated at first, but once you are used to use this, those functions, you'll see it's not that complicated. So to understand the integrating sub package, I have two functions that are not that complicated, but you need some basic mathematical knowledge to it. It's the quad function and the DBL quad. So basically, the quad function will simply calculate the integral of a function which has one variable, and the DBL quad function will calculate the double integral of a function which has two variables. So basically, we'll work with one as well as two variables. Once again, my goal right here is not for you guys to understand completely those functions, but simply to understand how they work. And after that, it will simply be practice. All right, so let's start. So basically, the first thing that we need to do is pretty simple. It's importing SciPy as we always do. So we'll import SciPy as SP. Then what we want to do is we want to import our sub package. In this case, the sub package that we will work with will be integrate. So basically, how do we import our sub package? It's pretty simple. We write down from SciPy import. So what exactly we want to import? We want to import integrate. So here we have our sub package that we have, the sub package that we have just imported. And now what we want to do is we want to work with our first type of function. So in this case, our first function will be the quad function. So basically, the quad function is a method that can get the integration of a given function from limit a to b using our function. So in other words, what does it mean? It will simply calculate the integral of a function which has one variable. In the difference, the dbl quad, the function that we are going to talk about a bit later, will calculate the double integral of a function which has two variables. So basically, the first one has one variable and the second one has two variables, but it's going to be a double integral as well. All right, so how exactly does everything work? Pretty simple. First thing that we need to do is we need to create a variable. So let's create a variable, and this variable, let's call it variable 1, so var1. Basically, in this variable, what we'll set, we'll write down our parameters. In this case, it's gonna be lambda. So lambda x, 2 points. And how exactly we want lambda x? So basically, we want lambda x to be x exponent 3. So x multiplication sign 2 times 3. Then what we want to do, we want to create our calculation variable, so a variable where we are going to store all our calculation. So let's call it function 1. So function 1 in this case will be equal to integrate. So once again, right now what we write down, why we write down integrate? Because we are going to look for a function that is inside the integrate sub package, and the name of this function is quad. So since we're working with the quad function that is integrate inside of the integrate sub package, we write down integrate.quad. Then next thing that we need to write down would be our parameters. So the first our parameters are stored inside of var1, so we just write down var1. And then we need to write down our limits. So our limits would be, let's say, between 0 and 6. All right, next thing that we want to do is print everything. So simply write down print. And what exactly we want to print? We want to print function 1. So here it is right there. Then we run our app. So you'll see it's going to take a little bit of time, but in this case, it was pretty automatic. So this would be the answer of this integration. So basically, it will look something like this. All right, so right now that we have that you guys saw what it looks like to make the integrate quad function, let's make it a bit more complicated and work with the dbl quad. So basically the double integration of in this case 2 variables. So basically we'll have a function that has 2 variables, so x and y. So what we'll do right now, we'll simply delete the first part and we'll keep var1. So basically var1 in this case will be equal to, we need an x and a y because we have in this case 2 variables. So basically we'll have our y at first, then we'll have our x. So write down x and y, 2 points, and then we can write down our operation. So let's say in this case it's gonna be x multiplied by, I don't know, y exponent 4, something like this. All right, then when we have this, the next thing that we need to do, we'll do the exact same thing. So we need to create our function, so our variable where we will store our calculation, and we can write down our function. So it will work pretty much the same way. So it's gonna be integrate point. So right now, since we're working with the integrate sub package, we start with integrate, then write down our function, which will be dbl quad. So in this case, we have it right here. First thing that we'll write down will be our parameters, sorry. So var1. Then we write down our, in this case, our limits. So our limits, let's say, would be between 0 and 6, like we did in our first example. And then we'll write down our function, which would be, let's say, for example, lambda x will be 0, and lambda x 1. All right, so we have everything that we need. Next thing that we'll do, it will simply print our function. So we'll print function 1, and we can run our app. So what we'll do, once again, it will give us the answer of the double integration. All right, so as you can see, guys, yes, it's a bit more complicated to understand, and to be able to explain you all this, I need to make a separate course about all those functions, because you need a good mathematical knowledge. You need really a good mathematical knowledge. Once again, my goal here is really to give you an introduction so you guys understand a little bit how all this works. So I hope you guys are able to write down those functions, have been able to write down those functions. And as you can see, you have this sub package inside of Python, inside of SciPy, sorry, that is inside of Python, that you can use if you guys decide to make some more advanced Python apps in the future. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with the use of Python. So in today's class, we are still going to talk about SciPy and how all this works. So basically how works SciPy, which is another tool inside of Python. So basically a Python library. So what we'll do today is pretty simple. We are going to work with SciPy as well as NumPy, and we are going to work with another sub package of SciPy, which is called Fourier. So we are going to make a Fourier transformation or Fourier analysis. So basically, for those who don't know what is it, Fourier analysis is a method for expressing a function as a sum of periodic components and for recovering the signals from those components. This is simply the main terminology of it. So basically, it provides a way to replace a number of functions in SciPy with its own functions, which are usually significantly faster via FFT. So basically, with this sub package interface. All right. So basically, how all this would work is pretty simple. We are going to use the FFT sub package to be able to perform this transformation, and to be able to perform this transformation as well, we are going to require an array. So basically we are going to work with an array, so NumPy. So we will need to import SciPy as well as NumPy. So basically, before we even start this, you guys need to check in your settings if you have imported NumPy and if you have SciPy. Normally you should have both of them. All right. So first thing that we'll do, we'll import SciPy as we always do. So we'll just import what exactly we want to import. We want to import SciPy as SP. Then what exactly we need to import? We need to import the NumPy library, so we'll just import NumPy as well as NP. So right now we have imported the two libraries that we need. Next thing that we need to import the sub package that is inside of SciPy. So in this case, what sub package we'll need? We'll need the FFT sub package to be able to run this transformation. So pretty simple, we will just write it down. So from SciPy, we want to import the FFT sub package. So right now we have imported the FFT sub package from SciPy, and we'll be able to use it. From this moment, what we want to do right now, we want to create our first array. So basically we will create a two-dimensional array. So for those who don't remember how to create an array, it's pretty simple. What we need at first, we need to create a variable where we'll store our array. So the name of the variable will be var1 as always, and we'll create our array. So basically we will start with np. So we are making a reference to NumPy via np dot, and then since we are making this reference to NumPy, we want to write down the function that we'll use. In this case, we'll use the function array. We open up the parentheses, and we can write down our array. So basically we will do as we always do, so even and odd numbers, so 2, 4, 6. This is what I usually do. If you guys want to write down other numbers, it's up to you. So 1, 3, 5. So basically we have a two-dimensional array, as you can see. All right, so what we'll do right now, Usually, to be sure that everything works fine, I like to print my array. So we'll print it and look what it looks like. So basically, if we didn't make a mistake or if there is no problem, and if there is a problem, we can correct it. So as you can see, there is a problem here. I wrote dots instead of commas. So I'll correct it. So what we'll do right now, we'll just rerun the app. And as you can see right now, it works pretty fine. So that's amazing. All right, so right now we have our first variable, which is our array. So our array is stored inside of our variables. What we want to do right now, we want to create a second variable, which will be used to make the transformation. Let's call it, in this case, trans1. So this would be transformation 1. So inside of trans1, what we'll do, we'll use the function fft. So pretty simple. How exactly we use it? We want to use a SciPy function, so sp function, that is in the sub package fft. So fft, basically fft. All right, so from this moment, what we'll do right now is pretty simple. We want to make this transformation to our variable var1, which is just there. So as you can see, our var1 is right here. So from this moment, what we want to print right now, we want to print trans1. Since we made a transformation to var1, so we have our array right here. Here in this line of code, we are making our transformation via this operation right here. So we are applying this operation right here to this function right here, to this variable right here. So what we want to do right now, we simply want to run everything. And as you can see, the transformation have been made, works. So it works pretty fine. So this would be the answer of the operation. So as you can see, guys, this is exactly how we can do a Fourier transformation or a Fourier analysis. So as you can see, it's pretty simple to do. All right, so I hope you guys understood everything. It's not that complicated, and I hope you guys saw that you can use NumPy as well as SciPy together. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in today's class, we are still going to talk about SciPy, and this is our last class about this amazing Python library. So basically what we are going to learn today, what we are going to talk about today will be linear algebra and all the functions that we can use with linear algebra inside of SciPy. So basically, as I said, there is plenty of sub packages that exist in SciPy, and one of those give us access to the majority of linear algebra functions that exist. So basically, we are going to learn two of those functions, which are basically the solve function, which will solve an operation of linear algebra with the two square arrays. So basically, we're going to create square arrays with the use of NumPy and simply solve them together. And we are also going to generate the reverse of an array. So basically, with the env function. So there are plenty of functions that exist with the basically not SciPy, but the linear algebra. So the sub package that is linear algebra inside of SciPy. So some of those functions will be, for example, the basic functions, which will be the solve function, the norm function, the PNV function, the PNV2 function. We have the eigenvault problems. We have matrix functions, we have matrix equation solvers, we have special matrices, and plenty of others. So basically, the linear algebra part of SciPy is really huge and is really well built. So basically, if you guys are advanced in linear algebra, you can do pretty much anything you want with SciPy if you want to build up an application that uses linear algebra with it. So it could be for data science, it could be for any other personal project. All right, so as I said, the functions that we are going to use today would be the env function that will compute the inverse of a matrix, and the solve function that will simply solve the linear equation set of our two matrices for the unknown x for square a matrix. All right, so let's start. Basically, the first function that we are going to learn will be the solve function. And before we even start, what we need to do, we need to import NumPy as well as SciPy because we are going to use both of them. So, as always, we are going to import SciPy. And then we are going to import NumPy because we will need to create arrays. Here we go. When it's all done, what we want to do, as I said, we are going to work with the linear algebra. So we need to import the sub package linalg, which would be the linear algebra sub package. So simply write down from SciPy import linalg. So basically this would be the linear algebra sub package. Right now, what we want to do, we need to create our array. So basically we have imported everything that we need. Now it's time for us to start our operation. So let's create our arrays. So what we'll do right now, we'll create two arrays. So we'll call it array1. And for array1, we'll have two square arrays. So basically it's going to be two lines of two numbers. So pretty simple. So how to write down an array? So np.array, we open up the parentheses. And here we can write down one entry. So basically even numbers. And in the second array, we'll write down odd numbers. So it's going to be 2 and 4. All right, so for the second one, we'll do the exact same thing. So we'll just copy everything from here to there. We'll call it array number 2. And what we'll do, we'll just change the numbers that are inside. Let's put 5 and 9, and here let's put 2, well, let's put 6 and 8. All right, so we have our numbers. Amazing. So right now we have everything that we need. So what we can do to be sure that everything works fine, so we can print array1, here we go, as well as array2. All right, so everything works fine, everything is perfect. So as you can see, everything is great, everything works. So now it's time for us to make the operation. So basically, as I said, the first thing that we'll do, we'll solve the operation that will work with array1 and array2. And basically the goal here would be to solve the linear equation set. So a multiplied by x equals b for the unknown x for square A matrix. So basically in this case we'll have a and b. All right, so let's do it. So pretty simple. What we'll do right now, we'll create another variable. In this case we will call this variable function 1, and let's do it. So basically we will write our function. So it's gonna be sp because we are referring to SciPy, to a SciPy function. So we'll write down sp dot linalg, since it's a sub package of SciPy. So basically linear algebra is a sub package of SciPy. Next thing, we'll write down the function that we are going to use. So in this case, it's gonna be the solve function. And what we wanna solve exactly? We wanna solve array1 as well as array2. So array1 mixed with array number 2. So what we wanna do right now, we want to print function 1. Right, so I just made a little mistake. We'll write it down again. So basically it's gonna be sp.linalg.solve, and in this case it's gonna be array1 and array2. Great, so we have everything we need. So next thing that we need to do is pretty simple. We need to verify that there is no mistakes, that everything works fine. So basically in our case right now, everything looks pretty good. So we have our array1, array2. Here we go. So we have a little problem right here. We can just correct it. Here we go. And we can print absolutely everything. As you can see, this would be our answer right here. So it has solved the equation that gave us this answer right there. All right, so next thing that we want to do right now is pretty simple. What we want to do is calculate the reverse of our array right here. So pretty simple. What we'll do, we'll simply calculate the reverse of this array. So in this case, what we can do, we can simply write down function. So function, let's say, in this case, we didn't use function 1, we automatically printed it. So we can just write down function 1 and write it down. So basically, function 1 will be equal to our operation. So it's going to be sp.linalg, because we are making a reference to linear algebra functions. And the function that we are going to use will be the env function, or the reverse function. So in this case, we want the reverse function of array 1. And what we want to do right now, we want to print it. So basically, we'll just delete the print right here. And what we want to do right now, we want to print our function 1. So we'll just open up the parentheses and we'll write down function 1. All right, when everything is done, we simply run our operation. And as you can see, we have the reverse function of our array number 1 right here, or of our function 1. So basically, this is the reverse of array number 1. Calculated, it has computed the inverse of this matrix. All right, so you guys, I hope until now you guys saw everything that you can do with SciPy. So once again, you will not be a professional of SciPy after just this part of the course, but I hope you guys have a certain idea of what SciPy is. So I hope until now you guys like the course. I hope you will continue it, because there are plenty of other interesting things to learn. So that's it for this class, guys, and see you all in the next part of the course. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So until now we talked about many Python tools that can be used, such as NumPy, SciPy, and SciPy. And today we are going to talk about another really interesting tool that is used for visualization, that is called Matplotlib. So in this class, we are going to have a complete introduction to this amazing tool. So we are going to talk about visualization, what is it exactly, then we're going to talk about Matplotlib and understanding what exactly is inside of Matplotlib and what is the concept of a plot. So let's start. All right, so the first thing that we need to understand is data visualization, and why exactly is it that important in data science, or just in life in general. So what is data science? So basically, data science for me is a visual representation of results. So in this case, let's say you guys have a huge amount of data and you want to analyze this huge amount of data. So basically, if you guys are just using, if you're just looking at data without making it visual in form of graphs or any other way to make it visual, it's going to be really hard to understand. So it will be really hard to find answers to questions. For example, you are looking how much people on 100 people's likes pizza, where there is, for example, I don't know, onions on this pizza. So basically, you want to know how much people like to have this topping on their pizza. So basically, if you make it visual, so in a form of graph, you will be able to see how much people on this 100 people like pizza with onions on this pizza. If you're just looking at numbers, maybe you will not see it as easily as if you put it visually in a form of graph. So the second thing would be providing an accessible way to understand patterns in data. So once again, this would be, it could be for anything. Let me just give an example in the financial world. So basically, you are looking in patterns. Let's say you're looking at a stock and you want to look at a pattern that happens every day or every week or every month. So basically, you can do it with data visualization way easier than if you're just looking at raw data. So basically, if you're looking at daily data of a stock, you will not necessarily be able to see all the patterns and all the chart movements. But if you're looking at the graph, or you're looking at any other type of visual representation of it, it's going to be way easier to understand. And finally, it makes large amount of data easy to understand. So basically, data visualization, since it's a visual representative way of data, it can make really huge amounts of data really simple to understand. So basically, you can have millions of I don't know, numbers or elements inside of your database. But if you put it in a form of graph, it's going to be way easier to understand than if you're just looking at those numbers that are just raw data. So why we have to visualize data? So as I explained, it will at first help us with the comprehension of data that you study. So basically, if you guys are studying huge amounts of data, trust me, it's gonna be really hard to just study those huge amounts of data without representing them visually. So the best way to understand the data that you guys are studying is to visually represent it. And without a visual representation, basically it's almost impossible understanding the data that you are studying. And finally, it's very easy for our brain to understand visualized data. So for the majority of us, we are very visual as people. So basically, if we are putting something in a visual form, so basically we put it, I don't know, in a form of a chart, a graph. So for data, it could be chart, graph. It could be, I don't know, histogram, for example. It could be, well, anything. It could be a map, for example. So on those forms, it's gonna be way easier for our brain to understand it than if we are looking at just raw data. So those are simple examples of how data could be represented. All right, so in Python there is a way to represent data visually. So we talked about different tools that are math tools and other stuff in the past few classes, but to visualize data, there is a tool that is called Matplotlib. So once again, this is part of the Python library. So what exactly is Matplotlib? So Matplotlib is a plotting library for Python. In other words, it works pretty much like MATLAB. So for those who know what is MATLAB, so this is, we can say it, a free version of MATLAB, but that works with Python. Basically, it allows us to visualize data in form of plots or in form of charts, graphs, or many other things, which is pretty cool in my opinion, since it's an amazing way for us to represent data. So what exactly is a plot? It's a way to represent small or large amounts of data. So in this case, here are some examples of plots. So you have the bar chart right here. You can have the histogram right there. So it looks something like this. You can have scatter plots that are just dots everywhere. You can have area plots. You can have pie plots. So basically this is a pie chart. There are some other things that exist on Matplotlib that we are not necessarily going to cover them all. But we are going to talk about the basics, and basically in this part of the course we are going to create plots or charts with different with small databases that we are going to create. So I hope you guys right now understand what exactly is Matplotlib. So as you can see, it's not something that is really complicated, and it's just a way for us to make our data more visual, to be able to understand it. So that's it for this class, guys, and see you all in our next class, where we are going to setting up Matplotlib inside of your PyCharm text editor. And welcome back to another class of our course about the complete introduction to data science. So in this class, we are going to learn how to set up Matplotlib on our PyCharm text editor. So it's pretty simple. It's the same way that we have set it up Pandas, SciPy, or NumPy on our text editor. The first thing that you guys would have to do is simply go on the file right here, click on settings, and then as always, you'll go on your project and click on Python interpreter. When it's all done, simply click on the little plus right here, and you want to look for Matplotlib. So as you can see, it's going to be right here. It's a Python plotting package. So what you want to do right now is simply install this package. It's really important to install it, because if you guys don't install this package, you will simply not be able to do this part of the course, because you will not have this package on your PyCharm text editor. So as you can see right now, I have Matplotlib that is just installed right here, and I'm able to do everything that I want right now with Matplotlib. So basically I'm able to work with this Python package. So I hope you guys understood how to install it. So as I said, really important to do it. So this way you guys will be able to do the next part of the course. So that's it for this class, guys, and see you all in our next class. Welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are going to talk about Matplotlib and learn how to create a basic Matplotlib graph or chart. And modify this graph or chart. So basically this is one of the best ways that you guys can use to visualize data inside of Python. So to be able to do all this, I divided this course in four parts. So basically the first part, we are going to learn to import Matplotlib. So basically it works pretty much the same way as Pandas, NumPy, or SciPy. So things that we talked about in the past few classes. Then we are going to create a really simple graph, really create something basic so you guys will see what it all looks like. Then I'll show you a more advanced way to be able to write everything down. So basically how usually we write down functions. So this way we are able to create not only one line inside of our graph, well, not only integrate one function inside of our graph, but have like 4, 5, 6 functions inside of our graph. So basically more than one x and one y. So you can have an infinity of x's and y's. And then after that, we are going to add the titles, labels, and everything. And finally, we are going to change the style of our graph and make it more beautiful. So we are going to talk about all this inside of this class. So let's start. So basically the first thing that we are going to do is pretty simple. We want to import Matplotlib to be able to work with this Python library or package. And how exactly do we import it? It's pretty simple. So we will write down import, and what we want to import is matplotlib.pyplot. So we want to import all this as PLT. So basically PLT, you can write down anything that you want, but PLT is the usual name of matplotlib.pyplot. All right, so if you don't write this, down this line of code, normally nothing would work because you didn't import Matplotlib. So when everything is ready, what we will do right now, we are going to create a basic graph with just one function inside of it. So basically it's gonna be one line, so we'll have one x and one y. So let's write it down. So pretty simple, the first thing that we'll do, we'll write down PLT. So we are making a reference to Matplotlib by writing down PLT. And the function that we are going to use will be plot. So basically plot right here. And then we are going to write down our x's here and our y's here. So for the x's, let's say it's going to be 1, 3, and 5. And for the y's, let's say it's going to be 5, 10, and 25. So basically we have just 3 numbers. If you guys want to add more, we can add more numbers. So let's say 5, we have 10, and here let's say it's going to be 125. All right, so basically we have our numbers right here, but if we click on this little thing, it's not gonna work because we didn't wrote down the function that will allow us to print everything right here. So to be able to see this graph, what we'll need to use is the show function. So it's gonna be plt.show, and we want to see what exactly we have just created. So pretty simple, you just write down plt.show. And you will be able to see the graph that you guys have just created. So basically, we can compare to what we see right here. So we have 1, and here it's going to be 1 for 5. So if 5 is right here, then we'll have 3. So 3 will be somewhere right here for 10. Then we'll have 5 for 25. So basically 5 would be somewhere here. So for 25 makes sense. And finally 10 for 125, which makes sense as well. So as you can see, this is the graph that we have just created. So if we put our cursor right here, you can see down there, everything is fine. So basically this is the first graph that we have created. All right, right now, let's say that you guys want to have more than one line. So if for those who don't understand what I'm saying, so this would be one function. So this is just one function. Let's say you guys want to have more than one function. How exactly you can do all this? So it's pretty simple. There is another way to write it down. Usually we don't write it this way. So basically this is just a presentation way. So just to present one chart or one graph. So the way that we are going to write everything down will be pretty simple. So we need our x's and our y's. So basically x right there and our y's. So let's say we have 2 functions. So it's going to be x and well x1, y1, so we'll have x2 and y2. So let's write it down. So for x1, what we'll do right now, we'll just add something. So let's say, for example, we want to add, well, we want to give them numbers. So it's going to be, let's say 2, 4, and 8. And for y number 1, it's going to be 4, 8, and 24, for example. For the x number 2, it's going to be pretty much the same thing. So let's say it's going to be 3, 6, 9. And for y number 2, it's going to be, in this case, let's say 10, 15, and 30. Let's keep it like this. So as you can see, the first thing that we will do usually will be write down our, well, what we want to write down. So basically all our database will be here. So all the x values and the y values. Then next thing would be writing down the plt.plot function. So it's going to be plt.plot. And then what we want to do is show everything. So plt.plot will have x and y. And the second one will be plt.plot x2, y2. So basically the plot function would simply be the function that will allow us to work with, let's say for example, x's and y. So basically if we want to work with x1 and y1, I will just write down x right here and y right here. Same thing right there. If I want to work with x2 and y2, I'll just write down x2 and y2. And finally, the last thing that we want to do is just show everything. So we'll write down plt.show, and we can run our app. So basically what's going to happen is that we will see our 2 lines right here, so we can compare if it's what we have written. So this is exactly what we have written. So basically we have our first line right here. So for x1 and y1, it's blue. And for x2, y2, it's right there. If I change, for example, my thing right here, instead of x2, y2, I just write down x and y2, you'll see it's going to be a bit different. So as you can see, it became parallel because I'm working with the 2 x's that are the same. So once again, this is more in mathematics, but as you can see, it works pretty well to be able to generate a graph. All right, so right now that we have our function, next thing that we want to do is write down, give a title to our graph. And not only this, we want to give a value to x and a value to y. So basically a title for x and a title to y. So how exactly do we write all this down? It's pretty simple. So we'll just write down plt.title. So this will allow us to generate a title. So let's call it, I don't know, let's call it test. So the title of our graph will be test. And then x values, we'll call it, let's call it test x. So here we'll have plt.x label. So basically we are giving a name to x labels, to the x values. So basically we'll call it, let's call it, as I said, test x values, and plt.y labels, which would be the name of the y labels, would be test y values. So test y values. All right, so what I have just done right here, I just give a name to my axis. So basically this would be the name of my axis, and this would be the title of my chart. So everything, what I did right now is pretty simple. So I still have the same functions right here. So my functions are still the same. I just added a title and I added a axis name. So if I run everything, as you can see here, I have my chart name. So basically test. Then I have test y values, which is my y values, and test x values, which are all my x values. So as you can see, it's all pretty simple to understand. All right, next thing that we want to do is pretty simple. We want to add style to our graph. So basically our graph right now is not that cool. So it's pretty simple, pretty, well, basic. If we want to add a little bit of style to our graph, it's possible. There is a sub package of Matplotlib called style, and we can use it. So pretty simple. We'll just go here, and we are going, so we need to import this sub package. So let's do it. Pretty simple. We'll write down from Matplotlib. So Matplotlib, we want to import style. So the sub package style. So right now we have our sub package. What we can do right now is just add some style to our graph or chart. and we can use the style that we want. So basically I have 4 styles that I can propose you. Basically they're all there are many more than 4 styles, but those are the 4 styles that are pretty simple to understand. So the function that we will use to add style to our graph is just the use function. So basically we are going to make a reference to the style sub package and the use function. So basically it's going to be style.use, and then we'll write down the name of our style. So basically let's start with one of the styles that is called BMH. So basically this is the first style that we are going to use. So right now we have added one style to our graph. So if we run everything, as you can see, the graph has another style. So basically right here you can see there are squares. It's more cool. If we don't use style, so basically if we write down classical, so it's gonna be the basic style, so classic, and we run it, you'll see it's gonna be a little bit different. So basically it's a bit different. Everything here is gray. The style is a bit different. There is another style that exists. It's called dark background. So basically we can try this one. So it's gonna be dark here, background, so background. Here we go, and we can run it. So as you can see, this is another type of style that you guys can have. So basically the style function will just allow you to have to give a certain style to your graph. So right now guys, you should be able to create your own charts with Matplotlib. So as you can see, it's pretty simple. The first thing that you guys do is you import the Matplotlib library. Then if you want to add some style, you just import the style sub package. Then pretty simple, you just add everything that you want right here. So you give to your X values, you give to your Y values, then you create your functions right here. So basically this would be your database. This would be where you create your function. And finally, the last part is where you will give title and the names to your axes as well to your graph, to your graph. So I hope you guys understand everything. So these are all the basics that you need to understand to be able to work with Matplotlib. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are still going to talk about Matplotlib and some other things that we can do with this amazing add-on to Python. So basically, what we are going to learn today is how to create a certain type of graph. So basically, this is something that Matplotlib can help you out with. So basically, it's used for visualization. So we will learn how to visualize our data with a bar graph. So basically, how to create a bar graph. You'll see it's pretty simple and it works pretty much the same way as we saw it a little bit before. All right, so as always, the first thing that we want to do right now is import our Matplotlib. So we'll just write down import Matplotlib dot. So very important, try to not make a mistake. PyPlot as PLT. All right. So when it's all done, the next thing that we want to do is start creating our graph. So basically the first part of the creation of a graph is creating the database. So in our case, what we'll do right now is we'll create a graph with 3 functions inside of it. So basically we'll have 3 X's and 3 Y's. So pretty simple. What we'll do right now, we'll just give a name to each of our variables. So basically we'll have X1, Y1, then X2, Y2, and finally we'll have X3 as well as Y3. All right, so when everything is done, we'll just give certain values to our X's. So in the first case, we'll have X1, which would be, let's say, 2, 4, 6, and Y1 would be, in this case, let's say 3, 6, 9. So you don't have to do the exact same thing as me. The numbers that I'm using are just random numbers to be able to just create a graph. So you can use the numbers that you guys want. It's up to you. So in this case, let's say Y2 would be 5, 10, 15. And for X3, let's say it's going to be 6, 12, 18. And Y3 is going to be 12, 24, 36. All right, so until now we have a database that is pretty simple. So as you can see, we have 3 functions. So we have enough data for 3 functions in our case. The next thing that we will do right now is putting everything together. So basically, we are going to use the bar function in this case because our goal is to create a bar chart or a bar graph. So how exactly we'll do this? It's pretty simple. So we'll write down our plt.bar. So we start with this. Then the next thing that we need to enter is the arguments that will be used inside of our bar graph. So basically, what are the variables that we'll use? So in this case, we'll use the list right here and the list right here. So we'll use x1 as well as y1. So this is for our first bar. We'll do the exact same thing for the other ones. So basically we have x2, y2, x3, y3. So then you can just change the names. And finally x3 as well as y3. All right, so right now we have everything that we need to be able to create our graph. So the last thing that is left to do right now will be to add a title as well as a title for our axis. So we'll write it down. So plt.title. This is the first step. So we'll give a title to our graph. Let's call it test graph 1. So this would be our graph title. And then plt.x label. So in this case, let's call it test x name. And the next thing, and the exact same thing we'll do for our y label, y axis. So we'll write down plt.y label. And for our y axis, we'll write the exact same name. So we'll say test y name. All right, so right now we have our x's and we have our y's. So right now everything is amazing. We can run our graph and see what it looks like. So very important, check up for mistakes. So especially for the little mistakes right here, because if you don't do it, you can have an error message. So finally, to run everything, we'll just write down plt.show. We open and close parentheses, and we can run everything. So as you can see, we have our graph right here, which show us how everything works. And as you can see, it's pretty cool. So basically we have our, right there, we have our x1, x2, as well as x3. So everything is inside of this graph and it's pretty nice. All right, so another thing that we can do right now is change the style of our graph. So basically, if we want to change the style of our graph, it's like always. So we will need to import, in this case, we will import the style sub package. So how exactly we do this? It's pretty simple. So we'll just write down import style. So we need to import style from Matplotlib. So we'll write down from Matplotlib import style. And what we can do right now is we can change the style of our graph. So it's pretty simple. We'll try it out. So we'll just write down style.use. So basically right here, I'm changing the style of my graph. And let's say we want to use the BMH style. So we'll write down BMH. So this is a style type that exists. So we can run everything. And as you can see, the style of our graph just changed. So it's a bit different. So everything works. We have the title of our graph here, the title of each axis, and finally the style of our graph that just changed. So if I'm making a quick interpretation of the code, so basically the first part right here is where we imported all the packages as well as the sub packages that we needed. The first part right here is the style that we want to use for our chart. Here we have our database. So basically all our database is right here. Here we have everything that we put together. So basically we're creating the first function, the second one, as well as a third function right here with the use of our database. And finally, right here, we are giving names to our chart as well as to our axis. So basically the X and the Y axis. So I hope you guys understand how to create a, this type of graph, which is a bar graph. And I hope that you will be able to use it in the future. So that's it for this class, guys, and see you all in our next class. And welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are still talking about Matplotlib, and we are going to learn to make another type of graph, or well, another type of graph, yeah. So basically what we are going to learn today is how we can create a histogram inside of Matplotlib. So you'll see it's not really complicated, and the result could be really interesting. All right, so basically the first thing that we are going to do is we will import Matplotlib as we always do. We are going to create our little database, create our functions, and finally give a title as well as axis name. So for X and Y axis name to our graph. And finally, we'll run everything, and we can even play with the style at the end. So let's start. So basically, as I said, the first thing that we are going to do, we are going to import matplotlib.pyplot. So pretty simple, we'll just write it down. So import matplotlib.pyplot as plt. So this would be the first step. Then, since we want to change the style in the future, we'll not do it right now. So we'll not import the style module right now. We'll do it a bit later when we'll finish everything. All right, so right now, the first thing that we are going to do, we are going to create a database. So basically, inside of a histogram, you need two things. You need a minimum of two things. So basically, you will need your numbers. So basically, how a histogram works, you need a certain amount of numbers. Let's say you have numbers 1 from 1 to, let's say, 100, and you have random numbers between those. This is the first step. So we're having the random amount of numbers that are from 1 to 100. Then the second thing that you need the jumps that you want inside of your histogram. So it could be jumps from 1 to 10, 1 to 20, 1 to 15, or whatever you guys want. And what it's gonna do, it's gonna calculate how much numbers are between 0 and 10, for example, or 0 and 15, or 0 and 20, for example. So we'll try it out, and you guys will understand. So let's write it down. So basically, the first number that we'll have, let's call it just numbers. So basically this would be our first list. We'll call it numbers. And basically here, what I want you guys to do is simply write down random numbers that are between 1 and 1 and 100. So basically you can write down as much numbers as you guys want. It's just for example purposes, and those numbers could be any numbers that you want. So just don't make a mistake and write down 2 or 3 commas, because yeah, it's not gonna be really nice. So here we go. I think I have enough numbers. All right, next thing that we want to do is we need jumps. So basically we want jumps of 5, we want jumps of 10, we want jumps of we decide what type of jumps that we want. And basically this would be how our histogram will be wide or small, basically. So let's write it down. So basically here, let's call it jumps. So let's write it down. So basically our jumps would be somewhere between, let's say it's gonna be from 1 to 15. So we'll write it down. So it's gonna be 0, then we'll have 15, then we'll have 30, then we'll have 45, then we'll have 60, 75, 90, and finally 105. All right, so right now we have our numbers and we have our jumps. The next thing that we need to do is pretty simple. We need to create a title for our histogram or our graph. So as always, we'll create a title. So let's call it, in this case, so plt.title. And here, let's call it, so you can call it whatever you want. I'll call it test 1 hist, since we're making a histogram in this case. All right, then we'll need the labels. So basically for X's, we'll need a label. For Y's, we'll need a label. So plt dot, as always, X label. So how we want to call our X's, let's call it test X label. And for Y's, it's going to be pretty much the same thing. So plt dot Y label. And we'll call it test Y label. Here we go. So we have everything that we need. So basically until now we have everything that we need to be able to create our histogram. Now it's time to run everything and to see what it all looks like. So basically to run everything, simply write down plt.show as we always do. Open and close the parentheses and you can run everything. So here we go. Oh, we forgot a little part of the code. So basically we need to write down the functions that we make everything work. So basically without this function, nothing would work. It's pretty simple. So we need to write down our function for our histogram. So plt, in this case, dot hist. So when we have our function for our histogram, how exactly works? So basically there are 4 arguments inside of it, but we are only going to write down 3 arguments, which would be, so the first argument is pretty simple, is the numbers that we have. So basically all the numbers that we have here. And in this case, we'll just write down numbers. The second argument will be the jumps that our histogram, inside of histogram, will happen. So basically we will have jumps of 15 in this case. So our second argument will be jumps. The third argument will be the histogram type. So basically what is the type of histogram that we have? So basically there are plenty of types of histogram that exist. So we'll use bars or steps. So basically this will be the 2 types of histogram that we are gonna see today. But if you guys want to learn some more types of histogram, you can just Google it. You'll receive all the histogram types that exist. So let's write it down. So it's gonna be hist type. It's the one right here. And from this moment, we'll just write down, for example, bar, since we want to receive bars. And basically, this is the type of histogram that we'll receive by default. So we'll just write down bar. All right, so when we have everything, so right now we have absolutely everything. We have our database right here. We have our title right there. We have our function right here that is ready to be run. And finally, we have our plt.show. So we can run everything and see what it all looks like. So as you can see, this is what our histogram looks like. So basically we have test1 histogram, which is the name of our histogram. We have the Y label right here. We have the X label right here, as we said. So basically the X axis and the Y axis. So our histogram is pretty much ready and works well. If we want to change the jumps, we can change the jumps right here. If we want to change the numbers that we have, we can do it right there. And basically what we can understand from this histogram, for example, if we look from 0 to 15, we know that there is 5 numbers that are between 0 and 15. We know that there is 9 numbers that are from 15 to 30. And we know that there is only 1 number that is between 30 and 45. So basically this is what we understand from this histogram. When I'm talking about histogram types, so as I said, we have bars, but we have plenty of others. So another one that is really interesting would be the step. Works pretty much the same way. So as you can see, those are steps. It's not as well as beautiful in my opinion, but once again, this is another type of histogram that you guys can have. All right, so as always, what we can do with this type of graph, we can change the style, and this is exactly what we'll do right now. So just for you guys to practice a little bit. So what we'll do, we'll just import the sub package style. So from Matplotlib, import style. So basically we want to import the style sub package, and what we want to do right now is just change the style. So basically we will change the style by writing down style.use, and from this moment just write down the type of style that you guys want. So let's try the BMH style and run everything to see what it all looks like. All right, so as you can see, this is what it looks like with the BMH style. The graph becomes a little bit different. So as you can see, this is how you guys can generate a histogram inside of Python with the use of Matplotlib. And once again, this is a powerful tool. Well, the histogram is a powerful tool to be able to help you visualize your data. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with the use of Python. So in this class, we are still talking about Matplotlib, and we are going to learn how to create another type of chart. So basically we are going to create another type of graph or chart. And today one will be the pie graph or the pie chart. So basically we are going to create a pie that will give a piece for each element that we'll have inside of our chart. So you'll see it's pretty simple to make. It's not that hard, but it's a bit different. So the first part of the course, we are going to import Matplotlib as we always do. Then we are going to create arguments that we are going to use. When we will have our arguments, we'll simply create the function. So we'll use the pie function in this case. Finally, we'll give a title to our chart and show everything to visualize the data. And by the end, we'll also play with the style of this graph. So let's start. So as I said, the first thing that we will do is we will import Matplotlib. So Matplotlib.pyplot. So when everything is imported, the second thing that we'll do is we are going to work with the arguments that we will need. So basically, for the purpose of this course, what I prepared is pretty simple. We are going to work with a basic example. So we'll have food that will be sold, and basically we'll calculate the number of sales and the food that has been sold, and we'll give each type of food a certain color. So let's do it. So basically we'll start with writing down the foods that we have. So we have our food right here, and what exactly we have like food. So basically we'll have, let's say, pizza. We will have ice cream. And finally, we will have, let's say, burgers. So as you can see, pretty simple. So we have 3 types of food. The second thing that we'll need is the sales for each one. So basically, let's say we have sold, I don't know, let's say we have sold 20 pizzas. We have sold, what else? We have sold 10 ice creams, and we have sold 30 burgers. All right, and finally, the last thing that we will need is the colors. So basically, what color will be used for each of those things. So in this case, pretty simple. For pizza, let's say it's gonna be red. For ice cream, let's say it's gonna be blue. And finally, for burgers, let's say it's gonna be yellow. All right, so we have everything that we need for our pie chart. So basically we have our types of food that we will use. We have the sales that have been made for each type of food. And finally, the color for each type of food that we have. So let's write down the function. So it's pretty simple. It's gonna be plt.py, since that's a pie chart. So the first part of it will be what are the numbers that we have sold. So basically this is the first part, and the numbers are in the variable sales. So we'll just write down sales right here. Then the second element of the variable will be the colors or the type of food. So basically in this case, we are going to use the type of food. So it's called labels. So what are the labels that what are the labels? It's the one right here, right? So what exactly are the labels that we are going to give to each part of our pie chart? So in this case, the labels will be pizza, ice cream, as well as burgers. And the labels are inside of the variable food. Finally, the last variable that we will need will be the color variable. So in this case, what each label will have like a color. So what color each label will have. So in this case, it's pretty simple. It's called colors. And the colors variable right here will be linked with the variable color. We'll just write down color. All right, so we have everything that we need. Now it's time to run, now it's time to give a title to our chart. So let's just give it a title. So let's name it example. So just example food. All right, so right now we have the title of our chart. Last thing that we have left to do is simply see what it all looks like. So we will run everything. I'm just writing down plt.show. And as you can see, this is our pie chart that we have. So if we compare what we have right here with the answers, so basically we have our title, that is example food. We have pizza, which is the first one and has 20 sales, which is the second biggest one. We have burgers, which is the half of the pie. So in this case, 30 sales. And finally, as ice cream that only has 10 sales is the lowest one right there. So everything makes sense. All right, so right now that everything works, we can play with the style. So once again, this is what we will do. So we'll import the sub package styles. So just write down from Matplotlib import style. And what we'll do right now, we'll just add a style to our chart. So we'll just write down style.use, and we can choose the type of style that we want. So for this class, we can use classic. This is one type of one style that exists. So if we run everything, as you can see, it became a bit different. The background became gray. So basically, this is another style that can be used. So if you guys want to change, for example, the numbers right here, put, let's say, 15 instead of 10, you can do it. If you want to change the color, instead of blue, putting green, for example, you can do it as well. And if you run the app, you'll see it's gonna automatically adapt. So as you can see, it's pretty simple, and this is an amazing visual tool. So basically, it allows you to see visually your data and be able to get the answers that you need pretty easier. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of the complete introduction to data science with the use of Python. So today's class would be our last class about Matplotlib, and basically we are going to learn to create another type of graph or chart inside of this class. So up until now, you guys understood what is Matplotlib and what is a visualization tool. Alright, so in today's class, we are going to create a scatter plot. So basically, this is a plot with dots a bit everywhere. So it's pretty simple to create and pretty simple to understand. So basically, it's gonna make a cloud of dots, which is pretty cool. You'll see what it all looks like. So as always, the first part is to import matplotlib.pyplot. Then we'll create our little database with x's and y's. So for the x and y axis. Then we'll just give a title to our graph as well as a title for the x-axis and the x and y-axis. All right, so let's start. So first thing, as I said, we will import matplotlib.pyplot as plt. So this is what we always do. Then it's pretty simple. We need to write down something for the x's and the y's. So basically we will have our x-axis right here, and let's say we'll have 5 dots in our x-axis, which would be 3, 6, 7, 9, and let's say 10. So here we go, we have our x dots. Then the next thing will be having something for our y-axis. So let's say it's gonna be, in this case, 5, 10, 25, 3, and 1. All right, so right now we have our 5 dots, so 5 x's and 5 y's. Next thing, we'll be giving a title to our database. Well, not in our database, to our graph. So basically, we will write down a title. So same thing, plt.title. And let's call it once again test scatter. Then we need the x-axis and the y-axis. So plt x label. So we'll give a name to x. So test x, and plt y label. So we need a name for y's. Test y. Alright, so right now we have everything that we need. Now it's time to write down the function that will allow us to create the chart. And in this case, it's going to be plt.scatter. So we have our function right here. And what will be the arguments inside of this function? It's pretty simple. It's going to be the x and the y that we have right there. So we'll write it down, x and y. So we have our 2 arguments. So next thing that we need to do is simply run our app. So we'll write down plt.show to be able to run everything that we have. So here we go. And as you can see, we have all our dots right here. So it's pretty simple. We have our first dot, which is 3 and 5, works perfectly. Then 10 and 6. So basically we have the 6 and the 10 right here. Then 7 and 25 works well. 9 as well as 3, so it's right here, and finally 10 and 1 right there. So everything works perfectly, as you guys can see. Another thing that we can do right now is, as always, changing the style. So what we'll do, we'll import the sub package. So from Matplotlib, import style. All right, and we can, okay, so style.use, and here we can choose the type of style that we want. So once again, we'll use the classic style, and we can run everything and see what it all looks like. So as you can see, everything behind is gray. So this is the main, well, the main difference that we can see. So as you can see, guys, this is pretty simple to work with. In my opinion, this graph is pretty simple to create. And well, once again, you can do a lot of really interesting things with this visualization tool in general. So Matplotlib is really an interesting visualization tool. So right now we saw in the past few classes different graphs that you guys can create with Matplotlib. You can do many more things. So you can create two graphs at the same time. You can do pretty much, well, a lot of things to visualize your data. But right now it's really up to you to practice all this. And you can do really amazing things with Matplotlib alone. So this is really an amazing visualization tool, and it could be a really good thing to, instead of having MATLAB, using Matplotlib, since it does pretty much the same thing. So I hope you guys liked this part of the course, because this was the last class of Matplotlib, and see you all in the next part of this course. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So basically in today's class, we are talking about another really interesting Python tool that we are going to work with to be able to understand a little bit more how we work with data science. So this tool is another visualization tool that is built on Matplotlib. So basically when we are going to work with this tool, we'll have to import Matplotlib to be able to work with it perfectly. So basically the name of this tool is Seaborn. So Seaborn is basically a better version of Matplotlib, if we can say it this way, simply because it's built on it. So let's look what it looks like. So basically Seaborn is, as I said, a data visualization tool, and it's based on Matplotlib. So basically what it does, it's pretty much the same thing. It will visualize data, but in a better way. So basically it's used to create more attractive and informative statistical graphs. So your graphs will be a little bit different. So you have more types of graphs with Seaborn than with Matplotlib, and it allows many other great things. So while Seaborn is a different package, it can still be used to develop attractiveness of Matplotlib graphs. So as I said, it will create more attractive graphs. So why Seaborn is used? Basically, it's used to create statistical graphs. So the same thing as Matplotlib. Basically, you will create graphs with databases that you guys will use. It could be small databases, it could be huge databases. And this is exactly what we'll do. We'll import databases, different databases from the internet, and we will work with those databases. Second thing, it's used to create more attractive graphs. So basically, you have plenty of types of graphs that you guys can use. So for example, right here, you have a violin plot, which is one type of graph that you guys can have with the Seaborn, which is pretty cool. And finally, it can be used to make Matplotlib graphs more attractive, which is pretty much the same thing as the best point. Basically, what does this all mean? It means that it takes all the Matplotlib features and it makes them a little bit better. Not better, but more attractive. So basically, you have more options of graphs. You have pretty much a lot of really interesting things. Not only this, but if we talk about some of the functionalities of Seaborn, it will allow comparison between multiple variables. It can support multi-plot grids. It's available. Well, it has plenty of colors that are available. So basically, you can use it as you want. You can add colors. You can add pretty much a lot of things, and can estimate and create graphs of linear regression automatically. So basically, it's pretty cool. Some other things that Seaborn can offer, or basically the Seaborn functions can offer, is visually understanding different distributions of data set. This is what you can do with this tool. You can visually understand mathematical and statistical relationships. So basically, if you have relationships inside of your database between a certain variable, so between variable x, y, and z, for example, with Seaborn, you can visually represent it with a graph. So basically, it could be represented inside of a graph so you guys understand it better. And it can generate graphs and plot, well, it can do graphs generation and plotting with categorical data, which is pretty cool as well. All right, so Seaborn versus Matplotlib. So what is the difference between Seaborn and Matplotlib? So basically, as I said, Matplotlib is used for basic plotting. Usually the visualization that uses Matplotlib are generally consisted of bars, scatter plots, histograms, and some others. So basically there are plenty of really basic plots that are used inside of Matplotlib. But inside of Seaborn, it's more advanced plots. So basically, as you can see here, those are some plots of Seaborn. So for example, you have the violin plot, you have the elam plots. Basically, you have plenty of plots inside of Seaborn, as well as all the Matplotlib plots. Basically, you will work with Matplotlib, and Seaborn is like a better version of Matplotlib, if we can say it this way. So basically, Seaborn is just a higher level API version of Matplotlib, with some different parameters. Also, Seaborn comes with numerous customized themes and high-level interface. Also, Seaborn functions work well for data frames, so which Matplotlib is not the best at it. So is Seaborn better than Matplotlib? Not really. Well, Seaborn is built on Matplotlib, and Seaborn is, we can say, if we can say it, a part of Matplotlib. So is it better? Not really. It's just part of it. So basically, it's like a higher version of Matplotlib. So you can work with both of them. So both tools are really awesome, but Seaborn is like a higher version, if we can see it this way, but it has all the Matplotlib tools inside of it. So basically you will import Matplotlib as well as Seaborn. So you'll see when we are going to work with Seaborn in the next few classes, we're going to import Matplotlib, we're going to import NumPy, SciPy, and Pandas, basically, to be able to work with everything together. So like always, we are going to work with PyCharm in the next few classes, and we are going to learn how to create plenty of plots by importing data directly from the web. So I hope you guys are ready. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in this class, we are going to learn how to set up Seaborn on our PyCharm text editor. So you'll see it's pretty simple to do, and this is exactly what we will do inside of this class. So pretty simple, it works pretty much the same way as with other tools that we talked about. So simply go on your file, on your settings, and then pretty simple, you go inside of your project. In my case, it's project 1. Then you simply click on the little plus button. Then here, you simply look for Seaborn. It should be this one right here, and then you simply install the package. So when it's all done, it should appear somewhere right here. So as you can see, I have my Seaborn here, my Pandas here, NumPy, Matplotlib. So those are some of the packages that we worked with. So when everything is ready, now it's time to import all our other tools to be able to work with them in the next few classes. So let's start. Basically, we'll start by importing NumPy as NP. Then we'll import SciPy as SP. Then we'll import Pandas as PD. We'll import Matplotlib .pyplot. So really important to import, to write down the pyplot as MP. And finally, the last one will be Seaborn. So basically, we'll import Seaborn as SB. So basically those are all the things that we need to import to be able to write down plots in Seaborn. So basically to create plots in Seaborn, sorry. So with all those things, you guys are ready to be ready for the next few classes where we'll create plots and different graphs with Seaborn. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in this class, we are going to start working with Seaborn, and we are going to create our first graph with this amazing tool. So basically the first graph that we are going to create will be the dist plot, which consists of a histogram that is directly inside which consists of a line that is directly inside of a histogram. So basically you'll see it's pretty cool. So what exactly we'll do, it's pretty simple. We will first of all import a database or a data set directly from the internet, more precisely from GitHub, and we are going to work with those databases. So for those of you who don't know from where exactly we'll import our data, we'll import it from here. So basically, as you can see, this is GitHub, and this is all the databases that you guys have. So basically there are plenty of those databases. So I'm gonna show you how to import any of those databases, and we are going to work with the most simple ones. So in this case, the most simple ones would be Flight and, in my opinion, Tips. So basically those are the two databases that are not really complicated and really interesting to work with. All right, so let's come back to our PyCharm. So basically the first thing to do would be to import everything right here. So everything has been imported. One last thing, so importing all the things that we need. So we have NumPy, SciPy, Pandas, Matplotlib, and finally Seaborn. Very important, Matplotlib, don't forget to write down .pyplot, because if you don't write it down, you will not be able to work with all the plots. All right, so the first thing that we will do is pretty simple, is importing our databases. So we need to create a variable that we will call, in our case, database. So basically I'm calling it database. You can call it whatever you want. So we'll create a variable that will be called database. All right, so when it's all done, the next thing that we'll do, we will use a function that will be referred to Seaborn. So we'll start what we will write with SB. So we are making a reference to Seaborn in this case, and we are going to ask Seaborn to load a data set. So basically data set. In this case, we decide what data set that we want. So let's say we want to import diamonds. So this is one of the data sets that we have. So just to be sure, we can come back here. So we have a data set that is called diamonds. So diamonds. So this is exactly what we'll do right now. We'll import this data set. And just to be sure that everything works fine, what we'll do, we'll print it, so to be able to see what it looks like. So we will print database, which is our, in this case, our variable right here. So let's print it and see what it looks like. All right, so as you can see, everything works fine. So we have printed our database. Our database works. So here we go. We have our diamonds database. So basically this database is pretty huge. It's consisted of 53,940 rows and 10 columns. So this is a pretty big database. The next thing that we want to do right now is pretty simple. We want to create our plot or our graph. So for those of you who didn't understand what I just did, I imported the database. So here you have diamonds, but you can change it by any other database that you want from this website right there. So pretty simple. If you want to change it for dots, you can change it for dots. If you want to change it for MPG, you can change it for MPG. And what it will do, it will simply import other databases. So you can create your plots with any database that you guys want. All right, so for the next step, what we'll do, we will work with one of those variables right here. So I'm proposing you to work with the carrots or price. So let's work with carrots. So what we'll do right now, we are going to create our plot. So once again, we are going to make a reference to Seaborn. So it's going to be SB. And the type of plot that we are going to create will be the dist plot. So basically we have our dist plot. So the dist plot will be referred to database. So basically we are going to take all our, so we are going to take our information from database, and then from what variable? From the variable, in this case, caret. So we are referring everything to database, so to the variable database. And from database, we want Python to look for caret inside of this database right here. All right, so we will write down caret. So basically it will use those numbers that are right here to create the plot or the graph. All right, next thing that we want to do is simply show everything to see what it looks like. So it's going to be plt.show. We can open up and close the parentheses that we have. So this formula, this function right here is just to show everything. This function right here, what it means, it's pretty simple. We are using the reference SB to be able to work with this plot function that is referred to Seaborn. And basically what this function does, it will ask database. So it will have a reference to database. So we are going to go to database, and from database, we want to extract the element caret. So basically in the database, we have diamonds, and from diamonds, we want to extract caret. Basically, when it's all done, you guys can run everything. So you'll have your database, and finally you'll have your plot right here. So as you can see, something that is pretty simple. You have your histogram, and basically you have the line inside of the histogram. Once again, this is a bit complicated to understand since we are working with carets, but this is exactly what it will be generate. So this is what we will generate with our, with this type of graph. So yes, of course, sometimes we can have graphs that are specialized in some things. Maybe this graph is not the best graph to know carets, for example. Once again, this is a good way to show you guys what type of graph that you can generate. Next thing that you can do, you can add bins. Bins will simply add, will simply tell you what is, how big you want your histogram to be. So basically, it could be 1, it could be 2, it could be 3, it could be 4. So you decide, you will simply add it here. So basically inside of caret, you can add your bins. So basically you simply write down bins, and you write down the, how big you want your bins to be. So it's gonna be just here. So we wanna load this database, and here we go. We want to have our bins, and we decide how big we want them. So basically in this case, let's say we wanna have bins of 1. So this is how big we want our histogram to be, and we can run everything. So here we go. As you can see, the bin size have changed and the histogram has changed. Once again, this is not a perfect example to do it with the carets, for example, because once again, it doesn't give a graph that makes a lot of sense. But once again, as you can see, this is how it works. So basically the bins is simply how big you want your histogram to be. So this is what you guys need to understand. So really important, you need to write it down right here. I was a little bit lost earlier. So you write it down right there. So database, and after the element that you guys want to extract from your database, so you write down your bins. All right, so I hope you guys right now understand what exactly you need to do to be able to create this plot. So basically your histogram with a line inside of it. And I hope you guys understand, you can use it in any other way that you want. So if we want to simply do a little bit another thing that is pretty cool, so basically simply change the databases. So we can, for example, work with dots in this case. So let's choose dots, and we run everything. So we'll simply take this away. So here we go, it's gonna generate dots right here. So those are the dots, and what we can do right now, we can, for example, extract something else. So for example, we want to extract the coherence from our dots. We can do it. So we can simply copy everything and paste it right here. So we want to extract coherence from the database dots. And if we run everything, as you can see, we'll receive our chart right here. So basically this would be our histogram inside. This would be our histogram that will be generated. So as you can see, you can work with any database that you guys want from this website. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in today's class, we are still going to talk about Seaborn, and we are going to talk about another type of plot that you guys can create inside of this amazing tool. And basically this plot is called the join plot. And what I will do, it will put dots inside of the graph. So basically those little dots you'll see, they will allow us to understand what is the relation between two variables. So for the purpose of this example, I'm planning to use the tips database. So basically if we go in on GitHub on our databases that we will use, it's gonna be the databases right here. So basically it's gonna be tips. You'll see it's pretty simple to understand. So the first thing that we'll do is we will import our database. So how exactly do we import it? So it's pretty simple. We want to create a variable. So in this case, we'll create our variable that will be called database as always. And we are going to make a reference to Seaborn. So basically we start our sentence with SB, and we want to load data set. So what data set we want to load? So in this case, we want to load tips, which is one of the data sets. So if you guys want to work with something else, you can, but for the purpose of this example, we are going to work with tips. So if we print everything, so if we print our data set, so in this case, if we print the data base, here we go, we'll see what this database will look like. So as you can see, here is our data set. So pretty simple. As you can see, we have our total bill, we have our tip, we have if it's a male or a female, we have if the person smokes or no, the weekday, if it's dinner time, and the size of the table. All right, so what we'll do right now, we'll simply calculate what is the tip based on the total bill. So if the tip is higher for a higher total bill, or if there is a relationship between the tip and the total bill, or if there is no relationship between those two. So how exactly we'll do this? It's pretty simple. So we will create a join plot. So basically you'll see this type of graph is pretty interesting. So how exactly we create it? It's pretty simple. Once again, we need to make a reference to our Seaborn tool. So we'll start our sentence with sb.join. So basically join plot, which is the type of plot that we will use. Then right here, we have three arguments that we need to write down. So we have our x, which would be our first argument. And in this case, what we want to have as an x, we want to have tips as an x. So here we'll have tips as x. Then the second argument will be our y. So inside of a graph, we have our x and we have our y. So in this case, what we want to have as y? We want to have the total bill. So we'll write it down, total bill. Then the last thing, we want to know from where exactly the data is going to come from. So in our case, the data will come from database. So from here, we will have our database. So basically, if you guys have more than one database, you can choose from where you want to have your data coming from. So in our case, we want our data to come from the variable database. All right, so we have everything that we need. Next thing that we want to do is simply run our graph. So basically, simply write down plt.show to be able to see your graph. So we can run everything. And as you can see, we have our graph right here. So right now it's time to understand what we have just generated. So right here, we have our total bill, and right here we have our tip. So basically, the majority of the tips are somewhere around here. So we have a tip of $3. Basically, that's the average if we want to see. So the majority is somewhere right here. And as you can see, the more the price of the table is, the more the tip will be high. And the less the price of the table will be, the less the tip will be. So basically, we have our extremes here. So we have our lowest extreme right here and our highest extreme right here. And on the other hand, for example, we have some other extremes. For example, right here, we have a tip of $5 for a meal that doesn't even costed $10. And we have another extreme right here of a tip of less than $1 for a meal that costed more than $30. So basically, as you can see, yes, there is a relationship between the tip and the total bill, and we can see it directly inside of this graph. So basically, we can automatically see that the more the tip costs, the more the total bill will be high. So basically, well, the more the total bill is high, the more the tip will be high in this case. So yes, we have extremes, but once again, it's important to understand that in the majority of cases, so in this case, somewhere around 80% of cases, this is respected. So basically, the more the total bill is high, the more the tip will be high. So this is basically how we can analyze data in a basic way. So I hope you guys understand right now how to make a joint plot, or this type of graph in other words, and how you can understand it and be able to work with this type of graph. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are going to talk about Seaborn like in the past class. And we are still going to learn how to use this amazing visualization tool. So basically in today's class, we are going to create another type of graph, which is called the cat plot. And basically inside of this plot, what we are going to find, once again, dots or lines, or basically what's cool about it is that it will give us the higher limit and the lower limit. So basically we will be able to see, for example, what is the most popular element of the graph, for example. So to help you better understand this graph, what I propose you is a basic example. So we are still going to work with databases from GitHub in this case. And the database that we are going to use today will be the flights database. So basically, for those of you who don't know from which database we're going to take everything, so as you can see, it's from here, it's from GitHub. And basically we are going to work with the database that is right here. All right. So our goal today will simply be to understand what is the most popular month of the year to flying. So once again, this is something that is pretty simple to do, and we'll analyze the data that we have to be able to understand what is the most popular month of the year. All right, so like always, the first thing that we need to do is importing our database, and this is exactly what we'll do. So we need to create a variable to store everything. So let's create a variable and call it database. So this is our variable. And inside of this variable, we want to import our data set. So like always, what we'll do, we'll write down SB because we are making reference to Seaborn. And we will write down load data set. So we want to load the data set. So what data set we want to have? We want to have the flight data set. So in this case, we will simply write down flights. So here we go, we have our data set ready. Next thing, we want to print everything to be sure that everything works fine. So we want to print database, which is in this case the variable that we have just created. And we want to run everything. So if we have something generated right here, it means it works. If not, well, it doesn't work. So as you can see right here, we have generated absolutely everything we need. So as you can see, we have the years, the months, and the number of passengers, which is quite amazing. So we have everything that we need. All right, from now, as I said, what we want to do is we want to know in what month we have a lot of passengers inside of our flights. So this is exactly what we'll do. All right, so next thing that we want to do, since we have printed everything, we want to create our, generate our plot. So how exactly do we generate the plot? It's pretty simple. So we'll just write down sb.cat plot. So this is the plot that we are going to work with. This is the type of graph. So you'll see it's pretty simple. So inside of the cat plot, what exactly we need to write down? We have 4 arguments. So 3 of those 4 arguments are mandatory. So we need them to be able to make the graph work. And we have 1 argument that is optional, but we are going to talk about it a bit later. So the first argument that we need is the x. So in our case, the x value will be the months. So basically the month will be our x value. Then we need a y value for our graph. And in our case, the y value of the graph will be the passengers. So here we go. We have the passengers. So very important, don't make any mistake when you write down those arguments, because if you make a mistake, it's just not going to work. All right, next argument is from where exactly we will take the data. So in our case, we are going to take the data from the variable database. So the data is stored inside the database, and this is where we are going to take it. So simply write down data, and the data that we are going to take will be taken from database. All right, so those are the 3 arguments that are mandatory for our graph or for our plot to be generated. So let's run everything and see what it all looks like. Oh, we forgot one argument down there. So we need to show everything. So it's gonna be plt.show. Here we go. There. So don't forget this little line of code as I did. All right, so simply run everything. So here we go. We have our graph right here. So this is the basic. So once again, here we have our graph. It looks pretty complicated to understand at first, but this is the one of the types of graph that we can generate with the cat plot. So basically there are plenty of other types of graph that we can generate. So as you can see, we automatically can see that July is the most important month of the year in terms of how many flights there is, or how many passengers there is. Well, how many passengers there is, and in the years that have been generated right here. So if we want to have something that is a bit more presentable, we can use a different type of graph for the cat plot. So basically, how do we do this? It's pretty simple. We are going to use the optional argument that is called kind. So we can choose the kind of graph that we want. So basically, we can have the strip, which is one of the arguments. So in this case, we can use strip. And we can run and see what it looks like. So here we go. We have the strip right here. The strip is basically the thing by default. Then we can use another one, which would be, for example, the violin. Here you go. So this is another type of graph, which is the violin. So you'll see it's a bit, this one is a bit, well, it takes more space. So it's going to be more complicated if you guys want to generate it and make it bigger. And there are some other types. Well, there are plenty of types. The one that I personally prefer is box. So the kind box. So as you can see, it looks something like this. So automatically with this type of graph, we can automatically see that the month that we have the most people is the month of July. So let's just make it full screen. So as you can see, the month of July is the month where there is the most people. So even the mean of July is the highest. Then we can automatically see that the mean of, well, the month where there is the less people that are flying is the month of February. Because as you can see here, we have the lowest mean. But the lowest minimum will be in November. So in November, we have an extreme, which is the lowest extreme. But the month which is on average, where there is the less people flying, will be February, or the month right here. So as you can see, it's pretty cool what you guys can do with this type of graph, which is called the cat plot. Once again, let me just summarize everything that we have learned. So basically, as always, the lines of code right here are made to generate our database. Then after that, the cat plot right here. Pretty simple. We simply write down SB because we're making a reference to Seaborn. We write down cat plot because this is the type of plot that we need. We have 4 arguments, so basically the X, which is right here, the months. Then the number of passengers right here, which is the Y. Then we have our data, which is taken from database right here. And finally, the type of graph that we want. In this case, we want the box type, which is one type of graph. And to understand the graph, so basically what we can understand right here is that we can understand how many passengers have been flying in this plane, depending on the number of months. So I hope you guys understand everything until now. As you can see, it's not really complicated to understand this type of graph, and it's pretty straight to the point, so you guys can understand it pretty simply. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in today's class, we are still going to talk about Seaborn, and this will be our last class about this amazing tool. So up until now, you understood that this is a really great visualization tool. All right, so what we are going to learn today is pretty simple. We are going to learn to work with multiple plots or multiple graphs. So basically, we are going to work with more than one graph. This is what it means. So to be able to understand better what type of analysis you guys can do, I decided to use another data set of from our databases. So we'll use the tips database. So first thing that we are going to do, we are going to import everything. So pretty simple. We are going to create a variable that will be called database, And as always, we are going to import our dataset. So load dataset. And what database want to import is the tips database. So here we go. We have everything right here. So we can run we need to print everything first. All right, here we go. All right, so we can run everything right now to see if everything works. So as you can see, the database is generated. So we have everything right here. This means that everything works just fine. All right, next thing that we want to do right now is creating our databases, our two graphs, sorry. So the first thing that we'll do is we are going to create another variable. This one, let's call it graph because we are creating a graph. And here, what we want to do right now, we want to use another function that is called facedGrid. So once again, this is a Seaborn function. So we are going to start with sb.facedGrid. So pretty important, the F has to be in capital letters because if it's not gonna work. All right, next thing that we need to write down, the first argument actually will be from where we are going to take our data. So we are going to take our data from the variable database. So this is what we'll write down. So database right here. Then what will be our columns? So our col. In this case, we want to know if the person is a male or a female. So inside of our columns, we will have the sex of the person. And finally, the hue, which in our case will be if the person is a smoker or no. So this is what we are looking for. All right, next thing that we are going to use is another function, which is map. So basically, we want to create two graphs. So basically, we are going to use the map function. So once again, graph.map, so basically the graph variable. And right now, what type of graphs that we want, or what type of plots that we want. Pretty simple, we want scatter plots because in my opinion, this is the most representative of the situation that we are trying to study. All right, so right now, next thing that we want is what we want inside of our scatter plot. So we want the total bill and the tip. So right now we have everything that we need. So last thing that we'll do, simply show. So we need to show everything. So to see the graph, so plt.show. And then pretty simple, we just run everything. All right, so right now we receive this type of graph. So basically what can we understand if we wanna make a quick analysis of this graph is pretty simple. So this graph is for male. So basically all those right here are guys and all the persons right here are girls. So basically we can see how many smokers. So we have smokers and no smokers. So basically the yellow ones are smokers and the blue ones are no smokers, have left a tip based on the total bill. So basically we are studying right now 4 variables. So we are able to study basically 4 variables just with one graph. So basically depending on the color, we are able to know how much the person have left tip. And we can also know, for example, if a smoker left more tip than a no smoker. And in this case, we can see that there is no correlation between smokers and no smokers. So basically, if a smoker left more tip than a no smoker, so we can see it left pretty much the same thing. But what we can see in this graph, we can easily see that men's leave more tips, like for example, in their extremes, leave more tips than women. So for example, once again, based on the graph right here. And if we look at the average, it's pretty much the same thing. So men leave more tip than women based on the data right here. Once again, so the extremes are more higher for men. This is what we see. So once again, this is what we can conclude with the analysis right here. So basically, as you can see, we are able to make an analysis with 4 variables. So we have the total bill, we have the tip, we have the sex of the person. So if the person is a male or a female, and finally, if the person is a smoker or a no smoker. So as you can see, we can make a complete analysis with the database that we have right here. So we can take a simple database that is right here and create something really advanced and really have really interesting data about well, actually all the population that have ate at that restaurant. So as you can see, there is plenty of really interesting things that you guys can do with Seaborn. So what I showed you right now are just the basics. So basically we have learned how to create some plots or some graphs and the basics of analyzing those graphs. So right now, if you guys want to learn a little bit more, you can import your own databases. So basically from simply write down sb.load datasets, and you can import your own datasets and try to study them to understand a little bit more all the concept about, well, all the data science that is around those databases. There is a lot of really interesting things to learn. Besides of that, I hope you guys understood the power of Seaborn and how it could be really powerful in analyzing data. So this is really an amazing way to analyze data. And since it works with Matplotlib, you know that it's really high quality data visualization that you guys will have. So that's it for the Seaborn part of this class, and see you all on my all other class where, well, on the other class where we are gonna talk about some other topics about data science. And welcome back to another class of our course about the complete introduction to data science with Python. So in the past few classes we talked about the many tools that you guys can use to be able to perform data science with Python programming. So we talked about Pandas, we talked about Seaborn, NumPy, SciPy, and other things. And right now we are going to talk about another topic that is really related to data science and that requires a lot of data science to be able to be performed, and this is machine learning. So basically in the next few classes we are going to talk about machine learning in general. What is it, how it works, the different types of machine learning. We're gonna have, well, I'll try to go as in depth as possible and keep it as simple as possible as well, so not making nothing that is too complicated, so to help you understand. And also we're gonna talk about some of the algorithms, that can be used with machine learning. So this way you guys will understand some of those algorithms and how they work, and basically how you can program them with the use of Python. So let's start. All right, so basically what is machine learning? So the first thing that we need to do is really understanding what exactly is machine learning, and before even going further in the topic. So basically there are plenty of definitions for machine learning, so a lot of them exist. For me personally, machine learning would be the use of AI to provide systems the ability to automatically learn. So basically you will use artificial intelligence that is based on data science to help machines, to help your system, basically not a machine, it's a system, to help your system learn and perform tasks based on past experience. So basically, let's say you create a system that will automatically drive. So basically to teach your system how to drive automatically, you will give him a lot of videos, for example, or you will put him in a lot of experiences. So basically you will make him experience the road and many other things, and the system will simply adapt to your learning and adapt to the situation, and bring the outcome that you wanna have at the end. So basically you will tell your machine, I want this outcome, and this is the income, and I want this outcome from it. And basically the goal of the machine is finding the best map possible, and this would be a supervised learning. We'll talk about it a little bit later, but this is one type of supervised learning that exists. So basically this can be machine learning. Next thing is machine learning can be the science of making computers learn and act like humans. So basically what we're trying to say now is really, well, this is really more advanced. So we're talking here about giving not a conscience to computers, but simply make computers understand their environment like human beings. So basically understand the faces, and this is really in more advanced machine learning. At basic points, it's really helping computers perform certain tasks. So basically, let's say you want a machine that is able to recognize faces, like for example on your phone. So on your phone you have a machine learning applications or a AI that will be able to recognize faces. If if we say that this is a machine, if we implement in it a machine learning system, what it's gonna do, it's gonna start learning from from its experiences. So basically it will learn each time that it will see a face, it will add it to its database, and it will learn more and more and more and more. And basically to make work those types of systems, how it works, as I said, you have an income. So basically you have your income, where your starting point, and your outcome. Let's say you want to recognize a face. So basically you will create a system and give the system a lot of faces. And this system will get used to recognize faces. And it will create a map to recognize faces the best way possible. So basically this would be your machine learning. This will be your machine learning system. And you have plenty of algorithms that will help you achieve this goal. Last thing is the use of algorithms to allow the analysis of data to make a prediction about something in the world. So basically it could be used for this as well. So let's say, for example, on the stock market, you want to predict the movement of a certain stock in a certain direction. So basically you can use machine learning for that. So what it will do, it will simply analyze the chart. And when I'm saying analyzing, it's going to be a pure technical analysis. So basically it will analyze all the aspects of the chart. It will analyze absolutely everything, all the movements on each second. Well, it depends how you program your system, but it can be really, really, really advanced. And basically with all this information, it will be able to make the best purchases possible because it will optimize to the max. And those are things that a machine can do that a human being will not necessarily be able to do, because the calculations that are behind the scene of all this are really, really advanced. All right, so some examples of machine learning. So as I said, there are plenty of examples of machine learning. You can see them all right here. So we can have image recognition. So basically, there are plenty of systems that exist in the world used for security purposes or any other purpose to be able to recognize, well, for facial recognition, for example, or simply image recognition, just to recognize an image. Those are AIs, but to be able to be created, we have used machine learning systems to be able to make the creation of those systems. Speech recognition, so one of the most popular speech recognitions that exists will be, for example, on Google. So when you go on Google and you go on Google Docs and you want to write down a text, they have a speech recognition system that you can talk and it will automatically generate a text. Traffic prediction, this can be, for example, well, for engineering purposes. So for example, you wanna estimate the traffic or any other thing. It could work as well. Fraud detection, so basically it can detect frauds on millions of transactions. So those are really advanced systems as well that can detect frauds on millions of transactions. Financial field, so as I said a bit earlier, in the stock market, so to be able to predict the movement of a stock or a ETF or whatever, it's possible with machine learning as well. So here you can find plenty of other examples. So for example, self-driving cars, simply the email spams and malware filtering. So basically on your email to choose an email to go to spam or to go directly to your email base, basically it's machine learning. So there are plenty of things that use machine learning. It's all around us, we just are not used to it, or we simply don't know what is it, and this is why we are maybe not, well, we maybe just don't understand what is it to be able to see it. All right, so last thing will be, what are the different types of machine learning that exist? So there are 3 types of machine learning that exist. We have supervised learning, and basically when we talk about supervised learning, it could be training or, well, if we want to understand and have the definition of supervised learning, it will be training an algorithm and pick the model that will be the best to predict some outputs based on inputs of data. So as I said, basically you have an input and you want to have a certain output, so you will train your system to be able to predict this output. So as an example, we can think of simply facial recognition on pictures. This could be a good way. So basically how all this would work behind the scene. So the system will receive multiple inputs and outputs, and basically the job of the system is pretty simple. It will be to map all, well, to be able to create a map or basically a road from the inputs to the output, and it has to be the most optimized possible. And the more the system will be trained, in our case, well, the more it will be effective. So basically the more you train your system, the more you give him information to be able to understand this information and to transform it, the more the system will be good and will find the right answers and bring you to the right output. All right, second thing will be unsupervised learning. So basically the difference between supervised and unsupervised is that there is no outcome to predict in the unsupervised learning. So basically this type of learning is done with unlabeled data, if we can say it this way, and to find uncovered hidden structures. So basically it's harder to use and is well less used. So basically it's not as used as supervised learning. And usually it can be used before the supervised learning, so simply to, well, to provide information about the potential outcome and how to reproduce it. So basically, if you don't know the outcome, you will use unsupervised learning simply to maybe have an idea of how you want the outcome to be, or how you want to get the outcome. And after that, with supervised learning, you have a certain idea of the outcome. You can try to train your machine to be able to reach that outcome. Then the last thing will be reinforcement learning. And basically reinforcement learning is all about taking suitable actions to maximize results in a particular situation. So in other words, basically what you want to do is really train your machine to be as optimized as possible. So it will learn from errors, as it says right here. So basically you want to have something that is, well, optimized to the max and will simply be able to adapt in any type of situation. So basically in reinforcement learning, there is no answers, but the reinforcement agent decides what to do to have, well, to optimize the realization of the task. So basically we can see some examples right here. So we can talk about real-time decisions. We can talk about skill acquisition. We can talk about robot navigation. So those are really more advanced things, and basically you have a system that is already in place, and what you want to do with this system, you want to optimize it. So basically when you want to optimize your system, you will not use supervised or unsupervised learning. You will really use reinforcement learning, which is the thing that is used to be able to optimize to the max your system. So right now, I hope you guys have a basic introduction to what is exactly machine learning and how it works. And in the next classes, we are going to start talking about some of the machine learning algorithms that exist. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science. So in today's class, we are going to talk about machine learning. So in the past class, we talked about what is it in general, how it works, and basically all the basics of this. And in this class, we are going to talk about the different machine learning algorithms. So we're not going to go into practice of those algorithms. We are going to cover all the theoretical part. So basically, I'm going to talk about each of those, each of the most important machine learning algorithms, how they work, and simply give you a brief little introduction to each of those algorithms. Once again, my goal is not that you guys become professional in all this, but simply that you guys understand what is it, how each of those algorithms works, and basically all that you can do with machine learning and Python as well. So let's not wait anymore and let's jump right into it. All right. So basically the first machine learning algorithm that we are going to talk about will be linear regression. And this one is pretty simple to understand. So basically the formula is y equal to ax plus b. So basically, as you can see on the graph right here. So what exactly is linear regression in machine learning? It's simply a supervised machine learning algorithm where the prediction output is continuous and has a, we can say a concrete slope. Basically, the slope is pretty much the same since it's y equals ax plus b. So basically, an example of machine learning regression could be the graph right here. So we can say, for example, that right here we have the price paid for example, let's say a plate. So let's say in a restaurant, you guys are buying something, and this would be the price paid for your dish, so for what you have ate. and this would be the amount of tip that you guys have left. So basically, as you can see, this would be our test. So the system will be able to tell us that the more someone buys, the more the plate is expensive, the more the person will leave a tip. So the more the tip will be high. So basically, as you can see, and there would be right here, we will have a in the middle, we'll have our slope that will be right there. So as you can see, it's drawing right here. So basically, this would be like the average or the mean. Basically, it's in the middle of all the points. Some linear regressions are better than others. So in some of them, you will have points everywhere. In some of them, the points are very well condensed in one place. Those are more representative. So basically, a slope like this would be more representative than if we have points everywhere and there is one slope in the average. It's not really representative. So this is for linear regression. All right, the second type of algorithms that we are going to talk about will be the logistical regression. And it's not like linear regression. Basically, this is logistic regression. It comes from statistics like the linear regression, but it's not an algorithm for regression problems. In other words, problems that require the prediction of a continuous outcome. So basically, it's not for this. So logistical regression is really a method that is used for binary classifications. In other words, 1 or 0. So it will give you a discrete binary outcome between 0 and 1. So as I said. So if we want to think about something, so basically we can have, as an example, we can, for example, say, do you like to eat outside? So basically asking someone if he likes to eat outside, yes or no, could be a logistical regression, and 0 in this case, yes, let's say yes in this case will be 0, and no in this case would be 1. So basically it will look something like this. So as you can see, all will have 0 right here, and we'll have 1s right here. And after that, we'll have an average, and this would be our outcome. So basically, the majority of people like to eat outside if it's closer to 1, because the 1 is yes and 0 is no. So basically, this is another type of regression that we can use in machine learning. But once again, this one is really important, like the first one. And the difference between linear and logistic is that logistic is really between 0 and 1. So this is more of a binary, the outcome that you will have will be a discrete binary outcome, not like the linear regression. All right, so the third algorithm that we are going to talk about in this class is pretty simple. It's called the decision tree. So I think we already talked about this type of algorithm at the beginning of the course. So basically about decision trees and other stuff related to this. So basically, what exactly is a decision tree? So basically, decision trees, in general, are constructed via an algorithm approach that identifies ways to split a data set based on different conditions. So basically, we will have different conditions or different variables that we will need to take and put into consideration to be able to create our decision tree. So it's once again one of the most used and practical methods because it's really based on how we as human beings solve our problems. So basically, let's take an example. So the example right here that we have. So once again, this is a decision tree that will help us know what animal we are talking about. So basically, the first question that we are going to ask is, does he have feathers? If yes, can he fly? If no, has he fins? If he can fly, that's an hawk. If he can fly, that's a penguin. If he has fins, that's a dolphin. If not, that's a bear. Once again, this is really basic. Decision trees are almost everywhere. So basically, when you guys go, for example, to buy food, let's say you guys are going to buy a pizza. So basically, you will find decision trees when you will buy your pizza. So the process of buying a pizza could be a decision tree. So as you can see, this is really used everywhere. So not only buying a pizza, so we do it without even thinking about it. And implementing this inside of a machine or inside of a system can be something that could be really useful in all aspects of our life, and in general, simply having this inside of a system can be really useful and make the system way more optimized and performant. All right, another type of algorithm that we are going to talk about today will be the support vector machine, which is one really interesting algorithm. So basically, this is a supervised machine learning algo that can be used for classification or regression. But this algorithm is mostly used for classification purposes. So what does this mean? It's pretty simple. So support vector machine algorithm is able to generalize between two classes that are different if the set of labeled data is provided in the training set of the algo. So basically, if we provide enough data in the training set of the algo. So basically, the goal of this algorithm, or the support vector machine algorithm, will be to find a hyperplane in an n-dimensional space where n is the number of features. So basically, we have features right here. And in the end, to be able to separate the two classes of data points. So basically, we have the two classes right here. And there is a multitude of possibilities of hyperplane that can be chosen. Basically, it sounds a little bit complicated, and you guys maybe don't see where exactly can be applied in real life. So let me just give you two examples. So let's say, for example, you want to create a facial expression classification model. So let's say this model will say the person is sad, happy, I don't know, the person is surprised, the person is shocked, or whatever. Well, basically, you will use a support vector machine algorithm to be able to build this. You can build this with this type of algorithm. Or another thing that will be, for example, text classification. So basically, you will compare a text written by a human being and a text written by a machine, or simply being able to translate a text written by someone to a computer. So basically, to Word, for example. A good way to do that will be by using the support vector machine that will be able, with training of course, will be able to spot this type of text and simply transform it. So basically, there are plenty of tasks that the SVM algorithm model, the SVM model or the SVM algorithm can realize, and it can be really useful for machine learning purposes. All right, another algorithm that we are going to talk about today will be the naive Bayes. So basically, this is another algorithm that is really used in machine learning. So what exactly is naive Bayes? So this is a classification technique that is based on Bayes theorem. So basically, to be able to work with it, you need to understand the Bayes theorem. So it will assume that there is an independence among predictors. So naive Bayes assume that the presence of a particular feature in a class is not related to the presence of any other feature. So this is basically the main reason why it's called naive. It will take some features and basically it will use those features to be able to say, for example, okay, this is, I don't know, a pizza, for example. So let me just give you a quick example. So let's say something is round, weighs 500 grams and has different colors on it. So basically the theorem will say, oh well, this algorithm will say, okay, this is a pizza. So basically all the attributes, all that I said, have the attributes of a pizza, for example. So even if it's not necessarily making sense, so it could be, for example, a cake. It could be, for example, I don't know, any other thing that is round with some colors on it. So basically, this is the main reason why it's called naive. But once again, it could be really useful in classification and as well as to understand some other things. So basically, it's one of machine learning models. And basically, if it's here, it's because it does a great job. So basically, how the naive Bayes works. So just to give you a small introduction to how it works, you not necessarily need to understand it 100%. So basically, you will start with calculating the calculation of all prior probabilities for a given class label. Then you will calculate all conditional probabilities with each attribute for each class. Then you will multiply some classes conditional probabilities. you'll multiply prior probabilities with the step tree probabilities. And finally, you will understand what class belongs to the given input set step, which in other words is the class that is with the higher probabilities. So you can have an example right here. All right, the next type of algorithm that we are going to talk about in this class would be the KNN, or the key nearest neighbor. So basically this algo is pretty simple to understand. So what exactly is this machine learning algorithm? So the key nearest neighbor algorithm is a type of supervised machine learning algorithm. So basically it can be used for regression predictive problems as well as for classification problems, but it's mainly used for classification predictive problems. So basically it's mainly used for this, but it can be used for both of them. So it could be used for classification as well as regression problems, but it's mainly used in classification. So the KNN algorithm has no specialized training phases and is using all the data for training while classification. So this is why it's really known as a lazy algorithm. So basically lazy learning algorithm, sorry. So this is one of the main reasons of why. The KNN doesn't assume anything about underlying data. That is why it's also considered a non-parametric learning algorithm. So basically, if there is two things that we can say about the KNN algorithm, is that first of all, it's a lazy learning algorithm, and finally, it's a no-parametric learning algorithm. So it can be used in many places in real life. So this is one example. So basically it's loans. Well, we have variables. So we have the variable loan, we have the variable age here, we have the variable non-default and default. So basically if the person have paid for its loan, yes or no. And basically it will use the distance between this point right here or any other point and the neighbors of this point. So basically the neighbors of this point, the closest neighbors will be this one, this point, and this point. And we are able to come to certain conclusions with this algorithm at the end. All right, another type of algorithm that we are going to talk about today will be the key means algorithm, which is a well-known unsupervised learning algorithm that is used with machine learning. So basically, what exactly is the key means algorithm? So it's pretty simple. As I said, it's an unsupervised learning algorithm that is used to solve clustering problems. So basically, this algo is uses a very simple yet powerful procedure to classify data through a certain number of clusters called K. So basically, K is a cluster. So the way it works, at first, we find the number of clusters and we assume where is the center of these clusters. So basically we don't know where exactly is the center, so we make an assumption at first. So basically that's the first thing we are doing when we identify them. Then we can take any object or the first K object as initial center. So basically to be able to find the center, well, not to find, but to assume a certain center, this is how we will do it. And then the key means algorithm will do the first, well, what it will do at first, it will determine the central coordinates. Then it will find the distance of each object to the center and finally group all the objects based on the minimal distance, sorry. So if we, usually it looks something like this. So as you can see here, all the objects are grouped together. And to be able to understand a little bit more, let's talk about some real life examples. So basically this machine learning algorithm could be used in plenty of ways. So some of the examples in which we can use it in real life can be, for example, document classification. So basically we can classify different documents in different places, for example. So this could be a really interesting way to use this algorithm. Another thing, for example, could be customer segmentation. So basically dividing customers into different types of customers. For example, customers that spend a lot, customers that use, I don't know, credit cards, customers that use debit cards, customers that pay cash, customers that comes once a week. So basically you can really segmentate your consumers. And another way, for example, in insurance fraud, so basically finding anomalies into insurance contracts, for example, or people who are trying to fraud insurances. So basically there are plenty of ways that you can fraud insurances. So basically people who fraud insurances, it's possible to be able to make a detection of those frauds by using the key means algorithm. Alright, so the last algorithm that we are going to talk about in this class would be the random forest algorithm, which is once again another really powerful algorithm that is used in machine learning. So for those of you who don't remember, we talked a little bit at the beginning of this class about decision trees, and this is exactly, it's the same concept, so it's a concept of decision tree, just made bigger. So let me explain. So basically random forest is a supervised machine learning algorithm that is used for classification and regression. So it can be used for both, but it's mostly used for classification problems. This algorithm works with decision trees, and there is trees in the algorithm. Well, the more there are trees in the algorithm, the more the forest will be robust. So in other words, here, for example, we have 4 trees. So it's more powerful than if we have 3 trees, but not more powerful if we have 5. So how exactly it works? Basically, you have decisions that are made in each tree. So basically, decisions are made in each tree, and it has to have the same outcome. So basically, each tree needs to have a certain outcome. So basically, choosing between A, B, or C. And basically, each tree will choose based on different mapping. Will choose a different outcome. So basically, the more trees you have that choose a certain outcome, well, the more this outcome will be robust or strong, and the more there are chances that this outcome is the best outcome that you can have based on the random forest. In difference that if we only work with one decision tree, we only will know what is the best decision based on one decision tree. But with a random forest, we are able to know what is the best decision based on many trees that will each of them will map different scenarios in different situations, and at the end this will be a way better way to find out the best answer to a problem. So instead of using only one decision tree, using a complete random forest. So if we want to think about it in a certain way, so basically this is just a decision tree that is upgraded. So we can see it this way. So basically it's more than one decision tree, and it's more than one decision. So this will simply confirm our answer that we have in one tree. Alright, so I hope you guys right now understood all the different types of algorithms that exist in machine learning. So those are just the examples of the most used and once again the most simple. So once again, I'm not expecting you guys to become a professional, so this is just a brief introduction. I can spend hours talking just about each of those algorithms with all the mathematical and statistical aspect of each of them. So I try to be as straight to the point as possible. So right now, guys, you have a complete idea of different algorithms that exist in machine learning. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So in the past few classes, we talked about all the different algorithms that exist, and basically we talked about the theory behind all of those algorithms. So basically right now you should have some basic knowledge about each of those algorithms. And right now we are going to practice writing them down on your text editor, which is PyCharm. So basically we're going to write down some of those algorithms inside of PyCharm. So pretty simple. Today we are going to start with linear regression. So basically we are going to create a linear regression model with arrays. So basically we're going to generate arrays and create a linear regression model. So for the purpose of this class, we're going to use NumPy to be able to make the calculations and work with arrays, as well as Matplotlib to be able to visualize everything that we will create. So let's start. So as always, the first thing that we need to do is import the tools that we are going to work with. And in this case, we are going to work with NumPy. So we are going to import it, and we are going to work with Matplotlib. Here we go. So .pyplot as plt. All right, so when we have everything, so right now we have imported everything that we need. So we have NumPy as well as pyplot. And as I said, the first thing that we need to do is create our arrays, because we will work with those numbers. So basically this would be our database to have our x's and our y's inside of the graph that we are going to create. So let's start. Basically, we're creating our x right now. So the value of our x, as I said, will be a array. So let's write it down. So pretty simple. What I'll ask you guys to do is to write down from 10 to 15 numbers. It can be random numbers. So you write down whatever you guys want. It doesn't have to be big numbers. It doesn't have to be small numbers. You guys decide what you want to write. All right. Next thing is writing down our y values. So right now we have our x values, and we want to write down our y values. All right. So once again, you decide what numbers you want to write down. And what we want to do right now is simply print everything to be sure that our arrays work perfectly, that we didn't make any mistake. All right, so let's run everything. All right, so right now we have our arrays right here. So as you can see, guys, everything works perfectly. Everything works fine. It's awesome. So next thing that we want to do, so if you want to keep your print, you can keep it. If you want to delete it, you can delete it. What we want to do right now is want to create a function that will allow us to generate those, to make the calculation for our, for our plot, not our plot, but our slope inside of our regression model. So we will do it by using the polyfit function. So basically we'll return an array of coefficients that will minimize the squared error. So basically how exactly we write it down is pretty simple. So we'll create a function that we'll call func1, so function 1, or you can name it whatever you guys want. So it's gonna be np because we are referring to a NumPy function, and it's gonna be polyfit. So inside of our polyfit function we have 3 arguments. So we have the x in our case, the y, so basically the database that we are going to use, and finally we have a number, so it's gonna be 1 in our case. So if we run everything, let me just print the function. I forgot to print it. So if we print our function 1 and we run everything, as you can see, this would be the answer of this function right here. So this is the answer that is generated. All right, so next thing that we want to do, we want to create our graph. So basically we are going to use a Matplotlib function, which is plt.plot. So we want to plot all our points. So as always, we are using x and y as data. And what type of points we want? It's pretty simple. We want small circles. So to have small circles, we'll just write down points. So we have a point. So if we run everything, let me just write it down, plt.show, right? Here we go. So we have our small points right here. So basically those points represent all the points that we have right here. And what we want to do right now, it's pretty simple. We want to add a line right here to be able to have a linear regression. Once again, the points right here are not really representative of something, but we will be able to have an average line in the middle right now. All right, so how exactly do we do this? It's pretty simple. We will simply add another function. So once again, we'll write down our plt.plot function. And in this case, we will need to use another function, which is the polyvol function. And basically this function will allow us to add a line that I'm talking about. So pretty simple. How do we do this? It's pretty simple. So we will need a few arguments to make it work. So we'll have our x, which will be part of our database. Then we are going to make a reference to NumPy, so np.polyval. And in this case, we will have our function. So we are making reference to our function, which is func1 and 2x. And finally, the last little thing that we want to write down would be r minus. And then simply show everything. So basically we have all the arguments that we need right now to be able to write down our function. So if we run everything, as you can see, we have our line right here in the middle. So the main problem of all this, so basically what we can see with this model right now is that there is no correlation between x's and y. So basically there is nothing that, there is no correlation between those 2 points, because once again, the points are everywhere on the graph and the line is just right here. So basically the line doesn't mean a lot, because in our case, the points are just everywhere on the graph. So basically there is no correlation between x's and y's in this example below. If, for example, the points were, I don't know, in a straight order, so basically let's say it's 1, 2, 3, 4 and etc., well, it would have been different. So let's let me just show you another data set. So let's say instead of all this, we have another data set that looks something like this, so more simple. So 1, 2, 3, 4, 5, and we rerun our app. So as you can see, it's a bit more representative right now. The line is a bit more representative, and it makes more sense because the points, the more our x grows, the more our y grows. So basically this is what we can understand from our graph right here. And it makes a little bit more sense that the past graph where the points were everywhere on the graph. So basically this helps us find a correlation between x and y. And in this case, we have a correlation. It's not a really strong correlation, but once again, we have a correlation. There are statistical ways to find the correlation between x and y, between x's and y's and the points on the graph. Once again, we're not gonna talk about this. So right now, you know how to create a basic linear regression model and how exactly you can evaluate this model. So that's it for this class, guys, and see you all in our next class. Welcome back to another class of our course about the complete introduction to data science. So in today's class, we are going to talk about another algorithm that is really present inside of machine learning. And in this case, it will be logistic regression. So basically what we'll do today is we are going to work with another tool that is pretty important in machine learning that is called sklearn. Basically, sklearn is a machine learning library that will offer you various machine learning tools that you guys will be able to work with. So basically you will have access to all the algorithms, so logistical regression will be in it. You will have all the other algorithms that we talked about a little bit before in the class in a more theoretical way. All right, so basically the first thing that you guys will need to do is import the sklearn inside of your PyCharm text editor. So as always, simply go on your file right here, inside of your settings, project interpreter, click on the little plus button right here and simply write down sklearn. So when it's done, it should be this one right here. Simply click on install package and you guys should be able to have it. So as you can see, I'm having it right here. All right, so when it's all done, the next thing that we want to do is really jump into it. So jump into what we are going to create. So for the purpose of this class, what I decided to do to make it the most simple possible is to work with confusion matrix. So basically confusion matrices will give us, will explain us more easily our model and will allow us to know how our model is good in terms of predicting something. So basically what I decided to do is create a really basic example. So when I'm talking about example, what I mean here is, let's say someone is looking for a job and this person it's a management position job, and this person needs to have experience in 3 fields. And basically, depending on the experience of the person in those 3 fields, this person will get a job or not get a job. And basically, we want to predict the fact that this person will, the accuracy of our system to predict if this person will get a job or not get a certain job, depending of its experience. So what I'm planning to do is with Pandas create arrays where we are going to store everything, well, basically databases, where we are going to create our own data set. So basically you will create your own database in this case. So what I suggest you guys to do is really use 25 elements inside of your database. And from this moment, we will create our little program that will be able to predict if yes or no our model works fine or no, well, if it's accurate or no. So let's start. So basically the first thing that we need to do is pretty simple. We need to import everything that we will need for our, well, for our class. So pretty simple, we are going to start with Seaborn. So we'll import Seaborn as SN. We'll also need Matplotlib to be able to work with graphs. Plotlib.pyplot. Then what we'll need also would be Pandas. We also would need some things from sklearn. So basically we will import them. So from sklearn.model, we want to import train test split. We also need logistic regression, since we are going to perform a logistic regression and show the results inside of a confusion matrix. So we are going to write it down right here. Here we go. And finally, the last thing that we will need, just correct it to be sure it's written correctly. Logistical regression. Here we go. And finally, we'll need metrics. So from sklearn, we would need to import metrics. All right. So right now we have all the elements that we need to be able to create our, well, basically our database. So for the database, it's pretty simple. What I did is, as I said, I created 25 elements. So the elements are already pre-created. So I'll just show them to you. So basically it's pretty simple. I have my candidate right here, or the person, let's call it person. I prefer person. So basically the person will have experience in finances, management, logistics, and finally, do the person get work, yes or no? So it's pretty simple. Once again, we have our person number one, and what we have here is how many years of experience this person has. So as I said, it could be 1 year, 2 years, 5 years, anything that you want. All right, so the first thing that you guys would need to do is create a simple database that looks something like this. And then what we'll do is we will simply put all this together and create a data frame where we are going to store everything. So when you guys are done, what we'll do, we will create a data frame that we will call data. And inside of this data, we are going to, with the help of Pandas, so basically we are going to refer to Pandas, we're going to create a data frame that will store person. So basically all the elements inside of person, and basically in our columns, we want to have finance, management, and logistics. So here we go. So inside of our columns, we want to have finance, management, and here, and finally logistics. And what we need also would be our get work. Here we go. Get work. All right. So right now we have everything that we need. The next thing what we want to do is verify if everything works fine. So we'll simply print our little data. So we'll print our variable data just to be sure that everything works fine. All right, so as you can see, it's generating perfectly right here. Everything works fine. So let me just explain the data to you. So as I said, here we have our years of experience for the three first of them. So finance, management, and logistics in years of experience. The next thing that we want to have would be zeros or ones. So basically 1 means the person gets the job, 0 means the person doesn't get the job. So it's pretty simple to understand. All right. So right now that we have everything that works here, it's time to get to the next step, which would be creating our logistic regression in Python. So for our logistic regression, what we'll need is pretty simple. We'll need two variables that will be x and y. So basically they will be inside of our graph. So for our variable x, what we'll have is pretty simple. We'll have the elements finance, management, and logistic as well. So what we'll do right now, we'll simply make a reference to person. So we'll write down our variable person. And from person, we want to use, in this case, finance. Management. And finally, logistics. The second variable that we'll have will be the variable y, and this, let's put it in small letters. And this variable will store get work. So basically, once again, from person, we want to have get work. So if the person gets work or no. All right, so right now we have our model. The next thing would be creating our test, well, using the test split function to be able to test everything. So basically we are going to decide what percentage of the database will be used for testing and which one will be used for training. So pretty simple. How exactly do we write this? We simply write down x. So we'll put it right here. X train, X test, then Y train, and Y test. All this would be equal to train, test, split. So basically what I'm writing right now is how much I want for my data, how much I want of my data set to be used to test, and what percentage of my data set I want to be used for training purpose. So basically I'll finish writing and I'll explain everything. We'll have X, Y. So we'll have our test size. So in our case, we want a test size of, let's say, 30%. So this means that, we'll put 0.3. So this means that we want we want to use 30% of our data set for testing purposes, and the other 70% will be used for, training purpose. And the second one will be random state, and this one will be equal to 0. All right, so when it's done, so right now with this line of code right here, we are able to say what will be the test split, so how much would be used for testing purpose and how much would be used for training purpose. So we have everything that we need right there. All right, so when it's all done, the next thing is pretty simple, is writing our logistical regression model. So it's pretty simple. We'll do it down there. So it's gonna be logistic regression. So in our case, let's call it logistic reg, which would be pretty simple. And logistic reg would be equal to logistic regression, since we are applying logistic regression to it. So this would be our variable in which we are going to store the function logistic regression. All right, then the next thing is pretty simple. Let's call it LR. It's gonna be smaller and more easier to work with. So we'll have LR, which would be equal to logistic regression. We will not have to write down each time logistical regression. So we'll have LR dot fit, since we're fitting right now our training of X and Y. So X train as well as Y train. Here we go. X in capital letters. All right, so right now we have everything that we need. Really important not making mistakes. All right, next thing that we need is we want to predict our regression right here. So Y. In this case, we'll call it prediction. Will be equal to, in our case, logistic it's LR. So will be equal to LR dot, and what we want to do, we want to predict the test of X. So in this case, predict X dot test. Here we go. So basically right now we have everything that we need to be able to run our model. Then the next thing that we want to do, since we want to put everything inside of a confusion matrix, we will create our confusion matrix right now. So basically our confusion matrix will be created with the use of once again Pandas. So pretty simple. How exactly do we create our confusion matrix? We need at first to create our variable, which would be called conf mat. So let's call it conf mat. Let's use small letters as well. All right, so in this case, we'll have confusion matrix, and the confusion matrix will be equal to, in this case, so we'll have our Y test as well as our Y prediction. Then we'll have our row names. So how we will call our row names inside of our confusion matrix. So in this part of the code, we're creating our confusion matrix. And as I said, here we go. So right here, as I said, what we'll do is we will give row names to our rows. So pretty simple. Let's do it right here. So row names, we'll have row names. So for the first row, we will have right there, let's call it, I don't know how we can call it. We can call it, so it's right now. So basically true results, so true. And for columns, since it's everything that will be predicted, let's call it, I don't know. Let's call it provisions, since this is what will be predicted. So we'll call it prevision. All right, so we have everything that we need. The next thing that we need to do is we are going to use Seaborn to create our confusion matrix right now. So pretty simple. Sn dot heat map. So basically in this case, we're going to use a heat map to be able to see everything, well, to be able to see it more clearly when our confusion matrix will be generated. And in this case, we are going to apply our heat map to our confusion matrix. So you'll see it's going to be something that is pretty cool. In this case, we'll call it conf mat. All right, so we have everything that we need, and annotation is going to be true. All right, so we have everything that we need. And finally, the last step will simply be printing everything. So basically, we want to print absolutely everything. So print accuracy. So here we want to print our accuracy score. And here we'll have our y test. So we'll have our y test and what we have predicted for our y as well. So here for our accuracy score, we'll have our y test as well as what we have predicted to our y. So training and predicted. So the variables that are right here. Here we go. It's gonna be y test. Also here we'll have our y train as well as our y predicted. Here we go. So right now we have everything that we need. So very important, a really important part of when we have done doing all this would be correcting our code because usually when we write down a huge code like this, it's really important to correct absolutely everything that we have just done. All right, so the last step will simply be writing down plt dot show to be able to see everything that we have. So what we'll do right now is we are going to run everything to see if it works perfectly, and if not, we're simply going to correct mistakes inside of our code. So if we run everything, okay, we can see that there is a mistake. So 0 size array to reduction operation if min which has not identified. So what we'll do right now, we'll simply look at our code and try to find the mistakes that are inside of it. What could be the mistakes that usually happen? So usually the mistakes that happen in those types of code will be basic mistakes. So I already see some of them. So basically I can see it right here. So we have y test that should be here. Well, we should have y prediction that is right here. So we have this mistake right there. Okay, so basically the mistake that we have is pretty simple. So we have here y test, y train, and here we should have y prediction instead of y train. So here we'll write down y prediction. And finally, the other place where we should have y prediction should be here. So this is exactly what we will do. So we'll keep our y test. And we are going to write down our y prediction. All right, so normally right now we should have everything that we need. And if you guys you have an error inside of your code or whatever, you can simply copy my code right here. It should work properly. All right, so at the end, this is the result that you guys should receive, and this is a perfect result of usually what you guys should have. So here you'll have your accuracy. So basically the accuracy of our model is 75%. So we are able to predict at 75% how many people will be, well, how many people will get the job and how many people won't get the job. How exactly does it predict 75? So it's pretty simple. The calculation of this is the true. So basically what are what is the true? So basically the true positive, we can say it this way, and versus the provisions. So basically here we'll have our provision. So basically provision of a yes, provision of a no. So here we'll have our true yes a true no right here. And basically how we make this calculation, it's pretty simple. So we are going to make an addition of what are all the provisions that we have made that happened. So basically it's going to be this one right here and this one right here. Versus all the provisions that we made that basically didn't happen. So basically we made 3 mistakes right here and 0 mistakes right there. So it's simply going to be 8 plus 1 and all this divided by the number of provisions, which would give us 75%, which makes pretty much a lot of sense. So as you can see, this is how we are performing this type of regression. So as you can see, it's not, well, yes, it could be complicated, but at the end of the day, your goal is really to have this, to see how accurate is your model. So in our case, it's simply going to be 9 divided by 12, since we are going to make 8 plus 1 divided by the, well, all this. So basically 8 plus 3 plus 1. That should give us 75%. And 75% of accuracy is pretty good for this type of model. So as you can see, this would be the first model that we will create right now. So the first machine learning model. So this is the code around it. So basically, I tried to make it as simple as possible, but it's pretty normal that you guys have mistakes in a code that is big like this. But once again, if you guys still have mistakes, pretty simple, just screenshot my code and you can simply retype it and you should have everything that you need. So that's it for this class, guys, and see you all in our next class. To another class of our course about the complete introduction to data science with Python. So until now, we talked about many interesting things that are around data science, and in today's class, we are still going to talk about machine learning and some algorithms. So the goal of this class today would be to create another machine learning algorithm, which would be the k-means. So for the purpose of this class, what we'll do is pretty simple. We are going to generate random numbers and we are going, well, random points on a chart, and we are going to define the center of those random points. So you'll see it's pretty simple to do. And once again, it's one of the algorithms that we are going to learn, we are going to learn to work with. So let's start. So pretty simple. For the purpose of this class, we'll need to import some tools. So basically we'll need to import NumPy. So import NumPy as np. We also need to import Seaborn. We will need to import Matplotlib. Here we go. And we will need also to import, well, since we're working with sklearn, we will need to import k-means, the algorithm that we are going to work with, and also make blobs, which is a tool that works with k-means to be able to generate random numbers. So pretty simple. So it's gonna be from sklearn dot cluster import k-means, which would be the first thing that we will import, and also we will import from sklearn dot data sets dot samples generator import make blobs. Alright, so right now we have all the tools that we need to be able to work with all this. So the first thing that we are going to do would be writing our, creating our points. So pretty simple. Well, we are going to write them right here. So we'll have our x, y, true, would be equal to, in our case, make blobs. So the first argument that we'll need is the sample size. So in our case, what will be the sample size that we are going to work with? Let's say we will need a sample size of 800. So basically you guys can decide of the sample size that you want. So in our case, we are going to work with the 800. So n samples would be equal to, let's say, 800. All right, then you can decide of the number of centers that you want. So let's say we want, I don't know, let's say we want 5 centers. So we have 800 points, 5 centers. Then cluster STD. Let's put it at 0.45. And random state, it stays 0. Random state would be equal to 0. All right, so we have all our arguments to be able to make it work. Then we'll use a scatter plot to put everything together. So we'll write it down right here. So PLT, since we are making reference to matplotlib.pyplot, scatter in this case we'll have our x, here we go, then we'll have our x for 1, in this case 2 points, and 1. Then we will define our s, so what the value will give to s. So let's say in our case we'll give a value of I don't know, 30. All right, so right now we have everything that we need. Don't forget your commas, it's pretty important. All right, next thing, we are going to create our function. So right now it's time to create our function. So as always, we should give a name to our function. So let's say we are giving to our, we are naming our function like always func. So let's call it func. And what's the type of function that we are going to work with? It's pretty simple. We are going to work with key means. So as always, key means the function is just here. And then we can decide of the number of clusters. So in our case, the number of clusters that we want to have would be, let's say 4. And clusters. So we want to have 4 clusters. So basically 4 groupments of points. All right, next thing, we are going to fit our function. So we will use the fit function for this. So we'll have our func dot fit, and we want to fit x. Here we go. All right, so when everything is done, we want to give a y value to our function. So y func, and what we want to do right now, we want to predict our x. So basically we are going to predict our centers. Func.predict. All right, so right now we have everything that we need. Next thing that we'll do is we are going to, well, make our graph a little bit more beautiful. So what we want to generate would be a platter, well, will be a scatter plot. So plt.scatter. So in this case, it's going to be the same thing as here. So we're just going to come here and copy the elements right there. Then we'll need to give a c argument to our function. So the c would be the y function right here. So it will be a reference to this function right there. So basically it's going to be func.predict because we want to predict our x in this case. Our goal is to predict the x or to predict the centers. And finally, we'll have our s that will be equal to, let's say, I don't know, 15. All right, then what we want to do, well, we need to add centers. So in this case, we're gonna write down centers. Here we'll have our centers. And finally, the last thing that we'll do, we'll simply write down our scatter plot. So basically we will write down what color we want our centers to be, if we want them to be really bright or not that bright, and all this type of stuff. So pretty simple, we'll just write down. So if we want, we can write down the plt.show function now, but we won't do it. So plt.scatter, and here we're going to write down our centers. Here we go. So, and here we'll have our centers. That would be 2 points, 1. So the color that we want, so for the C, it's pretty simple. It's the color that we want. So basically what color we want the red color. Let's put red. So if you guys want a blue center, you can write down blue. If you want a white center, you can write down white. So we want a red center. For our S, we want it to be not 100 because 100 would be really, really bright. So let's say we want it 75. And finally, the alpha will be 1. All right, so right now we have everything that we need. The last thing would be simply showing our plot. So basically plt.show. And we can just run our app right now. And as you can see, we have everything that we need right here. So basically we have our center of, we have all our centers that are generated. We have our 800 samples. So basically, as you can see, 800 samples. As we said, we want 5 centers. So basically our centers, it's right here. It's divided in 5. So 1, 2, 3, 4, 5. Since we selected 4 clusters, it's gonna be only 4 centers that will be created. So we have 1, 2, 3, 4. If we change it to 5, for example, you'll see it's gonna change as well if we rerun the app. So as you can see right now, it became 5. Also, for the color, as you can see, we selected red, so it's all red. So basically it works pretty fine. And for the S, so as you can see right here, S is simply how you want it bright. So right now we have it pretty bright. So if we put, for example, 0 right here, we won't see the centers at all. So basically this is just to make it a little bit more beautiful. So what does this tell us? It simply tells us where exactly is the center inside of, the center point inside of all the points that we have right here. So basically what it does, it will simply find the center point. And what we have done with the function right here, we have generated a random point. So basically we have random points a bit everywhere on the graph. And from those random points, we simply have found the center of each of those random points. So those are the basic functions that we are going to talk about in our machine learning part. So right now you guys should be able to create your own, your own little function, your own machine learning little systems, really basic systems with those functions. So you have really the basics and the introduction to be able to work with those basic systems. So that's it for this class, guys, and see you all in our next class. Hello guys, and welcome back to another class of our course about the complete introduction to data science with Python. So today's class is our last class about this amazing course about data science, and I really hope that you guys have learned a lot of things right here. So basically what we'll do today is we are going to make a quick summary and simply talk about the course in general. So first of all, what we talked about in this course is pretty simple. We talked about all statistical concepts that are really used for data science. We talked about the different tools that can be used for data science, such as NumPy, SciPy, Matplotlib, Pandas, Seaborn, and others. We also had a little introduction to sklearn and talked also about machine learning, so basically all the different algorithms, and even worked with some of them. So once again, right now you guys should have a really good introduction to data science. So basically, what exactly is data science? What are all the tools that you can use for data science when you work with it in Python? And basically everything that is around data science. Yes, you are maybe not a professional of data science, but once again, you have all the basic knowledge to be able to pursue your career and even make small projects in data science. So right now you have everything that you need. Besides of that, I'd like to thank you all for taking this class. Once again, it was an honor for me to be able to teach you. Yes, of course, there are plenty of concepts in data science that are not easy to understand well, when you are the student, but also not easy to teach when you are the teacher. So once again, I hope you understood everything that all the information that I tried to transmit you guys. The course in general, I tried to be as straight to the point as possible, so not playing around and just talking for talking. So I tried to be as straight to the point as possible and explaining the concepts the best that I could. So besides of that, I hope you guys liked the course in general and you liked my style of teaching. So if you really enjoyed my style of teaching, don't hesitate to check out my other courses. So I have plenty of those right here. I'm pretty sure you would like it. And if you want to learn a little bit more about Python, you can check out my Python course. You should probably love it. Besides of that, thanks again for being here and supporting me in this teaching adventure and being part of it as well. And see you all in my other courses.